Hey, hi folks. We have got Sharat, Sean, and we have got Vishwanath. So, got some time yesterday, Sharat, to try the different examples, buddy.
Uh, I'm right now trying it, Venkat. Actually, I did not.
That's okay. No worries. So, just try the examples and let me know in case if there is a concern, Sharat. Okay.
Sure. Yeah.
Thank you.
Thank you.
And were you able to practice Sean and Vishwanath? Okay, maybe it's a little bit early. They haven't come in until now. No worries. We'll wait for the others to come in.
Yeah, very good. I'm actually waiting for the others so I can get everyone together.
Yeah, that's correct. Yeah, because normally people do come in. It's about 9:30. Yeah, yeah. A couple of guys have joined, so they normally come in about 10 minutes next. So we should have the complete audience by about 9:40 or so. So guys, it's about 9 o'clock your time. I'll just wait for maybe another 3 minutes to 5 minutes for the others to turn up. We have got Venkate and Natesan also. Friend, were you able to practice the examples that we have done yesterday, dear?
Yeah. Yes, Venkat. Yeah.
That's great. And how's it going for the 2 days? I hope the concepts what we're explaining, you're following that. And this document is always very helpful. The docs page, so that you can go back and see the steps also. That will be helpful to you, friend. Right?
Yeah. Yeah. Yes. Right. Yeah.
Yeah.
Thank
Sure. Sure, buddy. And others, while you're here, maybe what you can do is the complete set of what we have worked with yesterday. I have put it on the Google Drive so that you can download that. And you can also download the materials for today. And you will have to install the Postgre database also on your system. So I've got everything ready over here, friends. So today during the morning session, you can go ahead and do that. Sure.
Hi, this is Vishnath.
I was talking on mute, Vishwanath. Vishwanath, we had just said hello to the others. Maybe you just stepped in right now. Got a chance to finish off with the examples. We were supposed to do about 4 examples. Got a chance to finish that.
Yeah, I ran those.
That's great, friend. So you can understand those things. Hi, good morning, Ashima.
Hi, good morning.
Yeah, got some chance to work on the exercises of yesterday, dear.
Yeah, so I completed 9 and 10. I wasn't able to complete 11.
Yeah, because deliberately there were some things left out in 11. So that is what I have just mentioned it over here. When we do the filtered by, you have to just add some things to ensure that the filtered by works, But if you copy paste the code and you can try that, that should definitely work. But then there are some changes to be done. So just have a look at that and you can understand those things. So how was
Okay.
it until now, Ashima? The 10 examples that you ran, all good, so far so good, Ashima?
Yeah, yeah, and the book you shared, it helped in understanding because I got stuck with some concepts and everything.
Okay, no worries at all. And like I had shared the details, you can of course mail it at any time and ask me any questions what you have. Even post this trainings for the next 2 weeks, you can post it. But then since we're there in different time zones, I'll be able to reply back to it during my time zone here because I'll be on road for the next 2 weeks. But then you can ask me the questions. No worries on it, Ashima.
Sure, thank you.
You're welcome. Hey, hi
Um,
Nick. Hi Akhil.
can I take a moment?
Yeah. Nick, you can go ahead, please. Thank you.
Hi guys, this is Nick from the operations team at Yola. I just wanted to check with you guys on the training so far. How's it going? And or to hear from you on any feedback that you might have for us or Venkat.
Hey, your voice was kind of breaking out and we couldn't hear you properly. Could you please come again?
I was hoping to get some feedback from you guys on how the training's been going so far.
I mean, for me, it's going really good, and he has been so patient about every concept we are learning. Yeah, so far so good. I mean, I'm liking it.
How about the rest of you guys?
I'm sorry?
I was asking the rest of the guys, how about them?
Oh, okay, yeah.
Yeah, I agree with Ashma. Same.
I think, Nick, your voice is a little bit low over here, so that might be the reason people are not able to hear you. Over to you.
Yeah, I think that might be my new microphone. Let me just try to switch it up.
Okay, sure. So we also have got Mati who has come in, and we have got Akhil also who have joined us. Hi. Got some time to try the hands-on on the stuff that we have done yesterday, Mati?
Yes, Venkat, I was able to do it.
That's great. In the last example, you would not be able to see some of the values. So I have just put it in the Google Doc, some small changes, what we can do, and then that can work out. So just have a look by adding these changes, friend. Hey, hi, Brandon. This thing, were you able to practice the hands-on what we did yesterday, Brandon?
No, I just finished up to that last what's that? 6.
The group by key? Yeah. Okay.
No, I haven't completed the 7. I had to drop off for some.
That's okay. That's okay. No worries.
I'll catch up. Yeah, I'll catch up today.
Sure. So all that I want from all the others is to just catch up on these things. Whatever doubts you are having, feel reassured to ask me those doubts so that I can answer that, because today we are going to go ahead with a completely new set of things. I have given the stuff that you needed. Whatever is the complete projects that we have done yesterday, I have kept everything available for you as a download for yesterday. Then we have got the download link for today's material. Okay, so I'll just put it over here. Day 3 materials, you can download those things, and you will also have to install the Postgre database, the SQL part of it that we'll be working on, but that will be later on in the day. So whenever you get a chance, you can download those things and keep it ready. So in about a minute's time, we should get started. We have got almost everybody. So that's great. You had a question, Martin, or we are all good?
Oh, yeah, we are all good. No, I was on mute.
That's okay, no worries. And then we have got Akhil. Akhil got some chance to work with the hands-on about yesterday, Akhil?
I did, but I still need to catch up. Like Brandon was saying, I had to drop off for another important meeting that I couldn't skip. So
Okay.
I'll catch up today.
That's okay. So try your best to see what things are. And like I had mentioned to Ashima also, even after the training for the next 2 weeks, because we'll be again meeting back in the 3rd week of this month. So the week of 28th, we are having other sessions. So even in the next 2 weeks, I've shared my mail ID. So feel free to be in touch and I can help you out. No worries on it.
Sure. Thank you.
Thank you. So I think we have got almost everybody. Let me just have a quick look over here. And we have got Akhil, Ashima, Brandon. We have got Mati, Sharat, Sean. We have got Vishwanath, and we have got Venkatesh. I think Kalyan is pending and Igor is pending. But I think we should get started, friends, for the people who have joined in. So they should be able to join us soon. So this is what we have done as Eclipse projects. So what I have done is I have done all the examples that we have done till yesterday. So let me open up yesterday's document so that you would know what was the last example that we had to do. So just opening up yesterday's code. Let me go down to the end of the document. Just once again. Control End, and that was our example number 11. So all the 11 projects you see over here, I have got it and I have tried it out and I have shared that with you so that it will be easy for you to download those things and keep it ready. The only challenge what you will face is those projects might, because since I have done it using external jars, you'll have to just change the directory to point to where you have got all the Spark jars. So that's the only thing what you'll have to do. So we saw all the examples. In the last example, some small changes needs to be done. So I have given those changes over here so that you can try out all those things. So what we have done as of now is we are finished off with the Spark core part of it. So today we will be focusing on the next part. So all the contents for today, the material, that is a Word document that I'm walking through. So this is going to be day 3. So let me close the Spark Java 1, and this is what is going to be day 3. So this is the document that I have. So this is what you will be seeing, folks. So please have this downloaded, and this will be about another 19 pages of stuff that we have to cover up today. So we will be, let me just tell you the flow of how we will be doing today. So the plan of action for today would be we will talk about accumulators, some advanced concepts what we are having, accumulators. Then we will talk about something called as broadcast variables. So let me just tell you the flow of it. So accumulators are there. There is an example of that. So we'll be starting with example number 12 for today. The data sets and everything is what has been shared with you. So see, this is the day 2 that we did, and I have got the day 3 also. So the complete Word document, and there are 6 data files that is also being shared with you. So like what we did yesterday, we'll create a, sorry.
Venkat, day 3 that you shared gave me day 2 content actually.
Yeah. So it looks like it's a duplicate of that day 2.
Okay. I'm really sorry about that. I think let me delete that right now. So that is day 3, my dear. Let me open it. I'm surprised because I checked it was day 3. Let me check it right now.
Yeah. For me, it works at day 3 inside.
Hey, thanks, Igor. So it is day 3, friend.
Yeah.
Let me download it once because we never know. Maybe I would have done a small mistake in giving you the old doc. So it has downloaded. Let me say start download. And it will be there in the D drive. Yep, there it is. So let me open it. It is actually day 3, my dear. It's not day 2. Maybe the link would have been confusing. It is actually day 3, friend. So let me delete this day 3 because I already have that over here. So Igor just confirmed that, and I just tested it out myself also. It was actually a day 3 content, friend. So please try to download this. Just one second. Let me move my the chat window a little bit so I can close this. I can close this. So this is actually day 3 content, Sharat. So I will just copy this and put it for you in the chat so that it will be easy for you. There we go. There is no chat.
I will download once again and check.
Yeah. Please download it once again. I'm sure it is the right content. What's happening? Where is the chat not opening? Yeah. So just ensure that you again select this. So the day 3 link is the new link what we have, and later on whenever you get chance during the break or during lunchtime, we will have to have the Postgre downloaded in Windows for some of the people, and for the other folks we should have that in Mac and have that ready for us. So that's what you should be doing. So that's great. So Igor, you're back. So we're just talking to the others, Igor. So I hope the things are all clear for you until now, right, mate? Any confusion or any doubt, buddy?
Yes. No. Everything good. Thanks.
Okay, great. Thank you so much, Igor. So let me just close this. So that's perfect. I will close my participants window, and let us start with our plan of action. So what I was saying is today we will start with our accumulators, some couple of examples, and accumulators we needed to see the job history server, so we will have to do it in the image also. You see that I haven't started with the image right now. So then the first example, we will be simply doing it in Eclipse and Windows. Later on, we will have to move it to our image. And then we will go ahead and first was broadcast variable. Then we have got accumulators. Let me scroll down. So this was again broadcast variables. Again, some examples of broadcasters there. So for the UK spaces, etc. So all those things are done. Then we will talk about caching and persistence. That is the third advanced topic what we have in addition to what we have already learned. So if I just plan to summarize what we have done in the past few days, we saw how to set up the items, that is the image, the Vinicity or FileZilla for our Mac users, the PuTTY environment. We need all these things to be done, how to set up these items in our personal system. Then we saw the very basics of Hadoop, that is HDFS, how to start the services. What is that? Because the idea is not to focus a lot on that, just give you the basics that is necessary for Spark. After that, we spoke about what is Apache Spark, and we saw that you can do a lot of things in Spark, and we focused on the Spark core yesterday. So we discussed on day one what is Apache Spark. We saw the architecture of Spark. Then we started with one example on Scala. How did we go ahead with it? So this is what took the first day completely. Then yesterday we did our examples of Spark core, about 12 examples if I'm correct. Let me just go back and be clear on it. Sorry, not here in the document. Let me scroll up what was today's example starting from. Yeah, 11 examples. So we had done 11 examples as of yesterday. Let me go back. There we go. Okay, so examples on Spark core. So the 11 examples is what we had seen yesterday, and this was all related to the various transformations plus actions what we have. And a strong suggestion would be to look at lovely transformations .pdf file. That's what I had shared with you later on in the evening. Okay, this talks about the various transformations and actions that is explained by the creators of Apache Spark, that is Databricks. Because since I had officially attended a training with them, this is what they have shared, and I share it across with all the people in all the trainings that I meet, because it's a fantastic document. So that's something that you will have to look out for. So this is what we have done yesterday. And let's start with today. After this, we will talk about caching and persistence. What are the different levels of caching? How do we go ahead with that? Let me go down to the document and let me scroll down. Just once again. So this example we saw, broadcast variables. After that, we spoke about what is caching and persistence, some examples of that. Then we will talk about joins. What are the various join, the left join, the right join. So whenever we have got two data sets which has got some similar keys, the columns will be similar. How do I go ahead and do the join? And then we will see how to go ahead with the joins in Spark SQL also. So that's what we will be starting today, and tomorrow we'll continue on with that. So we'll talk about joins in our RDD way of doing it. After joins, let me scroll down to see what are the next thing that we have. Then we will talk about the very broad architecture discussion, and then our focus is going to be on data frame and data set. We'll talk about data frame and data set. We will be using, since we are using Java, we will primarily be using data set. In case if you are using Python, data set is not as available for you. Data set being a programming way of doing things, it is only available in Java and Scala. So for Python and for R, you will typically work with something called as data frame. So we'll talk about what the differences are and see here, what is the difference between RDD that we have been playing till now? What is a data frame? What is a data set? There are about 8 levels of differentiation. Then look at what the SQL is going to do, the data set and the data frame, how does it work? What is it from a Java perspective, from a relational database perspective, and then talk about how do I make it run in my standalone Windows application. And then we will have to have our Postgre database so that we can insert some values into the Postgre database also. And of course, in that, it will be done via a pom.xml. So the pom file is also shared with you. And see here, you will have to have the administration utility for Postgre. And that is what I had just tested it. See, this is what the administration utility would be. If you look at the database and if you look at the tables, see here, I've got different tables that is already there. Of course, I can fire a query and I can do that. So this is the place how we will work with our Postgre database. See, some screenshots are given to you and you will see how after inserting something, we will check it out. And then one more example, just to reinforce your concepts, a new table is what is going to be added. So that is the complete length of what we are going to do for today. So let's get started. So first thing, we are going to start with our accumulators. Before we actually go ahead, I have individually spoken to a lot of our other colleagues and they are reasonably okay with what we have done. Just wanted to check with the others. One second, there is no window. I'm opening too many windows. Yeah, so in case if you have any questions, please let me know. Let me go back to the manage participants. And I think only Kalyan is missing. Other than that, all of you are there. And if you have any questions on the 11 examples that we did yesterday, now's the right time to go ahead with it. So in case if you have done, that's good, understood, that's nice. We'll start with our next set of 10 examples for today, friend. Okay, nothing until now. So you guys have read that. If you haven't practiced, please do so, because there is no substitute for practice, friends. So please go ahead and do that. So that's perfect. So today, let's get started with our first topic that is called as accumulators. So let me go down to my document and let's start with it. So we will be talking about the advanced concepts of Spark. We are still with our RDD. Okay, so that means we are doing our Spark core. So on day one, I had mentioned that we can work with our Spark core. Then we will move on to our Spark SQL. That's what we will be doing in the day today towards the end of the day 3. Then we will continue with our Spark SQL tomorrow, finish up all the different concepts, and then start with your Spark streaming. So once you finish off with that, on day 4, we will talk a little bit about machine learning and maybe a very small exercise on graph-based computing, graphics. And then we will try to put all these things into a small project and try to work on that. So that is what we will be doing. So we have done 2 days. We have got 3 days left. So I'll be going at the same speed how I was going yesterday, friend. So the main thing for you is if anything goes wrong, please bring it to my notice. So let's go down to accumulators and see what is accumulator. So let me go down to the link what I have provided over here, and let me go back to the page. Let me paste it so that it will take us directly to the accumulator. There we go. So let's see what it is. So accumulators are primarily variables that are only added to an associative or commutative operation, and therefore it is very well supported in Spark and it can be executed parallelly. So I'm a little bit confused. What do you mean by associative or commutative operations, friends? So what is associative or commutative operations? Anybody, friends?
Anything that can be collected as a group, at the same time, anything that can be added, summed up, committed.
Maybe a small example. What you're saying is fairly close, Sharad, to what it is. So maybe if you can just give an example, that will be better off.
For example, there are 10 elements. And,
let's say 2 elements. So yeah. if I say A plus B is equal to B plus A. However, A minus B is not equal to B minus A. Okay, so this is one answer. The other
Oh,
answer.
okay. Sorry, I was thinking in a different way. Okay, you are this is different. Okay, yeah. So associative is like okay, commutative is yeah, A plus B equal to B plus A, and associative is like
Let's say
A
A
plus B
plus
plus
C
C,
in
yeah,
a bracket. What I say is
equal
equal
to
to,
A
yeah,
plus B plus
plus
A.
C. X plus C.
Plus
That's
A.
right. No, plus C. Sorry, my mistake. This
Okay,
should have
yeah,
been C.
plus C. Yeah, that's right.
Okay.
Yeah.
Yeah, that's right. So this is what is an example of associative operations, wherein if you have three elements, I can put the bracket in any fashion, and it should be able to work. And when we say commutative, this is what it is. However, A minus B is not equal to B minus A. Okay, so this is what is associative and commutative when we talk about the operational aspect of it, friends. Okay, so the main thing in our accumulators is it should be done through an associative or commutative operation. The main purpose of this is that it will be used to implement counters. Okay, so that's the primary purpose of it. Just once again, dear. Back again. Because my son had come here asking for something, so I just told him. So that was the reason. So this can be done to implement counters. So what we have done in MapReduce, there was something called as counters, which will give me some statistical information. So that is the way how accumulators are done. And primarily they are for numeric types. Of course, you can create your own custom accumulator also from the new version that is possible. And we can see the accumulators in the 4040 page. But then we are not working with Scala in a REPL mode. So we can see it in 18080. That is the history server. Okay. So you can see the accumulators, the sum saying, and if you drill down at every individual system, that is a worker node, you can see what the accumulators are. It will give you a grand total, and you can see what it is at every individual node also. Okay. So tracking accumulators can be useful for understanding the progress of the running stages. This is still not in Python, but then in Java and in Scala, it is possible. So that is what is accumulators. So let's go back and see how they are used. Okay, so we have got a file that is called as a 2016 Stack Overflow Survey Responses.csv. Let me open up that particular file. And in this file, we'll be interested in the third column, which would be the country column, and the 15th column, which is the salary midpoint column. So let me open up that particular file. I've already shared that with you. So if I double click it, it can open up in a normal editor also, or it can open up in Excel also. So this is a column that I'm interested in. And if you see the number of records, what I have, I've got about 2000 records. Okay. And I'm interested in the country column. Just once again, too many options. And I'm interested in the salary range also. So that and this column is what I'm interested in. Two columns is what I'm interested in. Okay. So let's see how do we use this. So from this,
Do we
have
have
to see.
2019 one? Sorry.
No, what was that? I'm sorry, I missed it.
No, 2019 file, we don't have it. Survey results.
No, we don't have it, friend, because this is typically given by Stack Overflow. So over a period of time, they give you the results. It's still about 2 years. 2018, I should be able. Sorry, 17, I should be able to get it. So you can actually try that out. The various countries and how is the range in the individual countries, you will see that and it changes, and it's pretty realistic. So you can keep a benchmark about for a technology, what would be the general figure of what should be the salary pick point, what you should ask for. So it is pretty reliable because this is all genuine records what Stack Overflow does. So you have it. I know I have seen the 2018, but I don't think so. I have seen, sorry, 17. I don't think I have seen the 18 and 19. Definitely we don't have it as of now. So because only after the year gets finished, they will try to do it here. Okay. So we are sticking down to this particular file. What I want is, how many records do we have in the survey results? So pretty simple. I just scrolled down to the end. I saw that there are about 2,000 records. Then how many records are missing the salary midpoint? That means I don't have the value for that. And you can see here, record number 4 for the country called as Afghanistan, that is missing over here. See here? So that's what it is. And then I want to see how many records are from Canada. I just picked up Canada as one of the countries. You can pick up any other country also. Okay, so this is what we are trying to read from our data, and we will see how does accumulator work over here. So the first example for today is example number 12. The data file is over here, and we will have to put it inside the in folder like what we have been doing yesterday. And this is what is the Java code. The first one, of course, like you suggested yesterday, I'm sorry, let me put back with the names. This Sharat. So Sharat, you said that we should have it as org, right? So that irritating thing will not come. So that's what I have implemented. So we will get the logger for log and set it at error. Then as usual, create a Spark conf, give the application name a Stack Overflow, and then decide the amount of masters you want. We have got 2 cores. I've only set it as 1. Okay, you can set it as 2 if you want. That's okay. Create a Spark context and then create a Java Spark context. So this is what is the standard template code, the first 4 lines, what we will always have in our code. Let me just expand this a little bit more. That's better. And then we will go ahead and create our accumulator. So what I'm going to do is we will have to instantiate the accumulator, and the accumulator we are creating is accumulator for total and for missing salary midpoint. So these are the 2 accumulators that we are having. You will have to register this accumulator with your Spark context also. So you will have to register it, and this is the name what you will have for it in the accumulator list. So just once again, friend. So when you run this, you will actually see this in the accumulator list like this. See the total and the salary midpoint. Remember, we have 2,000 records. So this is what the answer what you'll be seeing. So in the first example, when we run it, you will not see this answer because we're doing it in Windows. So we can't start off with our 18080 page. So that's why we'll create a jar file and then move this file into our Ubuntu environment, run it and see this. So that's how we should be able to see it. So I register my total and I register my salary midpoint. Then I create my first Java RDD, that is via the same text file like what I'm doing earlier. And see, I'm pointing to my in directory. Okay, so when you're trying to do it on the shared location, we can say /input because we want the file to be in HDFS. The first example, we are just having it, running it within Eclipse itself. Okay, so that's why we did that. Then I create a RDD called as response from Canada, and I do a filter. That's what we did yesterday. And then what do we do here is I will look at the split. Again, it is going to be using the same utils, comma delimiter, standard regex code that we did earlier. Okay, and then I simply check. First, I will, the moment I enter into it, I'll simply add it to the total. The reason I'm adding it to the total is because for every record, I will be going inside the filter, right? So I'm simply adding the total. Total is nothing but the total points what you're having. Okay, so that is what is the total. How many applicants are there? So we have 2,000 applicants, right? So I increment that. Then I say, if my splits 14 is empty, that means I don't have a record, only then I will add my salary midpoint. And then it will return me from my $2. So let's go back to the example. And we have got 0, 1, and 2. We wanted to find Canada, right? So let me scroll down. We have got Argentina, Australia, scroll down, Bangladesh, Belgium. C should be Bosnia, Brazil. Go down, go down, go down. A lot of entries in Brazil. Yeah, we have got Canada also. Only about 4 entries from Cambodia, but we have got and something called as Burkina. To be very frank, I haven't heard about this country at all. I'm sorry. So, but then we will look at Canada and see how many values are there for Canada. So see here, I return that particular split so that that is what will be there in the filter, and that is what will be stored in this RTD, response from Canada. And then I simply say response from Canada, I get the count of it, I get my total responses, and I get the count of my salary midpoint also. Okay, so that is what we are going to do in the code. So let's go ahead and create a Eclipse project, and let's simply run it, because since I have set the logging as org, you will not see any error, and only the basic information is what will be coming on the screen for you. Okay, so that is what is the first example that we are going to do. That is example 12. Let me go back to my Eclipse. Hey, Kalyan had a question. Please go ahead, Kalyan.
So in the day 3 link to download the codes, right?
Yeah,
The source
I've
code of
already
what we
kept
have.
for you in the Google Drive, friend. So
Correct. So I was trying to download it. Okay, you know what? Never mind. I got it. Because it was showing, it was saying that it was not accessible. Never mind. It's now accessible.
okay, great. So there are two things what you'll have to do, friend. First is all the codes from yesterday, if you want to download it every day, that's what I'll be doing. I'll be sharing all the codes of yesterday, the 11 codes that we did. You can download it as Eclipse projects. For today, you will download this material so that it will open up a folder and you will see all the stuff that is needed for today. And then you will have to set up Postgre SQL as the database. So this is for both for Windows and for Mac. You can download that and you can go ahead with the installation. Okay, so when you go ahead with a simple Windows installation, this is the way how it will come up. It will take a little bit of a time for installing the whole thing, but then this is the way how it will come. And then you can open up this PG admin. Don't worry, I'll be explaining this later on in my diagram also, and I already have it over here. Okay, so that's what you should be doing. Now, let's go on with our first example. Let me close my Eclipse because I don't need that. Create a new project, that is example 12. Okay, so I don't really recollect why did I create this example, but then that example is already there, but you should go ahead and create it, please. So create a new folder called as example 12. You will create a folder called as in, and our 2016 Stack Overflow survey responses CSV will be there. Friends, if you can just mute the phone, that would be helpful. So I'm just muting it for you, Akhil and Kalyan. Sorry about that. So you will create our Stack Overflow survey.java, the same Java code what I have given to you right now. And you also would need utils.java. So that is there from yesterday's example. So let me just go back and look from which example. So from example 5, you will see utils.java. I would need that to be a part of this code because I'm using utils also in the example here, friend. Okay. So once everything is ready, you can simply go ahead and run this because everything is locally available. So I will click on this run and I should see the responses over here. Wait for a couple of seconds. Hey, where is my output window? There it is. Okay, so because it was already there. See, once again, input part. Okay, got it. Because I had changed it. So see here, by mistake, I sent it to input because I made the changes in the same file because after I tested it. So I'll just say in and I will say slash. Okay, and let me run the code once again. And at this time it should run. There should be no issues and it will give me the final output. I will want you to run, look at the code. Any questions, let me know, and we will move on after that. After you try it out in your systems, that is the first example for today, example 12. And see here, the total responses from Canada was about 77. The total number of responses was 2000, and the count of responses where the salary midpoint was not available was it's almost 1/3 of the data, that is 566. So let's get these answers on your own systems, friend. So over to you. Please go ahead and then try this out. I'll give you about 5 minutes. Any questions you can ask me in between, friends. Just meeting myself. And one final thing that I just want to say to everybody is, folks, some of the examples, some people have tried, others have not tried it. That's okay, friends. But then please take a time out and spend about half an hour, 45 minutes after the session and try to finish off with all the sample codes, my dear. Because yesterday there were about 4 codes, which is pretty simple from what we have learned. That's okay. But then trying out is getting a completely different experience. So please do that, friends. Thank you. Nick, just wanted to talk to you on this. Initially, when we had discussed, you had mentioned that there might be about 11 participants in our session, but then for yesterday and today also, and the last 2 days also, we consistently had 10 participants. So not very sure if the 11th person has joined, or maybe he's not there in the training, or whatever might be the reason, Nick. So just wanted to inform you on that also. Okay, he might be on mute and he would have gone out somewhere. That's okay. So Nick is the person from the vendor team whom your company has coordinated. So initially when I had started with the session, they said that there'll be about 11 participants, but then even on day 1 and yesterday for the whole day and today also, we consistently have 10. So just wanted to let him know about that. Yeah, go ahead, Kalyan. You had a question.
So I'm getting this exception of Spark driver could not connect. What does that mean?
That's you need to have an entry in etc hosts 127.0.0.1 with local host, so that
in fact, frankly speaking, not
That's,
needed.
I will give you the command.
That usually is
Kalyan.
on, right? I could
yeah,
only reach the...
yesterday Akhil faced same thing actually. He could resolve.
Okay.
No, to be very frank, you should not have that, buddy. So I will just request to you, Sharad, if you can just tell me that, because, okay, is this in math is what you're trying to say?
Yes, that's right.
Okay, okay. Maybe that's the reason I might not be knowing about that. So hold on. The name node, your data node is not up, friend. That's why. Kalyan, your data node is not up. So go to this thing, what you call, I needed to look at the logs directory.
Hold on, let me just restart it. Maybe that will help.
Okay, start all.sh. Directly you can say start all. So whichever was not started, it will start it again. Yeah. That's good. Yeah, see, now it is starting. The name node was already running. Yeah. Now do JPS. And let's be sure that the data node is up now. No. We need to look at the log. So can you please go down to lab software Spark? Lab software, not Spark, apologies, Hadoop. Software HA tab, logs. Yeah, press enter and try to go to once again. Let me look at my system once again, dear.
Data node, right?
Yeah, there it is. Yeah, data node.log. That's right. Go down to the end of it to see what is wrong. Yeah, see, initialization failed. Exiting now. What's the reason? It crashed for some reason. So
why don't I just do format and restart it again?
No, you lose all the old entries.
Why?
You can do that, but then we really don't know why it happened. So you lose all the old data. So that's the only thing. Just give it 2 minutes. Let's try to find out. It says all the directories failed and remove block pool. In fact, it actually shut it down completely. Just 1 second before you go ahead, Kalyan. Let me look at my system.
While you do that, I'm going to try something.
Yeah, there we go. So this is the right one. So in the logs directory, there is your, just say dot out. Did you say dot out or out.1 or something? What did you
Just out.
Just out. Okay.
Yeah. .log.
.log. Okay, can I just open it once again, friend?
Sure.
Up arrow. Yeah, tail.
Do you want me to tail it?
Yeah, tail should be okay because we want to see the file. Yeah, that's okay.
To data node .log or .out?
.out. Oh, sorry, it should be .log. My mistake. .out was a temporary file. It should be .log.
Venkat, since we are not using anything Hadoop, just file system, right? HDFS only. Do we really need data node?
Yes, because your data is there. See, you need a file system. Yeah, in the current example, we are not using anything. That's okay. But then, even when in the next example, we are going to move the data to HDFS, and even for putting a file, I would need HDFS services to be running, right?
Okay. I mean, the reason is Venkatesh notation can run without having data node up, actually.
That's correct, because even I didn't start with it, right? If you see my screen also when I come, I didn't start with anything because we're running it on Eclipse itself.
No.
The moment we
Even
require,
in that image also, you could run without data node up. Only name node is good enough, looks like.
no, that would not happen, dear. You can't point to any file; it will give an error, my dear. I'm dead sure about that.
Okay.
Yeah. Okay. So I think you can do HDFS name node space minus format. That's okay. So we will first stop the services, Kalyan. Yeah, over here, stop hyphen all dot sh.
Yeah, I'm sorry. Stop dash all .sh.
Yeah, that's it. Okay. So it's stopping all the services. After that, we'll do a JPS just to be sure that the services have stopped.
I'm just going to lower my hand so that I don't forget it again.
Okay. Do a JPS after this, just to be sure that everything is stopped. JPS. Yeah, just say MR tab, MR and tab, stop space history server. Okay, good. Then you can say HDFS space name node space minus format. Name node space minus format. Yeah, that's it.
I think it should be HDFS, DFS.
Yeah. Let me just open the document because there are too much of technologies what we are doing. Just one second. Let me get sure that I think it is right, but let me just be sure. I have opened up the document. That is Hadoop setup. Let me scroll down. Go down still. Yeah, that's right. HDFS name node space minus format. Let me go back to your screen. Yeah, HDFS space name node space minus format. That's correct.
This time it worked.
Wow. I don't know what happened last time. That's okay. Hold on. Yeah, say yes. And yeah, that's right. Now it's formatted. Now you're starting it. After this, we will do a quick JPS. Let's wait. Name node, data node, secondary name node is up. Yeah, do a JPS. Sorry.
Okay. The data node is still not up.
No idea. You will have to. That's very surprising. So, okay, go down. What happened is okay. Do CD dot dot. No. I want to go down to the location. We'll do it again. CD dot dot.
Okay.
I want to go to lab. Go to lab.
Okay.
One level up. Go to HDFS. CD HDFS. Yeah, ls minus l. Yeah, there is a data node. Delete the whole directory. RM minus RF data node minus RF. Yeah, enter. Let's create a directory. Yeah, mkdir data node. Then chmod 75575.
That's the
Okay.
same thing.
Okay, fine. And
Okay, I'll do
yeah,
it. So why take chances?
yeah,
It's the
that's
same
it.
thing, but anyway.
Okay. So now we can start it, Kalyan. So just say start hyphen. Yeah, format it once again. You're right. HDFS name node space minus format. Okay. Yep, that's good. Capital Y, and it is formatted. Hey, once again. What has happened was that we removed the name node, data node, whereas we should have actually removed the name node. So let's go down and remove the name node once. RM minus RF N. Yep, enter. Chmod again. Chmod. Sorry, mkdir. You're right. Yep, and then chmod. Right. 755 as name node. Yeah, then do the format again. It will not tell me yes and no now. See, everything went through. Perfect. Now say start hyphen all.sh. sh. Perfect.
Now the data node is up.
No, we don't know for sure.
Yeah, I saw it.
You saw that. Okay. That's perfect. So now you can continue. Yeah, MR start space history server. Perfect, Kalyan. Great. Yeah, you are all set right now. No worries. I'll stop the sharing. Akhil, you had a question, buddy. Now, in this example, what we're doing is a Stack Overflow. Okay. The same example. Okay, you're creating a separate package. You're putting it inside it. That's all okay. The code is all okay. Did you create the utils file also? I don't see the utils.
Yeah, well, I just copy pasted that here in the same class.
Okay. So that should also be okay.
So Spark conf. Hold on. This
What is it
seems to
saying?
be off.
Service Spark driver failed to start.
Hold on, please. Let me. Project. It's probably running a wrong class.
Okay. No.
Just put 127.0.0.1. It should work.
From where?
I mean,
Let me give
in
you that
local
command.
set master, or you can put in etc host. Actually, you need to have an entry between 127.0.0.1
here.
Yeah. So you are running in local, right?
Correct.
Okay. So yeah, for etc host, can you go etc host? No thingy. Yeah. You have to have it.
Kalyan, just run that command, the one that I just put, the sudo hostname -s.
Did you send it to me?
And
yeah, he's put it in the chat window.
Zoom group chat.
Should I put
Brandon,
it on the
just give
VM?
me a second.
Should I run it on VM or
No. Just run it in. Just run it in the terminal.
But
when you are running
right
in local, right? So then you need to have in local.
Yeah, run it in local.
What does that command do?
It will just update the host name as it's not able to find the host name. It's not able to find 127. Actually, the log should tell you what's green, and I'm trying to see why it's not.
It should give me an error. There is something else, my dear. Hey, it worked now.
Yeah.
Okay, so what did that? Okay, let me take a look at it.
Yeah, basically, it was not able to find, not able to resolve its host name.
But why would that happen, Akhil? Because that is the default host, right? 127.0.0.1.
Yeah, but sometimes I don't know because it happened to me yesterday. I did a lot of research.
Okay.
Yeah.
Let me make a note of it because that will be helpful for me because I've never done this before. Okay, I'll just copy that. Let me start sharing and let me go to Brandon. Yeah, tell me, buddy, you had a question. Brandon?
Yeah. Yes. Hi. Sorry, I was on mute. Just one quick clarification.
and sorry if this was discussed late yesterday. So in this example, I can see there is a Spark context and a Java Spark context.
Right.
So in the previous example, we're only talking about Java Spark context, right?
True, because the reason why this new thing called a Spark context came is so that I can just pass on whenever we are talking about accumulators and those things, we will have to create a default Spark context using the same conf. And from that, we will create our Spark context. If you look at yesterday's example, let me open up any example. And I'm opening up example 3. Let's go to word count. So we created our conf and passed that conf directly to the context. The new thing what we are having over here is we are initializing it into a default Spark context and passing on the value to my Java Spark context. I think this was more to do with version 1.6. Just to be very clear, I'm just going to comment it since you have asked me this. Let me go back and try to change this directly to conf. And let me see if it gives me an error. Oh, okay, hold on. So we need it for sure, because when I register it, you can, the individual accumulators needs to be registered with the Spark context. They cannot be done with the Java Spark context. And that's the reason why I have done this one more extra object that I created. So this was not done yesterday, friend, because it was just required for the accumulator, because when you're registering it, it will take only a normal Spark context and it doesn't take a Java Spark context. So that's the reason, friend. Make sense?
Okay. All right.
Perfect.
Thanks.
Great. So that was the reason. So once again,
hey Venkat, so this Akhil, I am getting an error saying no class def found for Scala product. Did anyone face that?
Scala product? No, we are running normal Java thing. Once again, let me stop share, and I presume for the others it should be working. Okay.
So this is my.
Can you scroll up? It says class not found. Just scroll up.
So this one is saying Scala product. Saying line number 16.
Absolutely, I never got this error, friend.
Okay, so let me see what.
But why should it give you Scala when you're running it in Java? And I think this is this one, right? What you call IntelliJ, right?
Yeah.
Okay. But then IntelliJ code should work. Should not give me error. Scala product null class. Okay, let me just Google it out while you're seeing that. No class def found error.
You also do the same.
And the code was Scala / product dollar plus. Product. Product dollar class. Dollar plus. That's an error.
Okay.
Sorry.
Are you trying to close anything like the context or config? Spark config? No.
It is happening over here. It's creating the Spark config.
No.
You're not. You didn't modify anything on the code
No,
other
no.
than the.
No, there is
When
an
I
error
tried to
because
close,
others have got this error. Others have got this error. But then he's saying it's in Scala, but we're running a Java code. Why should it be? I'm putting it in the chat window. This is the link, and it tells me this is a Scala error. But why in the world should we get this error? Because we're running a Java code.
Maybe let me see what version of Spark core I have.
You have 2 versions, so it is getting confused. Maybe.
What is the 2 versions?
Yeah, can you comment that Spark SQL 2.12 that also contains the core products actually. So now you can clean it and try it actually.
Could be the case.
But then others are giving me that error. That's weird. But let's see.
It
Yeah.
could be the case. I was thinking. Let me see. Okay, this is. Oh, even after.
Why is it
Okay.
giving you Spark driver? Same error what I have.
I don't know. I don't know. I need to see now. Should I do it every day now? I have no idea. Anyway, so this is a fixable thing. Okay, thanks.
Okay, sure, buddy.
Thanks.
Yeah, sure. Oh my gosh. So what weird
Hey,
errors we
thanks,
get
sir.
every. Yeah. So let me stop sharing and let me start with this and let me go ahead. Yeah. So I presume the example would have been done. So this is the example that we saw. So the same Scala product dot class, and that was for a Scala code when I googled it. But then luckily he found out the reason. So now we got the output, but then nothing was stored for us where we can see where the accumulator is working. So this is what the output was. So now let's move on. I presume all the others would have also got this. Okay. So now what we are going to do is we are going to move it to our HDFS. So we need to start with our components. So let me quickly go ahead and start with my this one, VMware. So I'm just starting with my image that is coming up. Hey, tell me, Mati, you had a question, dear?
Yeah, Venkat. So I actually trying to understand accumulator, right? Like in which use cases for what scenarios we'll be using accumulator. What is the
Okay.
actual use of it?
Oh,
I'm not.
okay. Yeah. So take an example. You're working on some product, and I'm not interested in finding out the final value of the product. So there are two variables what we have. One is called as accumulator, and one is called as broadcast variables. So while executing the code, I wanted to see what is happening. Like for example, when you're doing a code and you wanted to find out how many the number of count of the error messages that you got and the number of different log4j, let's assume. So actually we saw that, right? How many error counts was there? How many info counts was there?
Yeah.
Because it is distributed, it will be going into different nodes. So what is accumulated to is this is the final count that we will be seeing. So if I want to see the count of something finally as a part of my process of running this, what is valid products, what is invalid product. So those kind of things we can do it via accumulators. Yes, it will be done in a distributed manner across multiple machines. But then when I finish the job, you will be actually be able to see it in the browser UI, what happened. So in the current example, you're not seeing anything. It just gave you an output, but then we really don't know where this accumulator is also
Yeah.
because we cannot see that. So that is the
Yes.
reason why we are going to go down to the next example where we are going to deploy it on our cluster environment and see what is going to happen here. So I'll just tell you the steps that we have to do, and then we will deploy it, and I'll actually show it to you also on the 18080 page that the accumulator is coming. So that's the whole point of it, Mati. Make
Okay,
sense?
got it, Venkat.
Yes.
Thank you.
So let's do this. So now to ensure that we deploy our code in the form of a final jar file in our Ubuntu environment, we have to do the following. We have to do the following. So first step, let me go back to the code. I will change my, and in fact, that is documented also. So yeah, we have to do the following. I'll just keep it over there. Let me go down to my cheat sheet. So this example we tried, it worked. So far, so good. So see here, out of the box, Spark supports several accumulators such as double and long. Spark also allows us to define custom accumulators. This is what came from your Spark 2.0 onwards, creating special accumulators and custom aggregation operations such as finding the maximum of your accumulated values instead of doing that. In case if you want to do that, you will have to start with, you will extend a accumulator v2 abstract class to define our own accumulators. And I'm giving you a link of that particular class. So I'll just copy this and show it to you on the page. Just one second. Control V. So this is what is your accumulator V2. See here, the base class for accumulators that can accumulate values for int or for in, whatever might be the in, and produce output for type out. And then, of course, the default methods and all those things are there. So we have to use this class in case if we are going to create our own custom accumulator. And I've got a very good link which tells you about more about accumulators. So let me just copy that, Control C, and paste it for you and show this, because this is a very good link what I shared it with the others. How do I create custom accumulators in 2x? It was not possible in our 1.6, and we were talking about banks using 1.6 till about a year back. And it is just in the last 1 year, almost all the banks have migrated to a 2.3. That is what is the most stable version. And it will take them about another 1 year or 2 years to upgrade the version, because yes, Spark will keep on coming out with new versions, but then banks will want to use a particular version and upgrade only when it is needed. So this is a very good article. So please spend some time and see how you can create your own custom accumulator. Let me continue. So to check the accumulators, we have to go to the history page, okay, to check the details. And hence we will also be trying this example in our cluster environment by creating a jar file called as example12.jar. Now I recollect why did I create this jar, because I wanted to see that for preparing this document, I needed the screenshots, right? Like this. So that's why I actually worked on it. Okay, so the same jar file is what we are doing, but the first thing that you'll have to do in the Java code is the following. Once again, let me write it down. In the Java code, ensure that we are reading from a HDFS path. So what you will have to do is, let's go back and see over here. Earlier, I was reading from a text file from in, but now it is not in. I will have to say /input. That means I have to put this file in HDFS also. Okay, so this particular file is what I have to change. Just 1 second. I'll just copy this so that line number 28, you will be able to see it. Let me go back to my cheat sheet. There we go. We are reading from HDFS path, line number 28, and this is what you will be doing. So the CSV file is there, but then for this to run, we have to put the CSV file in HDFS. So please do that. Just once again, something went wrong. The whole page went away. I'll just open the page once again. Yeah. Let me go down to the end of my document. Just once again, it's getting loaded. That's why taking a little bit of a time. Hold on, friends. Don't know what happened. Only the page went off. Just hold on, friends. Yeah. And there, okay. So let me scroll down. I was writing it out. Yeah, there we go. So we will have to ingest the file into HDFS. Sorry, HDFS. And I have already given that instruction to you. So go back over here. So first step, what we'll have to do is copy the file to your lab data that is in my local location, because it is there in our Windows, right? So let me start with the image. Let me log in. Not root. Password is going to be Hadoop123. Good. Let me start with my putty and my WinSCP. Let me go down to my putty. There we go. On Monday, we have created this, so we don't have to do it every time. The same value will be there. Good. Not true. Password is Hadoop123. Let me go to WinSCP. After this example, I can stop my image because we'll be running it on Windows only. There we go. So now what I need is, let me first go ahead. So I've made the changes in my code. Nothing else needs to be changed. We will create a jar file out of this example 12. Okay. So right click on example 12 and then go down to export and then Java and then jar and keep the name of the jar as example12.jar. Okay, so I'll just write it down in the steps. What you'll have to do, we have already ingested our file into HDFS. After that, step number 3 is, okay, which file I have to copy? This particular file, 2016. This file has to be, we will first ingest that particular file and put it into our lab data, then we will have to put that file into HDFS. That is step number 3. And I will change the fonts to 125. Yeah, that's good. We will have to put that file into HDFS. I've already given you the path how you can put that file into HDFS. See, it is already there. And then I can go back to 50070 and check that the file is actually there inside my input directory. See, I have also shown you how you can change the Java file. See here, I've kept it in the document. So I have already done that. You will have to do this, friend. And let me go back and check the port number to see if it is already done. Let me do ifconfig so that I'll come to know what is my IP. I copy the IP and say colon 50070. Hey, sorry, I didn't start my services. If I do JPS, nothing is ready. You will see that. Yeah. So let me say start -all.sh. So we'll start the services. Once it starts, this page will come up. Wait for a couple of seconds. So my name node will start. And now, if I do a refresh on this window, this will come up. See, I will go to my utilities, browse the file system. I will go down to my input directory and confirm that the file is there. Just one second, friend. It's coming up. Only the HDFS is started. Others will start. Yep, there we go. The yarn daemons are starting now. Perfect. And if I go to the browser, hey, tell me, Kalyan, you had a question?
When I try to copy it to HDFS, it says if it's in safe mode and it cannot
Okay,
copy.
okay. The safe mode is something when you just start with your HDFS, and when you do that, that's the time when you see the safe mode. So if you go down to 50070 of the browser, it will tell you that the safe mode is off. See, for me, the safe mode is off. Safe mode is when we are just starting the component. So what I would suggest is, yeah, go down to 50070 and confirm that the safe mode is off. What is safe mode is, it is testing whether all the blocks are correct and I'm getting the hang of everything. So it is just being a little bit slow. So just go back to 50070 and be sure that the safe mode is off. That's what you should try, friend. And it will take some time for the safe mode to be off when you start the services. After that, it will work fine, friend. So that's your error. So now,
One question. So when we should put safe mode on actually?
Friend, that is not our responsibility at all. The safe mode will automatically come up when the blocks, the number, see, we said that the number of replications what we are going to have is 3, right? So what this Hadoop do is, it will check all the copies and confirm that everything is okay. If something goes wrong, it will automatically, safe mode is an internal process. There is no way that we will have to start it or we will have to stop it. It is a mode by which the master says, hey, something is wrong. So I don't want any more operations on it till the time I fix that. And that is what is safe mode, Sharat. Make sense?
So when we are copying the file, why should we turn that off?
Hold on. The safe mode means HDFS is telling me that it is already doing a backup on something. Let's assume we have got 4 nodes and suddenly one of the nodes went down. And if you go back and try to put something into it, it has to first clean up everything, right? Ensure that the backup is happening and all of those things are done. At that time, it won't allow people to interact with HDFS till the time it is doing the necessary system level work. So that is the system level work is what is the time when the safe mode becomes on shut.
So, for example, my job is running. I schedule a job, and at that time, if the safe mode is on, I would not be able to do anything, right?
No, you can't. You won't be able to connect to the cluster at all if the safe mode is on shut.
Okay, so there is no guarantee when this safe mode is going to become on and when it is going to become off.
No, there's no guarantee because safe mode will be on only in exceptional cases when the admin is doing some, I mean, the system Hadoop is doing some background work and you can't do your regular operations. So it is a
Okay.
kind of a safe mode is a kind of a system and the admin does his installations and do all those things. That means
Okay.
Hadoop is taking care of the work. That's the
Okay.
idea, Sharon.
Got it. Okay, thanks.
Great. Thank you, friend. And we also had Sean. Yeah, tell me, Sean, you had a question.
Yeah, your Google Doc seems to be like too long for my system to. Where are you on your Google Doc? I want to make sure.
Yeah. Can you see my Google Doc? I'm in my Google Doc right now, friend.
I know. What's the last thing you have in there?
Okay, hold on. We have to put the file into HDFS.
Oh, you haven't put the step on how to do that. Okay, I guess I'm with you. I thought you typed how you put it into HDFS.
No, that is what I have seen it in my Word document that I had already shared with you, right? So I was seeing from that document, friend. Page number 2 of that document. Great. Okay. So
and
now,
then,
yep.
I'm trying to figure out where do I copy the file from or to.
Okay, you will have to copy the file to the input directory. See here, step
I mean,
number 2.
Not HDFS, just the
lab data. You will put it into your lab data. So see
lab
over
data.
here, that's
Okay.
correct. Lab and data, and see the file over here. You will simply drag and drop the file from Windows onto lab data. Then you will put this file into HDFS so that when we go down to our 50070, you should be able to see it like this. I'm just going to browse my file system. Okay, I'll wait, Sean. No
You're
worries.
way too fast.
That's okay. I'll wait. So have you moved the file to lab data?
No, hold on.
Oh, okay. Let me do one thing. I'll just stop sharing.
I got
And
it.
can you
I
start
got it.
sharing there? I'll go as per your speed. No worries at all.
I've already moved. Now I've moved it. That's fine.
Okay.
And then
After that, you'll have to move it to HDFS. So this is the step that, this is the command that you'll have to execute. Go down to your lab data, and then you will say HDFS DFS minus copy from local, that is moving from a local file system into the input directory. So please do the step number 2 right now.
okay. Well, also I copy my example 12 jar file to
No,
lab
example.jar file will be in your this folder. Once again, I'll show you where that will be. It will be there in programs, example 12.jar. See, it will be only in your Linux. It won't be there in your HDFS.
Right.
Okay, no worries.
Okay, I think I got it.
Okay, good, no worries. So let me see what I have done. So I've got the file here, and I do have the file in my HDFS also. Let's see what the next step is. Then I will go ahead and, hey, we have to start with our history server. So I started with everything, but I haven't started with the history server. So let me do that. Lab software spark sbin /start history server.sh. So when I do a JPS, I should see the HTTP server also coming. Yeah, I'll do a JPS. And yes, I see the HTTP server also coming. That's good. So that is ready. Let's go to the next step. After that, then we create a jar and then move it to the programs directory. And then from programs, we will run our Spark submit. So let me run this code. Control C. Go to my lab and programs. And let me paste it. So I do Spark submit minus class, the name of my class, that is Stack Overflow Survey, and the name of my jar file, that is example 12. I'll press enter. Fantastic. It is starting with the code. And since we have kept the logging level, I've kept it as 4 gigs right now, so that's why it's a little bit slow. Let's just bear with it. Fantastic. There you see. So it gave me the answer. So everything is ready. And now let me go to the browser. That is 18080 page number. That is what is the port number for the job history server. 18080. I'll press enter. Very good. I see that. And now I will go back. See, this is a Stack Overflow service.
Yeah.
Sharat, any confusion? Were you able to
No,
run
no, no.
things?
No, sorry, I was just talking to some.
Okay, that's okay. No worries. So I'll just mute you. No worries, Sharat. Yeah, you muted yourself, so that's perfect. So just 1 second. Let me go back to my count, that is the completed jobs. And this is the completed job. Let's click on this. And see over here, I'm able to see the accumulator. This is what I want you to see also. So the total accumulator and the missing salary midpoint accumulator, the values that I saw in my console, I'm actually seeing it over here. So this is the end of our current exercise. I'll wait till all of you see this yourself, folks. Any questions? Feel free to ask me, dear.
Venkat, I have a question.
Yeah, please.
Yeah, so it's related to just a history server, starting the history server. Okay. And we had to go into the bin of Spark and start it, right?
That's correct. So you will be asking, why can't I do it from somewhere outside, right? Why
it
should I
not
go to the...
configured in that way.
Yeah, because I did not put it into my .bash RC.
Okay, got it.
Yeah, the reason I did not put it in my bash RC is, just have a look, because there was a reason behind it, friend. So that's what I'm going to explain to you right now. Let me open up my bash RC. There we go. It is coming up. And I haven't put my sbin directory of my Spark home. So let me go to sbin and show that to you. Software, a Spark, and then it has got a sbin directory. In sbin also there is something called a start all and stop all. Okay, so this is very similar to what we have in Hadoop also, right?
Okay,
so if I put this also into my path over here, something will come up and something will come below, right? So whatever is below will overwrite whatever was the variables that is there up in the steps. So to avoid that, and since I have to start only one service over here, and that's the reason why I said I'll do it manually rather than putting it in the bash RC.
Okay, got it. Okay. Thank you.
Right. Sure.
Thank you.
And this is what I expect you to see. I'll wait for a couple of seconds more. And tell me if you need any help, Sean, or if you're good, that's perfectly fine with me. Ashima, have you done this, dear? Maybe you're on mute.
No,
Mike
Um,
ran. I'm just looking at the browsers right now.
Okay, okay. Take your time. No worries.
yeah, I'm just exporting the jar right now.
Okay, okay. Take your time. No worries. Vishwanath with me, Vishwanath.
Yeah, I'm good. I've done this.
Hey, that's great. And Brandon, all okay for the current example? Igor?
Yes, I'm done. We got only one question. When we register a new accumulator and we put in that option apply with label, that label only for that UI or it's used somewhere else?
No, it is only for the UI, because what will happen is there are people who will be given rights to this particular page. So let's assume a developer is actually running this. So it will be a standard thing that the developer will do. And it is not right if only I see it on his window. The manager should also be able to see it. So that is what is the benefit of the accumulator. The variable set is there. Other people other than the developer can also see it. So that is what is accumulators about. Make sense?
Got it. And yes, sorry, and one more question. In that register method, we are passing third parameter, which is really count unsuccessful count failed values. What is it?
Where do you see the count in the current screen right now?
I mean, when you are doing for total register, third parameter is true false, and that parameter called count failed values. Really, what does it mean? When you're registering accumulator.
Okay, makes sense. That is the business logic of the code, friend. So let me go back to the Stack Overflow. I'll make it full screen. And this one. So this is what is the name of the accumulator that am I doing?
No. Sorry. When you are doing register, do you see where that method accepts three parameters? Last parameter is false. That last parameter is false. That false, according to documentation, it's called count failed values. What does it mean?
Yeah, so for non-numerical values, I'll keep it as false, and for numerical values, I'll keep it as true. So since this was a non-numerical kind of an object, I've set it as false, and we will create one more accumulator in our code later on in some time. In that, I will keep it as true. So he's talking about this false. So,
yes, exactly. Yes.
Right. So that is where it will take up a numerical number or not. So if you go back to the registered method of your accumulator, that will have this parameter and it will tell you what it is making. Okay.
Got it. Thank you. Yep.
You're welcome. Sean, you were able to see this, Sean? Hey, Kalyan.
Yeah, it kind of took me a while to get to it, but
I need some help.
Go ahead, Kalyan. What do you need, friend?
Can I?
Yeah, you can. I stopped sharing. You can share your screen. Okay.
Just give me 1 minute. So I modified this file.
That's correct.
And then
you created a jar file out of this?
Yes, I did.
Okay.
Just give me 1 minute.
Okay.
I just didn't keep the same thing. Oh, sorry.
The clear has to be removed. That's all. This is perfect.
Right?
Mm-hmm.
So it says HDFS :9000.
Hey, you didn't put the file. You didn't put the file. So
no, it exists. So when I do HDFS,
DFS minus ls
-ls
slash input. Yeah. You will not see the file there. That's it. So I have mentioned it in the step that you have to put it, right? Can you go down to my Google Docs page? That's
this is
it.
The one,
yes.
Right?
No, you're running it from the wrong location. You should run it from lab data because the file is over there.
No, I copied it in here.
Okay.
Right? So it's right here.
Okay, run it once again.
So
yep. Not this. This one. Yep.
Do I need a slash or no?
No, nothing. Remove the slash. Not needed. Even if it is there, it's see. Hey. That is because the input is a file and not a directory, my dear. Can you go to the fourth line? Don't scroll everything. The fourth line, once again, fourth, fifth, sixth. The sixth line of your code, when you said /ls, right at the top, my dear, don't scroll. Just take your mouse and highlight. Yeah, input is a file. Go to the beginning and see. You see /input. It's not a directory, it's a file. Can you highlight input for one level up
like
there?
right here?
No, above that, above that. Yeah. Now go to the left of the same line. See, it's a it's a file, not a directory. No, left, left, left,
Okay.
left. First one.
What do you
Left
mean
hand
left?
side. Be
So
there.
this is left. I'm on the input. I don't.
Still go to the left, my dear. You see dash RW, right? Had it been a
Okay.
directory, it would have been D over there, the
D.
very first one.
I see what you're saying. So how do
Yeah.
I delete that?
Yeah. HDFS DFS minus RMR.
Thank you. Just give me 1 minute.
Yeah. DFS minus RMR slash input.
Slash input.
That's right. So the
Right.
file is gone. Perfect. Let's create a directory. HDFS DFS minus mkdir slash input. It happened because we formatted everything right now, dear, right? That's why this happened.
Yeah. Okay, I see what you're saying.
Yeah, and
So
now
then
put
do
this. Yeah, this is perfect.
And then
Yeah.
let's do an ls just to be
Yes.
sure that I have everything
Sure.
I have.
Yeah, yeah. See,
Okay.
perfect. And once again.
And
oh, hold on.
it's
Oh,
right.
you did slash input. Okay, that's right. Yeah.
Right. And then
Run the code.
run this
Yeah.
class.
Yes. Perfect.
And that should work.
Yeah, it will. Input part does not exist.
No, your file name is not
That's the
correct.
same error I'm getting too.
Look at the file name again.
Is the file name again?
Yeah, if you look at the file, it's name slash input slash.
Wait, that is the directory where it is going.
Is this a problem? If I look into my.
No, if you go into your input folder or your HDFS input.
Okay.
Yeah,
Let's go there.
HDFS DFS.
Do a clear and yeah, run this.
Yeah.
Right.
Okay, so that is a super group of slash. See, the file name has got a slash input slash in front of it.
No, that's because you did slash input. Just use an up arrow and remove the slash input here. Up arrow, Kalyan. Remove the input, and then remove the input and press enter. Just simply delete the input word. That's it. Press enter. And slash.
I forgot the slash. Yeah.
Yeah. Slash. That's it. This is what he was saying. This is correct because input is a directory, and you have the file also.
There is an input directory, right?
Right.
Yes.
There is an input directory, and he's got the file also. Hold on. The error is something else. Let's have a look.
Doesn't the file list not include the?
I think Sean is correct. The file name when it created inside input.
Say that again, Sean.
The file name also has slash input slash in front of it.
Oh, you okay? So you're saying, okay, let's just remove that entire thing again, right? That should take away everything.
No, the input is there.
Oh, sorry. Just give me 1 minute. If I do that, shit, I should have been using dash RMR.
Minus RMR, yeah.
Right.
Okay.
No, it doesn't like that. First of all, it says deprecated, but
yeah, that's okay. It's gone, correct?
Okay. Yeah.
And then let's say we make that input again.
Yeah.
Right. Do a slash again.
Yeah, the directory is there, right? Now you move the file. Not this.
And then I
remove the slash. Remove the slash.
Remove the trailing slash. Yeah.
Right here. Is that what you mean?
Yeah, press enter. Should not make a difference, but yeah, press enter. Now run it with the slash input. Yeah, slash input so that we'll see the name of the file. See, it is the same thing.
Still there.
No, I think there might be a typo or something, but what he did was right. There was nothing wrong. I'm surprised why that error is coming.
See something. I made some changes. Let's see if that works.
Here, bro. What was the change that you did?
I know what the problem was. So when I exported the jar, I didn't have a slash in the beginning.
Okay. After that, you had put it. Okay, makes sense. So he recreated the jar once again, and the problem. Now, please go to the page. Just start sharing once again. One last thing. Yeah. go to the browser, do a JPS to see if that page, yeah, not this, the same IP 18080. Your history server is, no, it's not on. No, it's not started, my dear. Go to the putty. Go to CD, lab, software, Spark, SBIN. Not this, not this, not this. You
Oh,
want
okay.
to,
I see. I'm sorry. Yes, I didn't start the history. Yeah,
yeah, yeah.
I'm sorry.
Lab, software, lab,
Lab,
software,
software, Spark,
Spark, SBIN, SBIN.
CD, SBIN.
Yeah. And now say dot slash start hyphen H and tab. H history. Yeah, very good. Enter. That's perfect. Now copy this IP 1051.146.121 colon
It's
5 once again. Okay.
in file not found.
No, 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 no. You didn't start the history server properly. So hold on. Go
Do I need a
to
start? Do I
no,
need
no,
a
no, no,
started?
no need, no need, no need. This is correct. It's giving an error because the directory is not created. So go to the sbin directory. Sorry, go to the conf directory. Delete this. Come outside sbin. Go to the conf and do ls minus l. Spark hyphen. Hey, you didn't remove the template at all for the defaults. To remove the template, right? You see,
Why
the
don't?
file is with dot template, conf
Yeah.
dot template. Delete the dot
So,
template word.
oh, I
Or
see what you're saying. When you say you want me to move
yes,
it.
yes, yes. Spark hyphen default. Yeah, to spark hyphen defaults.conf. Remove the template. That's it. Okay. Now open up that file. Do a VI on that file. We added 3 elements yesterday. It is missing. Let's see. Enter. Yeah, it is missing.
Let me just copy that from the yesterday's
That's what.
cheat
I'm
sheet.
also just going to the cheat sheet real quick so that I'll paste it in the chat window so that we can see that. So the important thing is to find out what went wrong and how it went wrong, friends. So once we do that, things will all be good. Where is it?
No.
Okay, it was not.
Here, I found it.
You found it, okay. Let me go back
This
to the
one, right?
screen. Yeah, that's
PC.
the one. Yep, that's the one. Copy that. And yeah, VI. Yeah, paste it at the end of it. At the bottom, you can paste it. Yep. Enter. Yeah, paste it. Yeah, that's good. I hope you have created the directory called as Spark events. If not, we'll have to create. I don't think you, by the way, you formatted your system. So let's do
Yes.
HDFS DFS minus mkdir / Spark events. Once again, I think Spark hyphen events. I don't recollect. I'm sorry. Just check once. I'm not sure.
That's okay. I'll just create it. I think it's Spark events.
Okay. It is Spark events. Okay, that's perfect. Great. So let's go back. And now you have started the server. Simply run the code.
I
Go
didn't
to
start the server, right? Because it didn't start the server.
okay. Now we have to start the server. That's correct.
cd double dot spin
Yeah.
and then
Dot slash
start history server.
Yes. Perfect. Very
That
good.
should, and
Yeah,
then
that started. Now run the job. No need. In the history server, it will still be there automatically. Anyway,
is
yeah,
it?
run the job also. Go to the IP colon 18080. Copy the IP. Yeah, 18080. Enter. Yeah, it's loading. Yeah,
Okay.
see the first one. Click on this.
Yeah.
And click on the completed jobs. And you should see the accumulator. Oh, no. The bottom one this one. Yeah, that's right. Click on it. It'll open. Click on this and see the accumulator showing for you.
Okay.
Perfect.
Thank you.
You're welcome. Marty, you had a question, dear.
Yeah. So Venkat, for me too. I'm getting an issue of not able to find the CVS.
Okay, can you just
I'm
start
trying.
sharing a screen, please, once?
Sure.
Because to be very frank, only when we look at it, we'll come to know what's wrong. I didn't get that. So it says that, hey, it says input path does not exist.
But see, if I do HDFS,
DFS minus LS slash input. Okay,
oh,
only
sorry.
slash input is there. Up arrow and say slash input. Yep, perfect.
See, it's there. Oh, it's under input under.
No, under input only. Show me the file. You have to change something in the file. Go to Eclipse and show me the file.
Okay. So this is my Eclipse. This
Come
is
down, come
example,
down,
right?
come down, come down.
Yeah.
I want to see the file. Hey, you forgot the slash before input.
This one?
Yes, that's why.
Oh,
Yeah.
okay.
Recreate the jar, it'll work.
Okay, yeah, sure. Thank you.
Yeah, because since you did not put it as slash, it was a relative path, and in that it was not there. No, Java.
Sorry.
Okay.
Okay, I will do it.
Okay, okay, sure. No worries. So let me stop sharing. And let me come back to the screen. Hey, my God, we are in due for a break. I didn't realize the time. I just saw that myself right now. It's 10, almost 45. So let's take up our break right now, friends, and we should be coming back. So 57 is what we will come back, friends. In the meantime, please finish off with that particular part so that we are done with it. So what did we do today morning? We saw a simple example of how to run accumulator in a vanilla fashion in Windows. Then moved to our HDFS and saw that in our history server also, friends. So let me go back. This we did. Then we executed our code and went to the history server page, to the history server page, page, and saw the accumulator displayed over there. Sorry, items over there, and this is accumulator displayed over there. So that's perfect, friends. So now let's take up our quick tea break. Tea break. Tea break will end at 12. Once again, your time should be 12. Yeah, we will start off at 11, friends. It's almost 44. So at 11 your time we will start. The break will finish at 11 a.m. Okay, and once we come back, we will go down to the next code, that is adding another accumulator to calculate the bytes that has been processed. Okay, and remember, I think it was Igor who was asking. Yeah, that's right. Remember, Igor was asking what is the significance of the third value that we had passed. We have set it as false and false, right? And you see, since this is a numerical thing, and that's the reason why I kept it true. Okay, so we will see this once we are back, friends. So see you back again at 11 in another 15 minutes, folks. Okay, thank you so much. Just meeting myself. Hello, everybody. So it's almost 11. So let's get started with our next example. So we saw the accumulator and saw how it was running properly. That was our last example on the image. So in case if you don't want to work with the image, that's perfectly fine, because all the other examples will be doing it in our local system itself. So let me go back. Okay, before that, there was a question. Tell me, Marty.
Yes, Venkat, I am not able to see the accumulators in my browser. Can you please help me out how to view that?
Sure. Can you just start sharing the screen, please?
Sure.
Great, I can see your screen. Okay, look at the first job, click on local. Yeah, that's right. After that, click on the completed jobs. Yeah.
Oh.
Again, click on the completed jobs. Yeah, click on that. And
Oh,
now come down, you see the accumulator there, last one.
yeah, yeah. Okay, okay. I was clicking on other jobs and I got
Okay,
confused.
okay,
So here,
okay.
if you go, there is nothing. So I was
Exactly, exactly. So that was an earlier job that you had run. So the latest job, what you have executed, that's what you have to see. One about that.
okay. So those are the errored out jobs because
Exactly, exactly.
oh,
That's correct. Because that's the
okay.
reason why it was not completed, my dear. So that's why it gave you that error.
Okay, got it. So, but for accumulators and all, there is no nodes created. This is like for stage 0. Within that, we have text file and filter.
That's correct, because it's all a part of the same stage. Just go
Oh,
back, not over. Yeah, come down, come down. You see the accumulator below. Yeah, there you go.
yeah, yeah. Missing salary midpoint.
That's
Got it.
correct. That's
Oh.
correct. Okay, perfect.
So even for even only if we say accumulator in our program, we will be seeing this configuration
That's
cells.
correct. That's correct. If you don't say accumulator, this nothing called as accumulator will come at all. So we have to
Oh, okay.
programmatically do it in case if we are expecting to see that.
Oh, okay, got it, got it. Okay, so
Right.
this is only way Java program is the means programming is the only way for the accumulator configurations, right? Like
That's correct. But then we can do the same accumulator using our code in Scala and in Python also. So in
okay,
Java, we have to run it on the cluster. In Scala and Python also on the cluster, but then it is a much more interactive way of doing it. It wouldn't be a part of the Java code. I can do it in a normal REPL, and even then it will come here. That's the
oh,
whole
okay,
idea.
got it. Okay, got it, got it.
Okay,
Thank you,
perfect.
Venkat. Thank you.
You're welcome. So let me stop sharing. Okay, now we are going to see one more accumulator in our code, and let's go back and see again. This is going to be Stack Overflow survey code, and we are creating the masters to be 1. Again, the same way we create a Spark context and a Java Spark context. I had explained to Brandon earlier. So the reason why we created Spark context was that when I register my accumulator, you have to specify the Spark context. It doesn't take the Java Spark context. It takes the Spark context only. So that's the reason why we created this particular variable. And then for the earlier two ones, we had set the value as false, whereas it is going to be a numerical value in process bytes. And that's the reason why we are creating it as true. Again, I'm taking the file from my local file system in folder. And then I am seeing what all are the responses that is coming in from Canada. And this is the way how we will be able to change the third accumulator that is called as processed bytes. That's stored in as a long accumulator. So we are adding the response.get bytes and the length of it. So we are just seeing what is the byte of the data that we are having. And for that matter, it depends upon the business use case as to what all has to be put into the accumulator, because the jobs are running in a distributed fashion, and the accumulator will, after the job is finished, all the accumulators will be calculated and shown it to you. It will also show what was done on each individual node also. So when you saw the accumulators, if you scroll down, you will be able to see on how many cores. If you are having 2 cores, if it was running parallelly on both the cores, you'll be able to see that also. So imagine in a distributed environment, if there are 4 nodes, that is worker nodes, what you're having, what was happening on every worker node, that will also show that to you. Okay, so that's the whole idea of this. And rest of the examples are the same. And we're writing one more sysout for the processed bytes. And to pick up a value of an accumulator, you can just say dot value, and you can get the value of the accumulator. That's what we are doing over here. And this is what you see. The number of bytes processed will be like this. So let's please go ahead and copy this code and run this. So I'm there in my Eclipse. Let me close my other codes. And this example, what I'm saying is going to
Venkat.
be, sorry. Yeah, tell me, Mati.
Sorry, Venkat. I have a question, so I'll stop you here because I raised the hand. I think you
Okay.
didn't notice.
And I
Okay,
didn't see
so
that. Yeah, that's why. Sure,
no
tell me.
problem. Yeah. So, so how many accumulators an application can have? Like, is there any limitation,
No,
or
no,
will
no,
it
no,
affect
no.
performance?
There's no limitation in our standard applications for the managers to see the performance of a job. We have seen at least 250 accumulators of different data points that is there. Because when we go down and look at a real example, you will have the data coming in more than 250 to 300 to 400 variables will be there in every row for us. So when we push it into HDFS, it will be one record with a comma-based delimiter would be there, and you can have till about, I have personally seen something till about 250. More than that, I haven't seen, but we can have as we have seen an example with 250 accumulators for Citibank that is actually happening. So theoretically speaking, Spark doesn't have an upper limit on the number of accumulators. You can go ahead and do as much as you want, Mati. Okay.
Okay, but accumulator has this restriction, right? Always you have to create an accumulator and you have to register it.
Yes,
So it's
yes. This registry is only there in the Java code. If you look at a Scala code and all those things, just create accumulator and that should be fine. There's no need to register it at all. So only in Java you have to register it, and it will take a Spark context. It won't even take a Java Spark context as a parameter. So that's the reason why Brandon was asking, why did we create this variable? And that's the reason why I had done it in the code. Okay.
It is just to inform the Spark context that accumulators are coming and to make it available in UI.
That's correct. So all the accumulators will be available for us because we cannot see the accumulator till the time the job is completed, right? So that is the main advantage of the accumulator. So while the job is in process, I won't be able to see that. Only when it is finished, I'll be able to see the complete list of it, like the kind of a reporting kind of a thing, or some special statistics of the variables. I'll be seeing it in the accumulator. So what as a practice, what we have been doing is some common statistics, what I want to see as to the performance or what was rejected in a rejection kind of a scenario. Those are the typical use cases where we will use accumulators.
Okay, I feel a tight coupling between the accumulator and the actual processing function, right? Like we are processing with that input of filtering something, and the accumulator and the filtering processing code is in same file. We cannot separate out the accumulator separately or the code separately because accumulators are configuration specific. So
Exactly.
I feel
So they are the inner part of the code. So since you're asking me, let me show you one example. Just once again, this is from what I do it in Scala. Okay, so let me show that. So this will give you a view as to how we are using it in a real world. So just once again, let me open up the document. And you see that we have got something called as, okay, let me open up this retail DB. Just once again. I will say extract. So I'll give you a document where Cloudera has got a very good details on this. See, there are multiple tables, and what is the relationship is like this. Just once again, this is beyond what you are asking for. So just wanted to show it to you so that you will come to know what is the real use case. So this is one of the real use cases. Cloudera and retail.db. I'll press enter. I'll give you the link also. There we go. So this is what is the basic page, how you can get started with the Hadoop tutorials. Let the page come, let it get loaded. I'll copy this link and put it in the cheat sheet for you. Just once again, our cheat sheet is here. Okay, so we have already started after the break, and this is what the link is. Okay, so let me go back to the link, and it's still getting loaded. Where is it? Yeah, there we go. So this is what is the ER diagram of a use case. So what you have is you have got departments, then one-to-many relationship, you have got categories, then you have got products, and then you have got orders. Orders will consist of individual order items, and orders will also have a one-to-many relationship between the customers. So all these things they have given for us by default, Cloudera. And see, that is what is there in the retail db.rar. You'll easily get this RAR from a public source. So this is what is the details. From here, what am I doing as an accumulator? Let me show that to you. Let me open up my document. Okay, so see here, Accumulators are primarily used for performing some counts as a part of the application, whether it is for data quality, unit testing, or any business use case that you're having. So these counters cannot be global variables as a part of the program, and hence we have to use something called as accumulators. So what are we doing over here is they are creating two accumulators. The total number of orders and what the completed orders, because if you look at the orders will be there in multiple states. So let me show
Yes.
that to you. If I go to my orders and open up the file, just one second, let me open it with my notepad++. There we go. So the states can be, it can be a closed order, pending statement order, it could be a pending review order, or it could be a processing order. So I have got totally about 68,883 orders, and I'm only interested in the complete orders, okay, the count of it. So I want to see an analysis to see how many orders got completed. So that's why I'm creating this accumulator. So what I first do is I take all the orders, okay, from the order details. I simply do a count. So I have got 68,883 orders. So I've got two accumulators for us in the code: the completed accumulator and the orders accumulator. So in the code, I increment by completed order, and when it is complete, okay, then I will increment my completed order. So see here, orders accumulated. Sorry, go ahead.
Yeah, got it. Got it.
Okay. So this was example. So depending upon the use case, you can create different examples to see what is there. So this particular use case, what I've shared with you is really, really good. So they will tell you about all these things. They'll tell you how you can go ahead with Scoop also. Scoop is an import-export tool, right? They'll tell you how you can work with this and then play around with it. I think there are about 4 versions of this. This is the first link. Then you can go back and once again go to the next step. That's it. You'll go to the second link. So this tutorial is good to get a proper understanding about what is big data and where all the concepts what you have learned comes in picture.
Okay, got it.
Perfect. Thank you. So let me close this.
Very much.
Sure, no worries. Let me close this. And let me close this folder from my Google Doc. I don't want my extracted folder. Okay, that's fine. And let me go down to our code now. Let me close this also. And we will now try the second example for today. The second example is in our list. It will be example 13. Okay, that is example 13, where we have added a new accumulator and list it properly. So let me go back and create a project. So this will be example 13. I don't have it here. So let me close my earlier code. Good. Create a new Java project, and I'll call this as example 13. Let me create a package over here. Project is created. Right click, new. I'll go down to my package from the evenket. Let me get hold of the code. The code that we have, the name of the class is Stack Overflow Survey Follow-up. So let me give the name of the class. Right click, new class. That's the name of the class, and I will say finish. Let me copy the imports statement now. I would need the utils also, so I will drag and drop that code also. So Control C. The Scala option is also I would need. So I will import all the packages. Good. Now let me go back to the main, public static void main, and copy all the code. Go to the end of it, and that's it. This is main. Control C, and I will put it over here. Save the file. I need the dependency file. So right click, properties, And in the Java compiler, sorry, Java build part, I would need the jar files, all the jar files that we have been using, because this is like a normal project, not like a Maven project. Very good. And I should see no errors coming. Why there is an error? Let's go back and check. Okay, so okay, got it. Because I didn't have the utils code, so Control C. I'll put my utils code inside this, so I should not see any error. So what Akhil had done is that the utils part he kept it as a class variable. So that can also be done, but since I've got a separate class, I had kept it. Now what is this? Okay, I should suppress warnings to my main. So this Java Spark context error will go away. And at the last, I'm not closing my Spark context also, the Java Spark context. I'll close it. Control C. I'll say dot close, semicolon, and I will save it. And we are all done. So now let me simply run this. I'll go back and run my code. And I should see the output coming for me. It is just executing. Wait for a couple of seconds. Yeah, there we go. Hey, once again, why did it give an error? Okay, input path does not exist. True, I didn't create the in folder. So I should have the in folder with the file, right? So right click, new folder, and I will call the folder as in. And I will simply copy the code from there, from the earlier 12th example to this example, because if I'm not mistaken, the code is the same. That's right. I've got that ready. So now I'll close this and I will start again. There we go. So this should work, and it should show me the fourth variable also, like what I have shown it in the output for you over here. See here, it should show me the total number of byte processed was 23,60,248. Let's go back. See here, 23,60,248. So this is what is the new variable that we have added, that is in the form of an accumulator. Here we can't see it in the browser. We are simply directly printing the accumulators with the dot value method. So dot value is the way how you will print out the contents of the accumulator. Good. So just wanted to check with everybody, folks. I presume you would have done this. Ashima, is this finished, friend? This example? Are we all set?
No, I'm still working on.
That's okay. So let's give you another 5 minutes so that you can finish this. Friends, what is very important is to actually try and do the code. That's perfectly fine if you have understood it. You're watching what am I doing, and now you would want to do it on your own. So please go ahead. I'll give you about 5 minutes, because there's no sense in simply going through it without you trying it out, friends. So that's important. So please try it out. I'm just muting myself. It's about 10 your time, 11:19. We will give you 5 minutes till 11:25, friends. Okay, and then we will move on. All of you can try this out. Thank you. Okay, just for my understanding, the earlier code that you were running it in a different editor, I presume that would have worked, right, Akhil?
Yeah, that worked.
What was the reason?
The Spark version,
Yeah.
version, and even the HDFS version I was using was way higher. So I had to get it down to what you had in your.
Okay. So we were using 2.3.0. So I think you would be using a different version. So that would be the case. Sure. Thank you, Akhil.
Yeah.
We'll just wait for everybody to finish. Another 5 minutes more. Thank you. Just waiting myself. But I'm over here. If you want any questions, you can ask me here. Thank you.
Venkat, Sharath, I have a question. So the total that you calculated, I mean, using the accumulator, long accumulator,
Okay.
we also do that using that RDD dot count and put into the accumulator, right? I think.
One second. Let me just go back to the code. Marty, just 1 second. I'll just finish with Sharath and then come back to you.
Sure.
So, yeah, sure. Thank you. So, I think you were talking about this one.
The
So,
total,
here,
yeah, the
I
total.
just did, yeah. So what I'm doing over here is I'm getting the count of the accumulator. I'm not using the value. So if you look at response from Canada was not accumulator. See here? So that's the reason I didn't use dot value, my dear. So it was as a part of my business logic. So response from Canada was an actual RDD. And that's the reason why I did a count on that. And for all the others, I had did a dot value. Make sense, Sharath?
So response from Canada is RDD, which is
That's
already
right.
filtered. That's why it is smaller count, you're saying.
That's right. And for
So
all the accumulators, you have to do value only.
during the filtering, you wanted to check that thing. Okay.
That's correct. So as a part of the business logic, I confirm that it is equals Canada because we have about 2,000 total submissions, right? Out of which I'm only interested in finding out how many submissions had come from Canada. That was the
Okay.
idea.
Yeah. Okay. Got it. Thank you.
Yeah, great. Thank you. Yeah. Now tell me, Marty, you had a question?
Yeah, Venkat. Like what I understood from accumulator is, so we cannot have a defined global variable outside that RDD, right? Like I can define some global variable outside the RDD and I can get that value out. Is it possible, or I should be using accumulator to do that?
No. See, what would happen is if you have any global variable over here and within a code you're trying to increment a variable, please understand this code is going to be executed on multiple worker nodes. So
Okay.
if you have any global variable, like how we do it in a normal Java programming, I will say int count and I will simply say plus count. So that will
Exactly.
not work for us in our use case. So as a replacement to that is what we have a accumulator. Okay.
Oh, okay. Got it.
Yeah. Since we cannot do
Yeah,
that,
that's
there has
my
to be another
understanding
way.
too. But there is a way, but we should not be doing it because it will be running in multiple worker nodes, and
That's
even as
correct,
a
because you
class,
will not
we.
get a real answer. You will not, the
Oh,
reason why we can see the accumulator only at the end of it is because it will be working on different nodes and the value of it will be different in different nodes, right? Only after
Yeah.
the job gets completed, it will pass it on to the driver program and then we can access it with the dot value method. That's the whole
Got
idea here.
Okay, got it. So if I have here, I have only one RDD, right? Like response from Canada. If I want to have response from USA, response from India, so different RDDs I want to do I have to, means can I do those kind of RDDs inside the same class, or I should be having it in a separate function? How if
No.
I
You can have it in the same class. So
same class?
yeah, very much, because you can create any number of RDDs in the same class, depending upon what business logic you want. But then, since we cannot have a class variable, a global class variable kind of a concept, what we have in Java, we cannot do that in our Spark, and that is why we have got something called as accumulator.
Okay, got it. So now how can I differentiate between the RDD and accumulator, right? Like, so I have three accumulators in this class: total, missing salary, and processed bytes. And you are
Right.
using those accumulators in one of the RDD. So if I'm having another RDD, if I'm using the same accumulator, it will count overall for Canada, for India, for USA. Overall, the accumulator gives the value. So, but for specific RDD, if I want to have an accumulator, accumulator, I have to define different accumulator.
Friend, please understand the accumulator and RDD are completely different. So
Yes.
RDD is just a way how we are writing it in the program and getting an output. So RDD is something, a transformation will be there so that you can check the values that it will be done, because they are lazily evaluated. It is done only at the only when the complete thing is finished will I see the value. Accumulator
Yeah.
is something which is a counter kind of a thing, and they can be checked only after the job is complete, because they will be running on multiple worker nodes, right? So
Yeah.
both are different concepts. Don't try to mix and match. What would happen is I might increment these accumulators within RDD. Like for example, see, in response from RDD, I am incrementing my accumulator, right? See?
Yes.
So that you can do, but then both of them are completely different. So RDD is something that is transformations and actions, what we have learned. You cannot see the results of an RDD. You will have to actually print out the results of an RDD. Whereas in accumulator, there is a ready-made method called as dot value, which will give me the result of it here. So that's the point.
So here again, sorry, I am having a little more questions. Like you said, RDD will not execute until we print it, right? Like response from Canada.count is the one which will execute that RDD. Until then, the RDD will remain static. Like,
that's correct, because they are all transformations. That means you can do multiple actions. Like in Java, even though I write a lot of code, it will all go to the java.lang.object, the topmost class, and it will execute everything, right? So what would happen is only when you call an action, and count is an action, will all the other processing happen. Okay, so that is what is called as lazy evaluation. So it would mean that you can go ahead and do everything, but then it will not, Spark will not go ahead and run it till the time you call an action on it. I did this complete line over here, but this would not have got executed if I have not set this count over here, because
yes,
count
I
is
just
an action.
commented out and ran it, and it gives me 0, 0. Okay,
Exactly. So that's right. So it will give you the default values of it. You're right on that.
Okay.
Good,
Yeah,
good.
got it.
Yeah.
This RDD will run only if we have any action, and this is the action. And for this RDD, you have defined processed bytes, total, and missing salary midpoint, right? These are the accumulators. And so similar to this RDD, if I'm creating another response from USA, inside that, if I'm using same accumulator, so it will at the end, the accumulator gives me value of both Canada as well as USA, right?
Exactly. So over here, imagine if I have kept one more variable, I created one more thing called as total, and let's say total, sorry, this one, there was, no, Canada was only something that was there in the form of a RDD itself. See, the responses from Canada was an RDD. It was not an accumulator. See over here. So
I got it.
So in case if you're seeing response from USA also coming down, you'll have to just use that RDD and then call count, and you will get the value. Right?
Yeah, but if I define different accumulators, that will also be listed down. So, but
That's
if
correct.
I'm using same accumulator, it will also sum up both Canada as well as USA.
That's correct. It will sum up both of them. You're right in that. That's perfect.
Got it. Thank you.
Great. Sure. You're welcome. And thanks for the update, Sean and Ashima. They have finished it. That's great. So now let's move on. So let me close this. So we are finished with our concepts of our accumulators. Similar to the accumulators, we have got a concept called as broadcast variables also. So let's see what is that. Broadcast variables. And let me go back to the shortcut and then try to tell you what is that. So I need to go down to my docs, Spark 2.3.0. Go to my, you saw accumulators already. Now I will talk about my broadcast variables. Okay, so let's see what it is. So broadcast variables allows the programmer to keep a read-only variable that will be cached on every machine rather than shipping a copy of it with the task. So that means if you want some data that is going to be static, like for example, if you want to find out the orders that is coming from different regions, Okay, so the regions is going to be more or less static for you. It is not going to be dynamic every time. It might be dynamic over a period of time, but then it is something like a static variable. So if you want to do that, you can use it as a broadcast variable. So they can be used, for example, to give every node a copy of a large input data set in an efficient manner. Spark also attempts to distribute the broadcast variables using efficient broadcast algorithms so that you can reduce your communication cost. So any variable which is static, which doesn't change much, which I'm going to use it in the code, that can be kept or declared as a broadcast variable. And how do I broadcast it? We will say Spark context dot broadcast. Yesterday I said, right, using our Spark context, I can use text file, I can use parallelize, I can use broadcast, and I can use accumulator. So I can use all of them with my SC variable. Okay, so this is how using broadcast you can get the variable. So after the broadcast variable is created, it should be used instead of any other value. So you cannot change the value, and that is the variable that will be used. So this is the conceptual understanding of what it is. Let's do an example to understand this. So let me go back to my document. So they allow developers to keep a read-only variable cached on every machine rather than shipping a copy of it with the task. So they can be used, for example, to give every node, a worker node, a copy of a large input data set in a very efficient manner. Okay, and all broadcast variables will be kept at the worker nodes for usage in our Spark operations. So for understanding this, there are two data files what we have. We have got a UK makers spaces identifier data.csv. So let's look at that particular file. Just one second. So if I go to your folder, day 3, and you see the UK makers identifier data. So let me open that with Notepad++. Hey, let me open it with a this one, Excel. So see here, so you have got a lot of data that will be over here. And I also have got one more data that is UK postcode. So first let's understand what it is. Okay, so the CSV has got a header column in the first line. So let's go back over here. See, there's a header column. So whenever there's a header, and I'm sure in your data files also, in your office processing, whenever you're doing, you will have headers in your files. So this is to tell you what the column name is. Okay, so that's why we have the header file that is there by default. So the question that needs to be answered is, how are the maker spaces distributed across different regions in UK? But if I want to see the region, we only know the postcode for every region and we do not know the region. Okay, so if you look at this example, you will be able to see only the postcode for that particular region. See, so this is the column that I'm interested in. It doesn't tell me the name of the region. So the postcode is actually there in a separate file that is called as UK postcode.csv. Okay, so to answer that, we have got another data set called as UK postcode.csv. Sorry, it should be .csv. So by using the above, for each postcode prefix, we can find the region it belongs to, and by combining the data sets, we can answer the above question. So the solution would be, first, we'll have to load the postcode data set and broadcast it across the cluster, because this is a file which doesn't change. Okay, so I will broadcast it across the cluster, and then we will load the maker spaces space data set, call the map operation on the makerspace RDD, and then look up the region using the postcode of the makerspace, because in the makerspace data set I have got the postcode. The actual location of it will be there in another file. So that's what we are going to do in this example. Okay, so I've just given you a screenshot. So see over here. So if you look at this particular file, this is the postcode file, and you can see here I have got the postcode as well as I have got the count of it. Okay, and if you look at the file, so see over here, when we talk about the postcode in the makerspace RDD, it is the full postcode that has been given. Like for example, WIT 3AC, then this is the second one, and this is the third one. Whereas the postcode in the postcode data set is only the prefix of that postcode. So it is only the first three things, WIT, or it will be E14, or it will be SW12. Okay, so that is what it is. So we have to see how to join and make this work. At the same time, we have to see how do we use our broadcast variable. So that's what this code is going to do, the 14th example code. So first step, what we will do is we will get the logger, as always, get the spark conf and the Java Spark context. I don't need the Spark context here. That was only needed for my accumulator. Then I created a broadcast variable which will be of string and string. Okay, and from the Java Spark context, I broadcasted that particular variable. Okay, that is load postcode map. You'll see that down in the code. Then I create a Java RDD, and I am looking at the makerspaces data. Then from there, I'm getting the region. Okay, finding out what is the removing the utils comma delimiter, finding out the timestamp, getting the prefix, and see over here, I will check if the post prefix is present, the postcode map dot value, and whether it contains a particular key of my post prefix dot get, and then this is the value that I will return. So what it is trying to do is trying to do a join between two things, friend. We will see that further. If I don't find it, it will return null. Then you have got a for loop which will just get me the key, and it will get me the value of it. So the actual code is over here. So we have a map, and see how in the map we are reading from this particular file. Okay, so see here, I'm getting the postcode map and putting it as a hash map, and then I'm getting the individual values of it. Okay, so this particular function, load postcode map, that I wrote earlier, see over here, load postcode map in my broadcast variable. The actual definition of that is this particular function. That function is actually this particular code. And then we also have got a get post prefix, wherein I will pick up the value, and if it is empty, that's it, or else it will give me some value of it. So I'll be using this get post prefix in my regions RDD also. So somehow I'm joining both of them, making one of them as a broadcast variable, and seeing how the thing would work. Okay, so what is the process of running this? First step, create a broadcast variable by calling spark context.broadcast. See, that is what I did over here, spark context.broadcast. See here, jsc.broadcast. That's what I did. Then it is important that the broadcast variable is serializable, because it needs to be passed on from the driver program to all the worker nodes across the wire. We can also broadcast a custom Java object when we should ensure that the object implements the serializable interface. Then the next thing is the variable will be sent to each node only once. Okay, and it should be kept as a read-only kind of a view, so that you cannot do any update on the broadcasted variable. And the value of the broadcast can be accessed by calling the value method. Very similar to what we had in our accumulator also, dot value. So that's the way how I will be doing this. Okay, so this is what the example is all about. So I would want you to load all these UK maker spaces in our code and then try it out. Yeah, Mati, you had a question? Please go ahead.
Yeah, right. The broadcast variable is load postcode map. So, but there is no TD RDD for that, right? We are just
No, it's
scanning it. It's just a normal. Yeah, it's a function. I got it. Private static map, load postcode map is a function.
Right.
But inside that, we are scanning. It means like it's a normal Java program.
Normal Java code. That's
RDD.
correct.
Yeah, it's not an RDD here.
No, it's a value which I'm passing it and creating it as an RDD. See?
Okay. Okay. It's not an RDD, right? It's a
No,
broadcast
it is a
variable.
broadcast object. It is not an
Okay.
RDD, but then it is a type of object that is used by Spark.
Okay.
So we are saying JSC dot, that is Java Spark context dot broadcast. I'm using that normal Java code and creating it into an object that Spark will understand, because Spark understands RDD and accumulator and broadcast variables, right? So Spark will
Okay.
understand that. It is not like a normal RDD that we are having over here. You're right in that. It's not like a
Yeah.
normal RDD frame.
Okay. So just we are loading that Excel sheet again, right? That's an input. And and we are just going through next line, and we are searching for it and getting the postcode in and storing it in a map and passing it as an input. Okay.
That's correct. So this is the way how it will look like. Just once again. So what we are doing is the postcode is broadcasted. So across just 2 minutes, friends. 3 people have raised their hands. Just 2 minutes. I'll just fix this. Then we will move on. So postcode is broadcasted across the nodes in the cluster. So let's assume there are 4 nodes. So a part of that broadcast data will be put into all those 4 nodes. Then you will have the actual code will go via a job to these nodes, and that is where it will join or look up the data. So I have got in the data file, I only have got the postcode. I don't have the city name along with it, right? So what we do is that it will join the data files and then do the processing. So this is what will happen. So you are putting something into as a broadcast variable so that it becomes easy for me, and it is already there in all the nodes because these are all standard locations. So let's assume we have got our job running in four separate countries, just for the sake of it. We have got something in India, something in US, something in Germany, and something in UK. So the countries is something that will be broadcasted across, and so that I can do the join between the country and the individual work that we are doing. So that is what is the advantage over here, Mati. Make sense?
Okay, yeah, sure.
Yeah, so some part of the data which is static data is what am I broadcasting for. Okay.
You declare that as static method, for class level and passing it into a final broadcast. Okay, got it.
That's correct. I'm putting it into a broadcast variable. That's it. No worries. Sure. Yeah. Tell me, Ashima, you had a question?
Yeah. So down the line, will we be looking at the the real database scenario? Because currently in our organization, how we interact with data is through the app, through application properties, through Java code, or from SQL Server, or some are using MySQL. So down the line, can we will we be looking into that aspect as well?
Of course, my dear.
Okay.
See, we have got 3 variables, right? So it's very good that you brought this question, so that even for the others who have this question in their mind, when we talk about Spark core, we were talking about all objects. Then the next thing what we have is something called as Spark SQL. That's what we will be doing today. When we talk about SQL, of course, there will be a database that will be involved. And like what I had showed it to you, scroll down, friend. Let me go down. After the caching and persistence example, and after the joins example, we have something over here that will be data frame and data sets, right? So this is all your SQL database, my dear.
All right. Yeah, I didn't actually look at that. So yeah, sorry.
Yeah, no worries, no worries. So this is where, and today you'll actually do the code also. So if you go down, and that is the reason why I had mentioned, right? You will have to create a Postgre SQL database. Okay, so we will actually see an example of how to put it into a database, and you can see that. And I had actually shown this also, right? See the tables called as project 1 and project 2 is created, and you can select it from here and you can see the whole thing. So we will definitely do that, Ashima. No worries on it.
Okay, thank you.
Yeah, you're welcome. And yeah, tell me, Kalyan, you had a question?
So if you go back to your code on the broadcast where you had the map.
Just one second. So let me go to the broadcast. Let me go up.
Where you
Just
had
one
the
second.
map. Yeah, I'll wait.
Let me scroll this example. Yeah, tell me, Kalyan, go ahead.
So does it have to be the native Java data type, or could it be a custom data type?
Hold on. So you're talking about
So
this
yeah, that
one?
one, right? So when I do Java Spark Cortex.broadcast and you're sending a map,
That's right.
does that have to be a native Java data type, or could it be my own custom data type?
It can be very well a custom data type. So what I'm saying is that what you will be broadcasting is just going to be a normal method that you will be calling over there. In that
So that,
normal method, you'll be writing a business logic of what you want, like
no,
what we're
that's
doing
not
in
my
the code
question.
over here.
Was so instead of a map,
It
right?
could be anything. It could be any return type. It need not be a map object. It could be a string object. It could be any type of collection.
Does it? I mean, again, so I'm talking about collection. Let's say if it wasn't. Let's assume for the sake of argument that there was no map in Java.
Okay.
Sorry, no map in Java, right? And I build one.
Okay.
Which is not supported by Java. And can I pass it in the broadcast variable?
You can do that as long as you have got the implementation of that in the current code. You can pass it. So the what we are trying to confirm is this can be any custom defined object also. That's what how I'll put it.
So, but basically, this is a driver program, right? The one that you're showing us. So whatever.
This is a driver. So
whatever I write in the main is a driver program. But
that's correct. So this is a driver program
on the worker nodes or data nodes, to be more exact. Right?
Just repeat the last part. I missed it, friend. So yes, this is a driver program. When I broadcast, it can be any Java code, friend.
Okay. Okay, I see what you're saying.
Make sense, friend?
Yeah, but then it has to be okay.
It has to be what, Kalyan?
So what I was thinking, just for, let's say we were doing some mathematical analysis on this one, right?
Okay.
So usually what we pass here is a set of functions on an object. For the sake of this argument, let's say we write a custom data type called as calculator.
Okay.
And we define the methods, call it as add, subtract, divide, and multiply.
Perfect, right?
Right. And then I send that calculator object on this broadcast variable. And if I scroll down, please, and let's say we had some numbers here. And here, when I'm actually sending this is where the processing happens. Right.
I can pass the whole calculator object over here, friend. I can say return calculator. I set here public static map, right? I could have set public static calculator.
Okay.
And I can have the method as load calculator throws file not found exception. In the calculator, I will get the input data from the user, what all things he is adding.
Okay.
We can do that, definitely possible. And in the real world, that's what we have done. Here we are using some standard objects, what we are saying, but in many cases, if you want to create your own custom objects, you create your own class, domain specific classes and pass it on. It will definitely work, friend.
Yeah, because the idea is you probably will have multiple operations done on the same kind of data set.
That's correct.
Right. To one good example that Mati was saying was in our previous example where she was pointing out the Canada, India, and the accumulator examples.
Right.
So I was just curious if we always have the ability to send something, basically a managed outcome, if I have to say, through that broadcaster variable.
It is possible, but what will you broadcast? Any variable which is going to be static, the values are static, you cannot change that. So only because once you broadcast it, you cannot have that object changes the value. So whatever are the default values of it, you can pass it as a broadcast. Okay, that has been sent to the multiple nodes. Okay, and then you join via your program, whatever data is there, you will join it in the individual nodes with whatever variables are there on that node, and you will get the result. That's the whole idea, friend.
Would it be fair to summarize that broadcast is basically we can send any custom data type which have functions that act on the data, and not really an instance of that object?
Once
Did I
again,
confuse
the
you?
functions that act on the data and not instance of an object.
So
you will have to pass an object to the broadcast, right? Some
no,
kind of an object. So when you said
so
calculator, I said yes. You can pass the
yes,
whole
so that's,
calculator object.
so in that calculator, all my functions have to be static. Yes
That's
or no?
correct. Has to be static. That's right.
Okay, so which means that I cannot really if it was not static, I cannot really instantiate that object,
No, you cannot
calculator
do that.
object to access all that. Okay, got it.
So that's the point. You cannot do that. That's right. It has to be static so that it can be accessed directly with the class name. That's the whole idea here.
Got it. So it's basic. I got that. Thank you.
Okay, you're welcome, friend. Okay, there were a couple of people who have raised their hands. I think Ashima answered that. Then I answered Kalyan also. Anybody else, friend? Just let me know. Okay, sounds good. So let me go ahead and create this and run this code, friend. So this is going to be the next example 14. Let me do that. Till example 13 I have done. And today also, after I finish all the examples, I will zip this codes and send it across to you so that you can download that, so that you'll have all the codes ready with you, friend. That's the whole idea. I will say file, new Java project. And this will be example 14. Let me create a package. And make it. Let me create a folder because I need to input something. Okay, the folder is ready. The name of the class that I will be having over here is called as UK Maker Spaces. Let me create that Java class. New class. And I will say finish. And in my I need to have two files. That is my UK Makerspaces identifiable data and UK postcode. Control C, and I'll put it inside my in folder. That's done. Now let me copy the imports statement. Here I need my utils also, so I'll drag and drop utils also. Control C, and I'll paste it. From my earlier example, I'll copy the utils.java also and put it inside my code. That's done. Now let me copy the whole public static void main code. I'm loading two files. One I'm putting it, broadcasting it. Other I'm using it in my code. Okay. Control C. I put it in my code. Let me add the jar file so that the code will get compiled. Go to my build path. Add the Spark jar files. And I will say, okay, perfect. There is some warning. That is, okay, I'll just say add suppress warnings. That's done. And I think that's it. Perfect. Let me do Control S. That's perfect. So that's all taken care of. And in the code, we have got everything. That's good. I've got my logger also so that unnecessary data would not be there. And let me run this. There we go. The main thing is look at the code to see what is happening, and the data will run. And yeah, there we go. So it will come back with the output, and you will see that most of the spaces have got 1. Some of them have got 3, but very rarely. Only Tower Hamlets have got 3 items, maker spaces in that postcode, and Manchester also have got 3. Otherwise, it is 1 and 2. 1 is more common. Glasgow has got 3, Cardiff has got 3, and that's it. Okay. So only 3 counties have got 3. Most of them have got 1, and some of them have got 2. Okay. So this is what you will have to see from the output and see how things would work. So I'll just wait till the time you finish this. Also understand how it is running. If there's any question, you can ask me also, friends. I'll just wait. So let's get this finished, and then we will finish off with our caching and persistence till our lunch. We will, right now it's about 11:55. We'll go on till about 12:15, 12:20, and then go for our lunch. So we'll have one more code to finish before we go for our lunch. But first, I would want you to compile this and run and see if you have understood it. Something in the chat window. Fantastic, Sean. So he's done that. Let's give a little bit of time for the others also. Good. So, yeah, that's okay, Kalyan. But then just try to see, you'll be coming in after the lunch also, friend. So we should start off by about 1:15, 1:20. That's okay. So you'll be missing this example, and you'll also be missing the caching and the persistence. That's what I'll be doing now. So just try to look over that and see what am I doing, friend. That should be it. No worries. Thank you and appreciate. So we'll give you 3 more minutes, friends. Let's finish that. Any questions? I'll be glad to answer. Muting myself for a couple of minutes.
Hi, Venkat. While others are working on it, I had a couple of questions with the course curriculum. I wanted to know. Yeah. So I'm more keen to also understand on the sizing and stuff. For example, how many executors or how many clusters, if I have 4 node clusters running in 2 cores, how many executors should I run at max and stuff like that. So are you trying to cover any of these things on the last day or the penultimate day? Or?
Okay, so there are 2 aspects of it. I think that was Akhil who was talking.
Yes,
so,
yes.
Yeah, that's great. So Akhil, what was told is there are 2 aspects to it. Yes, in the consulting, I normally do the admin part of it also, and I can definitely give you an answer. But then they wanted this to be more of a developer perspective and see how this can be done. So that's the reason why the admin part of it was not there. But then I can give you a broad idea about what the sizing part would be, and would kindly request you to bring this up on the last day once again, so that very quickly I'll give you an overview about how things are to be done, and we can do that. So I can give you an example of how we have done with our JP. How did we size that? Right now we are doing it for our city also, and see how that can be done. I can help you with that. No worries on it.
Sure, that would be great, because we have some architects also in this group, right? So and a few leads. So, and I understand there is a mix of developers as well. So there are different point of views that we need to understand as well other than the code. So I thought this is the forum where we can ask this, and it would be great even for developers as well to understand, how to size, and because at the end this has to go in production, and if it is running slow, it might be something to do with the sizing, may not be the code, right?
Very true, very true. In most of the cases, it will be the sizing and how you have made the system setup and all of those things. So I'll give you this, but then if you want to get into a little bit detail, I'll give you some resources, how open source resources where you can look at the document and see what all are the parameters. Because if you see, I haven't spoken anything about the runtime parameters and all of those things, because that is typically an admin thing. So That is what was told to me. But then the good thing that you brought this up, so I'll just tell the team that, okay, this is how, of course, I'll cover that from my side. In case if you need a little bit more, maybe a one-day kind of a session we can have, where primarily it will be for the admins, and we can cover that at a later stage also. Because,
would be great if we can at least tackle that on the last day.
yeah, we'll definitely do it on the last day to see, but then that will not be enough to be very frankly talking about it, because there are a lot of aspects of what the developer would be thinking and what the admin would be thinking. So that is what my viewpoint. I'll definitely cover it up on the last day, friend. But then there'll be much more than that, Akhil. So that's what I was pointing it out.
Yes. Well, that is one of the challenges that we are facing here. Yes. So that we have to migrate, let's say, 1 million transactions. So how fast can we do? So if we need to do it in 2 hours, 1 hour, how can we, the performance test is, what is the size? So there are some conversation on that sidelines.
True. So no worries. We will definitely do it on the last day, before or after lunches. We'll spend about half an hour, 1 hour on that. No worries on it.
Thank you. Really appreciate that.
Yeah, you're welcome. So guys, just wanted to check if you have finished with it, so that we can move on to the next one. So just checking up with the participants. Mati, have you finished that, dear, or still working on it? What about you, Sharat?
Done, Venkat. I have said done, but that's okay.
Yeah, that's great. Oops, sorry. Too many clicks. That was the case. Igor, almost finished, friend.
Yeah, I'm done. Yes.
Yeah, that's great. Thank you, Venkat and Nathan. And even Vishwanath have finished. That's great.
Venkat, this is Sharat. I have a question. So
yeah, please go ahead, Sharat.
What if we have to? I mean, the size. Both the sizes are like the data that we are checking against is very big. We can't. I mean, it will be huge, right? Like in memory. So can we broadcast, or are there any other techniques?
No. Okay. So if you're talking about a very huge size of data that goes beyond the memory of that particular system, you can still do that. But then what will happen is that the pagination part of what is there, so it will try to keep whatever is there in the memory, and we should avoid those kind of use cases, because then the way to do that would be to increase the number of nodes. So if you say that your size is going to be big, and ideally speaking,
I'm talking about the broadcast.
That's correct. The size of the variable that is broadcasted, ideally the reference data would be a small data frame. It would not go into gigabytes and all that, because the data which doesn't change. So only the data which is a reference data which doesn't change, those are the stuff that should be broadcasted. You will not broadcast your other variables where they are going to be changing over a period of time, or it might be changing on a daily basis or something. So only the things that in a relation database, we say reference variables, right? Only those are the variables that can be broadcasted. Sharat? Make sense?
Okay. Yeah, makes sense. I was thinking, probably there might be very big variable that if we have to broadcast, I think we might need to filter down the stuff from there and then do the broadcast and do the in multiple steps. Maybe that might be the case, but anyway,
that is one of the solution. So we will really have to see what do you want to broadcast it in our code. So although we might have 200 columns that will be there, we are actually referring to only some of the columns when we are doing a join and all those things, right? So we will really have to look at the use case and then look at what is the data that we need, and then try to narrow it down to a smaller set of data, and then that is what we will put it into our broadcast object. We will not try to broadcast it at a higher size. So again, this is important, because if you're having it as a higher size, then you don't have enough memory on the node for the other actual work to happen, right? Your broadcast itself is taking a lot of memory, right? So we should try to avoid those things, Sharat. Make sense?
Yeah, Venkat. Thank you. Thanks for clarification.
You're welcome, friend. Okay, so now let's get down to the next one, friends. So presumably all of you could have done this. So now we are going to go ahead with our concept of caching, or something called as persist, that is persistence. So let's see what that is. Let me go back to the document and see here. So many a times we would like to call action on the same RDD multiple times. And if we do this in a normal fashion, the RDDs and its dependencies are recomputed every time an action is called on the RDD. So this can be very expensive, especially for iterative algorithms. So when you're getting into machine learning, there will be a lot of this iterative algorithms when you would want to call actions on the same data set multiple times. And if you want to reuse the RDD in the multiple actions, you can simply request Spark to persist that particular RDD into the memory. So when we persist an RDD, the first time it is computed in the action, it will be kept in the memory. And this is another big issue, because if people who are creating these things and persisting it, if you forget to unpersist it, it will lead to very difficult situations. So ideally, if you're having something for persistence, you should always check in your code that somewhere it is unpersisted also. Okay, so it is not that you will keep on wanting to persist everything into memory. So you can use our other objects like what I said, accumulators and broadcast variables, and you might want in your code something to be persisted also. So you can do that in these two ways. So let's go back and look at this article. So go back to my docs page. Let me go right at the beginning and talk about persistence. There we go. So this is what is the RDD persistence. One of the most important capabilities in Spark is caching or persisting a data set in memory across multiple operations. So when we persist an RDD, every node that stores any partition of it that it computes in memory, and it simply reuses them in other actions. Okay, this will make the future actions to be very fast as 10x than what you're having. But then remember, caching is one of the other reasons also why the performance of a cluster goes down, because you simply went on caching some objects and you forgot to uncache it. So whenever you cache something, always remember, I have to uncache it somewhere, friend. I cannot keep it as a cache always. So caching is a very key tool for iterative algorithms and fast interactive use. The way how I cache it is using the persist or the cache method. For the first time when it is computed in an action, it will be kept in the memory of the nodes, and then you can go ahead and do this. If for any reason, if a partition of an RDD is lost, it will automatically be recomputed because everything in Spark is there in memory. So there are different levels of persistence. So these are the different levels what we have. There are 6 levels of persistence, and some of them is available only in Java and Scala. Your Python doesn't have that. The default is memory only. So it will store RDD as a deserialized Java object. If the RDD does not fit into memory, some partitions will not be cached and it will be recomputed every time at runtime. Okay, this is the default level. Then you can have it in memory and disk also. So it will store the RDD as deserialized Java objects in the JVM. If it doesn't fit into memory, of course, I will store the partitions that doesn't fit into memory onto disk also. Then we have got memory only in a serialized manner. This is better than the default memory because you are storing this as serialized Java objects. So please remember, this is something that is very, very, very important. You should not use the Java serialization. Okay, because if you use the Java serialization, that is very good for the default RMI kind of methods. You will have to use different fast serializers. So let's click on this fast serializer and let's go back. This is what is they're talking about data serialization. Try to avoid Java serialization. You should use a different serializer called as Cryo. So you can use this Cryo as a serializer or use different serializers based on your use case. Okay, so Cryo is what is there by default. So that is something that you can use to serialize things. It's very fast. And the size of the data that you will have, that will be very less if you're serializing it. You can put it into memory and disk in a serialized fashion. You can also put it into disk only, but then I have never used this use case. Why would I want to keep something on disk? You can keep it as the default is memory only 2 and memory and disk 2. Okay, so instead of keeping it in one place, we are storing it in 2 places. And you also have got something called as an off-heap memory that is being worked by Spark right now, but then that is in experimental mode. So there are basically 6 levels of serialization that you can use. Okay, so in Python, if you're getting into it, you have got something called as a pickle library, and you would need to do that. So the most important thing is which storage level will you choose? So there are different storage levels because you want to have a trade-off between the memory and the CPU. So you will have to select which one should I use. The first is if the RDDs fit comfortably into your memory, that is the most CPU efficient. If not, try to use the serialized versions and use a serialization library which is space efficient, like your Cryo. Don't spill to disk unless the functions that computed your data sets are very expensive. And try to use replicated storage level so that you can have a very quick, fast fault recovery also in case something goes wrong. Okay, so this is all about the way how you can use your caching. Let's go back and see it in the code right now. So let's go back to this code. So what are we trying to do over here is I'm having some values that is 1 to 5, and I will persist it in memory because that is what is the default storage level. What am I having? So only when you call an action on it will this get persisted. So see, I'm calling a reduce wherein I'm doing a multiplication on all of these things. Okay, and then I print out the value and I close this. So this is something that will be there always for us. So whenever you are persisting it, always remember that you'll have to unpersist it also at a later stage. Okay. So whenever your code gets finished, you would want to unpersist it also, friend. So these are all are the default levels of storage. I showed you that link. Okay. And also look at the link on which storage level to use. That is what is this one. See which storage level to use. Okay, so now let's go ahead and try this example. This will be the last stuff that we are going to have it before we go for our lunch. So let's go ahead and try this example. One second, let me close this. I don't need this. The Word document is what I want to try. So this persist example, please quickly try, and then we can go for our lunch. I will give, it'll take maximum over 5 minutes to finish this. So by your time, that is 12:20, we should go for our lunch. So let's quickly finish the example. And all of you ensure that you please try it out. Control C. First, let me create example 15. I haven't done that. So file, new Java project. Example 15, I will say finish. I will create a package com.eventkit. I will create a class that is persist example. New class, and I will say finish. Let me copy the necessary imports. Control G. Okay. Let's go for copy the public static void main. Oh, sorry. I don't have to close the closing brace. Control C. I'll paste it inside my code. Let me say save. Some errors are there. That's because I didn't put my default files. So add external jars. Apply and OK. It is all set. That's good. I gave an app name. Hey, before I go ahead, yeah, go ahead, Mati. You had a question.
Yeah, so in this program, we are saying that like we are going to persist in storage level memory only, right? Like, so it will take the system's memory since we give the local and star. It means it will consume all the cores in the local and or one
We are
core. I
talking about
forgot.
memory, not local. So when I say
Oh,
memory, it will store it
wow,
as
memory.
deserialized Java objects in the JVM.
Oh, JVM memory, not the system memory.
No,
Okay,
not the
okay.
system memory, dear. That is the
Okay.
second one. When I say memory and disk, that means it will store it in the JVM. Whatever is not possible to put it in the memory, it will save it on the disk also.
So if I, this memory is like, okay, so it will calculate and put it in a memory. And what is the use case for this? Once we store this into the memory, what is the use case? From there,
Oh,
we can do
okay.
the broadcast.
Yeah, so when we cache some RDD, the same example like what we did about the broadcast, right? So these are all variables that will be reused in my program very frequently. Okay, and it is very expensive to recompute it every time. Like for example, you have got a data set, you have got some feeds that is coming down, you do a complex calculation of it which takes a couple of minutes or a couple of hours, and that is going to be there for the whole day. So after doing the complex calculation, I will cache it so that for that particular day, all the other methods can directly go ahead and start using it. So that's a use case what we have for these kind of things. So there are two
So
ways of looking at it. Sorry, go ahead.
okay. No. I'm just understanding. And also it's a JVM memory, right? So if I restart my application, that memory will be cleared out and it will recalculate it. It's kind of a static variable, static.
Yeah, because whenever something is cached, it will be constant, right? It will be static. It won't be dynamic, my dear. So unless you
No,
recreate
not
it,
that static. Not that static. If I have a static variable in Java, it will. I can do a cache over there, and then whenever there is an application gets started, again it will recalculate and store that
no, this
value.
won't get recalculated. No, unless you again calculate that kind of a thing. So it won't do that again. So the use case for typically this is that whenever there are some data objects that is calculated after some complex calculations, which take a lot of time. So those are the variables that we typically try to put it into the cache. Something that is going to be very commonly used, and it is going to be, if I want to do it from scratch every time, it will take a lot of time for doing it. So I will actually go ahead and do it, put it into a cache in this fashion here. So those are the examples.
Okay. So this can be separated out of the processing application. So I can write a separate Java class and do the calculation and store it into the cache. And then the processing, right? Actual processing, whatever
Can use
we do.
this cache. That's correct. Can use this object directly and you can work with it. So what am I showing over here is how do you cache it? So this is how you cache it. Once this is there in the memory, this particular object is there in the memory, any other Java program can look at this particular integer RDD and it will be available here. That's the whole idea.
Oh, okay. Okay.
Little bit of confusion. Go ahead, friend. What was the confusion?
No. Somehow I got it, but Sarath has some good.
Yeah, okay. So yeah, go ahead, Sharath. You had a question.
Yeah, Venkat. You mentioned the broadcast variables are going to be on each worker node. So this cache is going to be, this persisted cache is going to be on each worker node, or how it is?
Yes, the cache will also, see, these are all similar things, but then depending upon the use case, you will want to see how they're doing it. So when I say broadcast, let's say there are 5 data nodes what I'm having, and I'm having assumingly 100 records that is there. Okay, so when I say broadcast, 20 records will be there on each of the machine because it will try to distribute it equally. So 20 records will be there, and that is the way how that will happen. So that is what is broadcast. Over here, when I'm saying that this is going to be cached, so it is not going to be on every node. So when I cache it, so it may be or it may not be on every node. It can be there only in some location. When I cache it, the whole object is what is being cached. So what we are talking about accumulator, broadcast variable, and caching is because these are all advanced Spark concepts wherein I don't want to recompute it every time, my dear. So
Yeah.
in the broadcast, it was there on individual machines, and then I did it. The cache is also very similar to that. Okay. The only thing is, if I've done some complex calculation, I don't want to redo that every time. If something is going to be repeatedly used, I will go ahead and talk about caching, my dear.
Yeah, I get that definitely. So this is going to be stored at some location, at one location only, and then
Not necessarily one location, friend. Not necessarily one look. It could be there in, let's say if you have got 5 nodes,
one
it
copy.
can be.
I would say one copy, right?
That's correct.
Okay.
There'll be only one copy of it.
Okay, so it is one copy, and it can be accessible from different Spark jobs, right?
Yes.
From the developers. Okay, I
Yes.
mean, I'm just saying until it resides in it, until you say like a uncache it or persist it.
That's
right?
correct. That's correct.
So we are doing sc.close over there. After sc.close, still it will be there, right?
Yes. Till the time I uncache it, it'll always be there, friend.
So what is the name that we can name it, right? We can name that
The object, the same object. I'm saying integer rdd.persist. So the name of the object is still going to be integer rdd only.
Okay. But how do we refer that in the other jobs? Like, because this is a variable here, we're able to refer, right? But we don't know how to refer it. But I think it might be next examples you'll be showing, I think.
No, here we are just trying to say that this is there. In the next example also, when we are referring to it, like for example, when I say persist, it is going to be there, storage only, that particular variable will be there. We'll continue with the same object and you can go ahead and retrieve the value. So right now I'm keeping it in memory. You can close this program and you can write another program where from where you're getting this value and you'll be able to do that also, Sharad. That's
how do we refer? I think there must be a way to refer to this particular object.
The same variable what you are using it for persistence.
Okay. I think
no, actually, sorry, I am not very clear on the last question asked by Sharath. Like Sharath mentioned that the integer RDD is defined inside this main class, right? Like if I'm having multiple jobs, so if I want to refer the same RDD, how can I refer? How can I refer that?
Okay, so to refer to it, you would require the same name of it, right? We always refer to an RDD with the reference of the same name. So what would happen is when you're persisting this with this particular name, with the same name, I can just say Java RDD and I can say my whatever is the, okay. You remember RDDs, once they create, they are going to be always persistent, right? That means you cannot change the contents of it. So once you store it, the same value is what is going to be there. So you will use the same RDD to assign it to some other variable and then use it in our code. So I would say Java RDD integer, let's say integer 1 RDD is equal to, I will pick up the same Java RDD which will be there because this is something that I'm persisting it always. So
you're talking only about one program. We are in general in whole application. I might be having different jobs running in different programs, right? How can I have that references over there?
Sure. So let me explain that. So I was actually talking about 2 programs. So in program 1, you went ahead and say abc.cache, okay, and or persist. Once again, I think I did a persist over here. So storage level dot persist, that's correct. So let me just say over here abc dot storage level dot persist, and I have kept it in a particular level here. Then in your program 2, okay, I can refer to the same object with the same variable. I can refer to the same object with the same variable. That's what I was saying.
No, in Java, it will not compile, right? Like if you are referring, you need an declaration of that object. So
hold on. So in Java, I will have to just, what I'll do is that in the break, I'll just try this example by trying to create another program which will do this. But the same thing is what is happening in Scala and the others, friend. By using the same
I
object.
got it. Actually, there is a way we can define this variable in a separate object in Java and then use that object everywhere, wherever it is needed. That's okay. That is another way, but yeah, I got it.
The concept is the same, friend. So would you mind to say what is the type of an object? Because I'm going to create a program very quickly during our lunch break, which is going to be persist example 1. So what would be that object? If you know, that's fine.
We can define this object in class level, right? Like Java RDD, integer RDD under persistence example. And then we can have persistent example 2. And
I'll
we can
keep
create
it as
an
a
object
static
for this
variable. I will keep it as a static variable. So I will say persist example 1 dot input integer, integer RDD, and that's the way how I can refer it in the other example also. It is possible to do that.
Is that possible? Okay.
Yeah,
Let's see. We have to work out and see.
Yeah, that's right. So I will try this in the break just to see how that would work. So that is the way how we can refer to this in the next example, friend. So that is definitely possible. I've done this in Scala and in Python, and I'm sure it will be done over here also. So I will just check it in our break and we'll fix it up, friend.
Got it. Thank you.
Yeah. Sharath, clear on this, friend? What we just discussed?
Yeah, sure. I think after I look at the program, I'll be clear. But I think I understood. So you can declare as a static class level, so that any worker can refer to that class.
No, any other Java program, not any worker. Any other Java program can refer to this persist object. I can get the value of it here because it is always it's already persisted, right?
Yeah. It is already persisted. Any other Java program I can do, even usual regular Java program also. But when I mention the worker nodes, it is different JVMs. You can still refer to it using that static variable.
Yes. So that's what I need to check up in Java. How do you refer to it? In Scala and Python, we can refer to it directly with the class name. Okay, so I just want to check in Java, how do we refer to it? And I'm sure during the break, I'll just try this out and show you how that can be done. It is straightforward. It should not be challenging at all, dear.
Absolutely.
It's definitely possible.
The reason is, like, I think if we want to run this, I think we need to have 2 Spark worker threads, actually, workers. So should be launching 2 worker nodes so that we can check, I think, right?
No, in that case, we'll have to create a distributed kind of a cluster. So what I was thinking is, in the same example, once this program runs, I will create persist 1.example and then do that. So these are 2 separate executions, right, Sharath? I finished my persist example.java, and then I'm trying it in another Java code. If it is not persisted, I cannot use that object at all, right?
Got it. Yeah, that's fine too.
So that's a way. So you can actually do it with a distributed cluster also, but then I'm just trying to see in a single cluster how to go ahead and do this. We can do that. So that's something that I will try, friend. Okay.
Yeah, I think it's an overkill to do maybe right now. Maybe.
That's correct. So I'll just check that out. Sure, no worries. So Ashima, you had a question, dear.
No, it got answered. What Sharath asked. I had a similar question.
Okay. So now the last thing that we have to do, friend, it's getting a little bit late. So let's just run this program. Okay. So this is how I am putting this in the memory. And since I am doing a count of this, it is going to give me the sysout and it's going to give me the count. See here? It's going to give me the count as 5 because I had 5 elements over here. And this is something that I can use it in another RDD and go ahead and use it. Okay, so that would be it for the time being, friends. So example 15 is where we have stopped this. Once we come back, we will talk about the various joins. And after that, we will move down to our data frames and data sets. So yesterday we saw everything about RDD. Today we saw our accumulator, broadcast variable, caching, and joins. And now we will be talking about the data frame and data sets. Again, the Ashima, the SQL example of how to insert it into a database will be done. Please ensure, guys, that you will be able to set up the PostgreSQL database also. So please do that, friends. So right at the beginning, I have got this over here. So just 1 second, let me go back. So please ensure that you have your Postgre database already set up. For me, it's already done. See over here, I've already done that. So we would need this before running the 2 examples of the database. So that's it, friends. So let's take up a quick break. It's about 12:30. So we will start again at, sorry, what was that?
Any version we can download, right?
Yeah, version 10 is the latest version what you have. So that is something that I'm having. So I think you stick to that, friend. So when I actually did that, so version 10 is what is there? See, PostgreSQL 10. So start with that here. Cool. So we will start again at 1 hour from now. At 1:30 your time, we'll start again, friends, with the last example of join. Let me go back and try to do this. Write it down here. We have finished example 15, and we'll start with join after the lunch break, and we'll join again at 1:30 your time. Thank you so much, friends. See you. Take care. I just checking, Sharath, if you're back.
Yes, I'm back.
Yeah. So Sharath, this was the example. Just have a look at the cheat sheet, Sharath. So this was the example of the caching, what I have done it in this thing before, and how you can see it. You will have to just check it. I've got the system ready, friend. So we had cached a small data set, just some variables. And if you go down to our 4040 page, and if you look at storage, you can see that the name and how it is cached. And you can see the time it takes in trying to get it from the cache, Sharath. So the beauty of Scala and Python is that we have this page that comes up, but then unfortunately in Java, we don't have that page comes up. So this is the way how the partitions are cached, and it can be reused if it is used in any other way, Sharath. So this is just to let you know that, and I've given you some good articles what I had taken from my cheat sheet to see how does caching work, and they also explain with some examples as to how caching can be. The first example is all talking about Java, although I didn't understand much from that, but then it's all the way how we can do that in Java also. So do have a look, Sharath, so that you'll get a view of it. And in about another 2 minutes, I'll actually show this to you also once others also come back, Sharath. Okay.
Sure, Venkat. I'll take a look. Thank you.
Yeah, sure. Thank you so much. So guys, it's about 1:30 your time. So let's go ahead and start. So just wanted to show a small example of how the caching works in your Scala, friend. Okay. So this is what I had done. So let me just put this in bold. Sorry, this is what we did at our lunchtime. So what is important is we parallelized a list object and gave it as small RDD, and then I am caching it, and caching will be done only when it is executed. That means only when there's an action happening will the caching happen. So this is a small RDD that I have cached. So see over here, I started with my environment. See here how I started with the small RDD, and then I cached it. And then when I say collect, it retrieves the value. But look at the time it takes for retrieving the value. So let me go back to the jobs. See, for retrieving the value, for the first time, it took about 1 second, and then it took about 93 milliseconds. Okay, so to retrieve the value. So what has happened is that for the first time, it took it from the actual storage, and after that, it started picking up. So 1 second, and see, where is 1 second and where is 0.1 second? That is 93 millisecond. It took less than a second to take it from the cache. How do I know that the data is there in the cache? By going to the storage over here, you will see that there is a RDD that is already there. See, it is already cached this, and 100% of that is cached, and the size on the memory is 192 because I've used the default caching. I didn't say persist. If I say persist, even the size on the disk would have shown to me. So this is the way how we can actually do the caching. Remember when we were before lunch, we were saying that whether how it can be done. So this is the way how it is done, friends. So whenever you cache it, you will see the benefit of it. And that is what is this 4 articles, what I have kept. I took a screenshot of my RDD, the storage part of it, the jobs part of it. And these are some of the articles that you should definitely look at for understanding the caching part of it, friends. Okay. So this was just as an example. So now let's move on. So I was just checking if Mati was here. She's not here, but Sharad, you can just discuss with her, and this is what I had shown actually. Okay. So great, friends. So let's continue from where we left off. Let me stop my WinSCP window because I wouldn't be needing that. Let me close this. Because this is the way how we have been using it in the other languages to see how it can be done. Unfortunately, in Java 8, we don't have an interactive way of doing it. So that's a challenge. :Q is for coming out of Scala. Let me close this. Just one second. Yep, that's better. So let me close my putty and let me close my VM also. Let me just say power off, so that I will get to use that memory in my current sessions. Otherwise, memory would be an issue. So even though I've got 16 gigs of RAM. Okay. So, hey, tell me, Venkatanchi, you had a question?
Yes, yeah. So again, going back to this caching, is this a central cache or local cache? Because what I heard earlier, if I remember correctly, is you're saying it's part of the JVM memory, right? When you run that program. So let's say I have like 10 other Spark jobs running on different sets of nodes.
Okay.
So all of them needs to access this cache. So are you saying like on each node within JVM's memory this will be cached, or is there a central location? And like let's say on server side you have a Redis cache, which is a externalized central cache, right? It has its own distribution within. But
okay, no, this is not. No,
yeah,
this is not that, friend. This is not that. Whenever I say cache, I'm referring to the cache from the perspective of Spark, my dear, because that is what's shown to us, right? So when we go down to the storage part of it, so this is at the Spark perspective. So whether if Spark is running in a single pseudo cluster, this is in that fashion. If Spark is running in a distributed cluster, this is stored at the Spark level, my dear. So that once something is cached, and if I want to reuse anything, I will directly take it from the cache that whether the RDD is cached. It won't go ahead and execute the whole thing, friend. That's what I was trying to say. Make sense?
Okay, because which means it is done at the Spark level, which means in the storage it will be there that can be accessed by applications running on any set of nodes.
That's correct. That's correct. So the storage is at the Spark level, friend. So also please remember, if you start putting a lot of things in memory, the actual memory that will be available for the execution will come low, because I will have, let's say, 1 gig of RAM, and if I take up 400 MB in caching everything, that means I only have got 600 MB for the actual execution of the code. So that is the trade-off that we will have to be careful when we are caching, just to ensure that we don't unnecessarily cache something, and we also will have to say uncache it. Like the way how you cache it, there is a method called as uncache also, my dear.
Okay, got it.
Okay.
So cache is at the job level only, right? Only for one job. After that job runs, it's gone from the from the memory.
No, my dear. So here we are running it at the so what is the meaning of a okay, cache is at in the memory level. If you want to store it in the location, there are multiple ways how you can store it in the disk also. Just once again, let me go down to just Spark. Yeah, there we go. And let's go down to programming guides. And let's go down to RDD persistence. And see here. So if you keep it right now, I've kept it in memory only. You can keep it in memory and disk. That means that it is there for multiple jobs in that instance. That means you can have. So when you said there is a JVM that is there, I think there was a small disconnect. I think I realized it now when our other colleague also mentioned about it, right? So this is at the disk level, and the Spark program can keep on accessing that cache unless I close everything, my dear. So that is what I was referring to, Sharat. Make sense? Or it really confuses more, friend?
Spark program closes. So Spark context dot close is going to remove this thing, right?
That's correct. That's
okay.
correct. But in the
So
real
that's for
world,
one job, basically one job.
no, my dear. If I'm running it in a REPL mode, okay. So that is what the difference is, friend. We are running it between Java and the other things. I can keep on running it in a REPL mode, multiple executions, right? So if
Yeah,
one
REPL
job
mode.
is storing it in the cache, I can keep on reusing it by the other objects also. It's not like Java is one execution, my dear. That's what I was coming to.
So in REPL mode, that's different because REPL mode is considered as one session, one job session. So that's where it's being, it's available as many times that you run. But outside the REPL mode, when we run Spark submit, so I said
Okay.
Spark submit job one, Spark submit job two. So in job
Okay.
one, I create a cache.
Right.
And did not uncache it, and then in the Spark submit, another Spark submit
You will
job.
still get it till the time you close your Spark. That is what I'm saying. So in job
So
one, once you run it,
till the time you close the Spark means what? Actually, in job one, Spark context dot close, and in job two, there is another Spark context dot close, right? So that's what you mean. I didn't understand. So you open
okay.
the cache in
Hmm.
one job where we use the Spark context, and then at the end we'll say Spark context dot close in job one, and job two is of different program, totally different program, different,
Okay.
and that will have Spark context, and then we'll do it and Spark context at close. So when you say Spark close, what does it mean? Is it like
That's correct. So in case if you have got something wherein you want it across multiple invocations till the time I run it. So typically in the real world, in a distributed cluster, what you will do is that you won't have to say close explicitly. Although in our Eclipse also it's giving a warning, and if you go down to our normal Scala also, you don't have to close it in the last line. So once you create a Spark context for one program, that means multiple jobs keep on running in the same Spark context, because this is going to be a common distributed environment, right? It's not like I start a job and I close a job, right? Then the concept of caching and the other things will not come at all, because it's only there for that particular execution, right? Makes sense, Sharat?
so Spark dot context dot close is not required. So
Not
when we
required mandatorily, no. So even in our code, if you don't write that, we were getting some warnings. That's the reason. It's not a crux that I have to always close it. So see, even if I don't close it, okay, it is perfectly right. It is just giving me a warning. See, it's a resource leak which says it's not closed. I can still go ahead and do that, and when I go ahead and start with the next one, I will get the same Spark context. Like for example, here we are creating a new Spark context every time. So I just wanted to show you something with reference to this only. Just one second. Let me not this in the document. Let me scroll down. When you start with your SQL part of it, look at the way how it is written. Go back to the code. See here, what do? We create, right now it is Spark context. We will start with something called a Spark session. When we go down to the SQL part of it, we will say dot get or create. That means if it is already available, I'll simply get the Spark session, or for the first time I will create it. That means it's going to be like a singleton object which is always available. If it is there, I will simply get that object and I can use it, friend. Make sense now?
okay.
So that means I won't go ahead and creating a new session every time. So because we have got multiple execution paths that will be happening, and it is going to be done in the kind of a real-time mode when we talk about micro batch, when we talk about Spark streaming and all of that. For that, I don't have to start this every time. Yes, in Spark context, we create our sessions in our Eclipse every time, in our Java code every time, because that's a part of creating it. But once you get down to Spark SQL, there's a method called as .get or create. That means if it is already available, I'll get the same handle to it. If it is not available, I'll go ahead and create it.
Okay, so if I can see the code of another Spark program that we wrote like a persist example, right? If
Right,
we can
right,
write persist example one and access
hmm,
that same cache, how
right.
to write it? You know, the another example.
See over
We
here.
write
So
it-
just one second. So in fact, I didn't look at this to see. So what you would do is that you don't have to get the Spark conf created. So what you can do is that you like a normal builder pattern. So we have got a builder pattern in our Java, right? So I will have this created only once. And every time I will use a static variable to ensure that I have got this object already there. So here we have to create a Spark conf every time a new instance of Java Spark context is created. But then if it is kept in a standard builder pattern with static variables, I'll simply refer to that. And once it's created, we will go ahead with that. The same way what we're going to do in Spark SQL in the coming programs. Luckily, because all of us use our SQL way of doing it, right? So they already have this method of how to do it. Either you say .get or create. If it is not there, it will create it for the first time. If it is there, I will not create a new Spark context every time.
Okay,
In
so let's say get or create. We already used it, and now
Mhm.
how are we going to access input integers in the new persist example one? How
Okay,
are we?
so what you will have to do is, depending upon this, if this was already available, this SC object without saying new, I would be able to get a handle of this SC object directly. So in
Yeah.
Java, yes, I have to just go back and check. I checked it up a little bit in Java, but was not able to get hold of a easy method how to do it in Java, friend. But then in the other, and if you look at in Java also, see over here, when we start with our SQL API, that's when I look at the SQL, the same thing is there. Look at this particular code, friend. What do? We say Spark session dot builder because there
Yeah.
is a builder pattern, and then I will simply say dot get or create. That means in the code, if the Spark session is already available, it will give me the same Spark session, and I'll be able to use the same cache variable that I have cached, right?
Okay, Venkat. Let's say, yeah, we got the same Spark context. Let's
Mm.
assume that we got same Spark context, right?
Okay.
So after that, what do we do to get that, to use that cache in the another uh, program, which is called persist example one?
That's correct. So what you will have to simply do is you will, through the object, once you got an access by which of that particular variable, all that I will have to do is, let me go back to the earlier example.
Mhm.
So once it is cached, in fact, let me go back to the diagram. See over here, if I just write this line called as dot cache, then that means it is already available for me. And then I can simply, the next time I use my small RDD object, the same variable name, I will simply reuse it. So I will
No, no,
have to
no.
use the same RDD object name, Sharad.
In the another program, another, not in the same program,
No,
not
in
in.
another program. That's what I'm saying. In
Yeah,
another
how
program
do
also.
we get that? Can you show me? Can you write the code actually?
I can show that in Scala. In Java, a particular way, because like what I had mentioned in Java, we'll have to just see how the builder pattern would work and how that can be done. So just give me some time.
No, I'm just only asking the reference of small RDD, how I can get in another program for persist example one. How do I get that? You know, I know. You explained me several times about in the same program how you do it, how you get
Okay.
that context. I mean, existing context and everything. I understand that, but I
Okay.
have persist example one, persist example two. persist example one we wrote,
Right.
and then in there we used small rdd.cache, and in persist
Okay.
example 2, how do I refer to that small rdd.cache? I mean small rdd, not the cache, like small
True.
rdd.
True. So once you have the same variable, like what we are seeing over here, Sharad, just one second, because I don't have the complete example. So that's the reason why I had to just scroll up and down. So just look at this one simple example. So let's go back over here. So once we get the same handle, see, once the environment is the same, the cache will be the same, right? Because I'm using the same Spark session, I am doing this. So once I say over here, through this Spark variable, when I use something to put it into the cache, like the way I'm referring to it, through the same static variables, so that I can reuse it in the other code also. So that's the way how you can do it.
Can
So
you tell
I
me
would
that
suggest
statement
just
how?
give me some time for today. Let me go and come back with this concrete example. Let it be
Okay,
Scala because that's something that I have worked with, and I can actually show that to you, my dear.
no problem, no problem. Yeah.
Yeah.
Thank
Because
you.
what I'm trying to say is it's actually possible. Because when we look at it from a Java perspective, we think that okay, that might not be possible, but then it's actually there, my dear. And in fact, if you look at this code, what I've shared with you, they've given you some example of it also. Just once
But
again.
I'm not saying it's not possible, but I wanted to see not in REPL mode actually, in a regular Scala
Spark submit mode. Yes,
submit.
yes, yes. Yeah. So what I would just request you is just look at this particular article, okay, just to see the way how they are actually done this, and let me try creating an example and show that to your friends, so that at least you'll be able to see it in two separate programs how the same cache is being used. Sharon, I'll
Sure.
actually come back and give an example here. Okay.
No worries. Yeah, thanks.
Yeah, sure. Friend. So this is really possible. That's the reason I'm emphasizing so much, so that you would know that once an object is there, I can really reuse it. Friend. Okay, cool. No worries. Friend. Thank you so much. So now let's move on. We have got the last example that we have left in our code. That is what is joins. And after that, we have to go down to the SQL part of it, friends. So let's look at the joins. There are various types of joins. So let's go back to the code. That is, let me scroll up a little bit. And this is that example. So we are trying to do our example of 16. So what we are trying to do over here is we again created the conf, got the context. I'm using parallelize. So creating two Java RDDs in which we are having it from a list. Tom and his age is 29, and John and his age or ID is 22. Again, create another RDD that is going to be again John and James. So if you see over here, John is something that is common over here in this RDDs. And then we will see how we can play around with the various join. There are various types of join. So there is a left join, left outer join, right outer join. The default join will be called as an inner join. And then there will be a full outer join also. So we will use that join, okay, and to see how we look at ages and addresses to join that and save the data in some file so that we can actually see the output as to what is happening there. Okay, so that is what is the objective of what we will be doing. So please remember, in the example, you'll have to ensure that the out directory is created. Like how do we have in, right? We will have the out directory created. We will run the code, and you will have 4 folders over there. And in that, you will see how the default joins are working. So that is what is the example that we are going to see in the case of joins. Of course, when we do SQL, you will have the own joins over there. Okay, so right now we are seeing joins in our RDD. We can do the same thing in our SQL also. So let's go ahead and create this last example, friends. So you can actually try it out. I'm going to do it on my system. So copy this joins, go back to the example, and I think this was example, once again, yeah, 16. And let me go back and check. 16 is not there with us. So let me create example 16. Here, Java project. I'll create it as an example 16. I will just say finish. Let me create a package. It will be called as the Venkat. The class that I have to create would be called as join operations. Copy that. Right click, new class. We will call it as join operations. Finish. That's good. Let me import the necessary things. So there we go. Copy the default imports. Paste it in the code. There we go. Let me change this way at the top. It's perfect. Let me copy the public static void main now. Just once again. Just wanted to clear my code, so just mute it myself. Now let me copy the public static void main. Here we have to create the out folder also. Okay. So Control C. I will paste it over here. Let me create the out folder also. New folder that is called as out. It's perfect. Let me have the dependencies here. Go down to my properties. Go down to Java compiler. Build path, and add my external jars like that, and say OK. So we are all set. And let me run the code now. A pretty simple example where there are two RDDs. The first one is ages. I've got Tom and John. And the second one is addresses. I have got James and John. John is common in both of them. And we are trying to have the different types of join, the default join. Then we have got a left outer join, a right outer join, and a full outer join. Let me run this. Right click. Sorry, you can directly do it like this. So I'm running the code so that the necessary folders will be created for us in the out directory. It's surprising. I thought I clicked the button. Maybe I didn't do it. Let me do it once again. Otherwise, I should see the console coming here. That's what I was wondering. So I'm doing it once again now. Yeah.
Right.
Sorry.
No, that's fine. It came up.
Yeah, that's right. So because we were doing that for the first time also it worked. That's the reason it said that file already exists. We'll just refresh this directory. So you will actually see the files there. See, I've got the files inside my out directory. So let's go ahead with the simple join and look at it. So the simple join has got John, which is there in UK. Once again, let me check what is the simple join. Now folders, let me check that out so that we will be there in sync. Let me close this. I don't need this. Let me go right to the bottom. Okay. So the default join is age address dot join. Okay. So this should have joined and I should have seen my, yeah, I think that's correct. John itself came. So John has got both the two values. That is the first value, that is the age, and the second one, the location also. See, John is what is common. So you see both the values that is coming in. That was for the normal join text. Then for the second one, hey, we had some doubts.
Yes. So
yeah, please go ahead,
yeah,
Vishwanath.
Marty.
What was it? Or we
No,
also had Marty. Yeah, go ahead, Marty.
Okay. No. Actually, the tulip 2 means like 2 entries, Tom and 29. So when we are joining, it might be 3, right? How we can define, like you say integer, comma, string. So integer
Okay.
is John.
No. It will always look at the first column for joining. So it is going to look at always the first column for joining, and that's how you got John and John. And the second column was a tuple of 22 and UK. That's what you got here. See, that's the way how it came
Okay,
here.
so but the join returns the object as integer comma string. So what that means, like that is what we are expected, right? Like to leave integer. So we consider the USA the John as integer. So the return type, right? Like
No. The first is the string, that is John, and then it has got a tuple of integer and string, that is nothing but 22, and the state, that is the age and the country from where it came. So that is why we have got integer and string.
Oh, okay. Sorry. Okay, got it.
Yeah,
so we define here based on that it is coming. So if we define tuple 2 and string and comma integer, it will come in a different fashion. Okay, got it.
What I did is I know the way how the output would come. Based on that, I said that this is going to be in that particular format. So based on the example of how it came, this will be the join criteria, and the results will be the first one on the left and then on the right. So that's how I created this. First, I created a string, and then I created a tuple of integer and string here. That's the way. Fine.
So always the output will be like this. If I have tuple, you said 22 until 22, I can use, right? So if I have 5 tuples, so in that case, also first thing will be a string, and then remaining tuple 5 will be like.
That's correct. It will be based on whatever is the type of it. Like for example, when I do a full outer join, just look at the output of the full outer join. See here. So one was empty, other one was the age. That means he only got the age, whereas you did not have anything on the second one. But for James, the first one was empty and he had USA. And for John, it was 22 and it was UK. So this is the way how the outputs will come depending upon the type of the join method. Make sense?
Okay, optional. Why it is coming as optional dot
No, that is the class.
optional.
That is the class. So that is the class what we have. So that is the thing that we will be doing. So this is what is the class that we are having. So it's actually giving you the type of the class. See here. The empty thing, it is showing it as empty. And for the other things, it is just coming it as the name of the class. And inside that, you have got the actual value right here.
Okay, since we are expecting some empty value, we have to put optional class on it.
Yes, it will come by default in the case of a full join and the others. Like for example, see over here, in the case of a left join also, you have this. In the case of a right join, also you have this. In the case of a full out join, you have that. And the first example, what we saw was only the one that is common, which has got both. So that's the reason why I did not have this optional here.
Okay, got it. Thank you.
Perfect. We had one more colleague. Yeah, tell me, Vishwanath.
Yeah, so first one is, so based on this logic, so it appears like I can read data from 2 different files, create these tuples, and then perform joins, right? I don't have to necessarily persist those anywhere in any database physically. Is my understanding correct?
That is perfect. Here, I just saved it as a text file so that you can actually see that. Or I could have just did a dot collect so that I could have seen the output here also. So instead of doing a collect, I just saved it.
Okay. So even the input, I can fetch it from different files, create this stuff.
Very much. So see over here, how am I fetching it? I have deliberately said parallelized pairs. So instead of that, I could have said sc.text file also, so that I can read from a file system at a particular path also. That is also definitely possible, Vishnu.
Another question is, can't I change the join attribute? Let's say I'm reading from a couple of CSV files. Each row has more than 2 columns. So I want to join on X column in file 1 with Y column in file 2. That's not possible.
No, not possible. The first thing over here is it will always look on the left. So what we should do is before joining, we should ensure that the column that we want to do a join, that should always be the leftmost column. So you see that the join always happened on this John only. It did not happen on the other value. For example, if 22 was here and 22 was here also, it will not happen on the second column. It will always happen on the first column.
Okay, so in that case,
To his question, to what Vishnu was asking, it is Akhil. So if there are two CSV files, it will always join on the first
That's right.
column of the CSV, is it?
That's right.
At least that's smart. It's good.
Yeah. So that's the way how it works. So in case if you have got the elements in some other place, you will have to do a transformation and get the elements in a proper order before we do a join.
At least the first element, because remaining is just a join. So
that's correct. You should always have it as the first element.
Okay, that's good. No.
Sure. So that's great, and I think that was the answer. So that's good. So now let's go back and look at each of these things. So the first one was.
I have a question. Sorry.
Yeah. Tell me, please.
So if I have a CSV and it has more than like 50 columns, right? So in that case, how can I do this? Yesterday also Sharat asked, like, if I have 250 to or something, right? Tuple, right? So how can we do that? Here only 2, we are giving tuple 2.
Right.
If it has more than 50, what we have to do?
You will have to do it in such a way that you will be able to put it into a type. Remember, yesterday I had mentioned that there are multiple tuples. So the tuple that is there, the highest number of the tuple, that is 22, what we are having. So you will have to ensure that it is as per the same data type, what we are doing. If you're looking at the SQL has a far more better way of doing it. That's what we'll be seeing later on. But then by using the Spark core itself, it has got this limitation that you will have to convert that into an object and then do it, my dear. So
convert that an object and then you can do. Okay.
That's correct. You'll have to do it in this, and then you can go ahead and then try it out. So it has got multiple tuples. This is only for tuple 2. Like this, you have got till tuple 22. Yesterday I showed that, right? So just remove
the but in Excel sheet, we might
values.
be expecting more than 22 columns sometimes, right? Like a huge amount of data. Okay, got it. But we need to make another step of converting that to an object and make it as a tuple key.
That's correct. You'll have to create it as tuple 22 and then go ahead with it.
Okay, got it. Thank you.
Cool. Yo. Okay, friends. So let's go back. I think I have executed this. I just want a confirmation that please try this out so that you can see that particular output. I'll just lower the hand. So that's good. Yeah, Ashima, you had a question, Ashima? Okay.
I forgot to mute.
Yeah. No worries. So that's perfect. So cool, guys. So this was the various ways how we can try that out. So we just kept this, I just gave this as a simple example so that yes, join is possible without getting into the SQL part of it also. So this covers up all the basic aspects of what the transformations and actions are, friend. So if you see what we have done, so at the broad level, we have got something called as Spark core. That is what we saw right now. That is what we have seen till now. Then we have got something called as Spark SQL. That's what we are going to start with right now. Then we have got something called as Spark streaming. Okay, and this is wherein it will load everything in the form of micro batches. It's not real time. It's in the kind of a batch, but the batch level is very small. So that's why it is micro batch. And then you have got something called as Spark ML, that is machine learning. And finally, you have got something called as Spark graphics. So let's go ahead to the next level, that is going to be Spark SQL. So let me go back to the document. And some of the best practices, always look at this Databricks site of how do I optimize my Spark SQL joins. So a very good article has been given by a female called as Vidaha. So you can look at this. So let me click on this. Hey, you had a question, Mati. Please go ahead.
Yeah, so it is like a generic question related to files, right? Like a HDFS. So in our programs, we have seen like feeding the data from our local system and getting the output to our local system, and also using HDFS. So what in which case we need to use I was out of that. Why should we go for HDFS? Or should we use the file system which we have? What is the difference? And
Okay.
I got little confused.
Yeah, no worries. So let me explain that. So whenever we have a distributed data that is going to be huge data, so it is not possible to be there in a local one system at all. It is going to be in a distributed manner. So whenever we have distributed huge data, we will always be using HDFS. So when you say that you wanted to do some of these joins, and even one of our other colleagues, that is Ashima, also said, hey, we are using our relational databases, and we wanted to see how to do joins using those things. So the first aspect is the relational databases are not distributed. So HDFS gave a way how things would be distributed in multiple machines so that it can be processed in a parallel way. So the distribution was the first aspect that came about with your HDFS. Then came something called as Spark. So this came in 2006. It's almost, sorry, 2006. So it's almost 13 years since it is already there in the market. Then came something called as Apache Spark in 2014. So this was open sourced in 2014. So in the last 5 years, what Spark has done is you can do all the things using in-memory. So if you look at how the other organizations are using it right now is they have HDFS, they were working with MapReduce, but Spark gives a way how things can be processed in memory in a very, very good manner. So that is why Spark became very popular. And what people did is, hey, if I want to load data into Spark in a distributed fashion, I will load it from HDFS itself. So Hadoop was a way how people loaded all the data into the Spark. So that is what was happening traditionally. But since we are having an example over here where we're trying the small examples, so that's the reason why instead of using Hadoop, we are loading the files directly from our local file system. We saw how it can be done through Hadoop, but then we're again loading it locally and see how it works, right? So that's the base what we are talking about now. Make sense?
Okay. So if my understanding is correct, instead of MapReduce processing, we will be using the Spark, similar kind of MapReduce processing using in-memory, and we distribute the data using HDFS.
That's correct. The data is distributed using HDFS, but even in Spark, the data in memory is also distributed, right? So if you have got 4 machines, you can decide, and each of them are quad-core kind of machines. So totally you have got 16 cores. So you can decide how the data has to be distributed at Spark also. Should I give all the 16 cores, or should I give them some lesser amount of cores, so that because multiple people will be accessing the same data, right? So what people are doing right now is using advanced way of doing it, because in 2006 to 2010 we were using the concepts that was available at that time. So at that time multi-core was not a common thing. Then multi-core became a common thing, and that is what is possible in a Spark, and that's how you go ahead with this. Okay. So that's the whole idea about the storage will be in HDFS, and the processing in a distributed manner will be there in Apache Spark.
Okay. Got it. Thank you.
Sure. Yeah. One more person had a question. Please go ahead, Venkatesh. You had a question.
It's Vishwanath.
Sorry, Vishwanath. Go ahead.
So I see that in this program, most of the time we have joined only 2 sets of data between left and right. But generally in typical relational, we can join multiple tables with different types of conditions, right? Outer, inner, anything. Because data doesn't reside in one table most of the, or 2 tables most of the time. So if I feed multiple input files into HDFS and read through Spark, let's say, can I join in one shot? I'll make sure the join column is the first one in the tuple, as you said. But can you do that?
But you can join only two entities, right? So even if the data is there in multiple places, you have ensured that the condition on which I have to join, that will be the first one. You will have to ensure that once I join, so at any point of time, the join will take only two entities at one time. That can be further joined with another a data set also. So let's say you have got three tables. You can join the table 1 and table 2. Okay, then the joined table can be joined with the third table. That's the way how you will proceed. That is definitely possible.
But I had to do it in multiple steps, not
You
like
have to do it in multiple steps, because join at any point of time, even in SQL or in Spark right now, it can do only two things. Because even in SQL, you won't be able to do multiple things unless you have got a subquery and those kind of things, right? So those kind of things are possible with something called as data frames for us. So that is definitely possible, my dear. But then primarily it will be just two things, left-hand side and right-hand side of the join operator. That's the way how it will work here.
Okay, thank you.
Okay, cool. Okay, friends. So this was the last one that we had seen in our Spark core. So let me close this example 16. Let me go back to this. Sorry, I should say Apache Spark that came over here. So that's perfect. And this is what are the 5 parameters what we have. So now we will be talking about the Spark SQL part of it. And I have loaded one example. Let me just resize that, because it's pretty irritating that the top window section is getting hidden. That's okay. Yeah, that's better. So if you look at that link, this particular link is by that Databricks female called as Vidaha, wherein she's talking about what are the various ways how we can play with joins. So she's talking about shuffle has join, the broadcast has join, how to deal with skews when we talk about the joins, what is Cartesian joins, what is one-to-many joins, the various theta joins. So she talks about all of them in her article and gives you a broad overview about how things can happen, friend. So I found this to be very, very helpful when we were doing some examples. So that's the reason I thought I'll share this with you so that it'll be clear as to how that can be done. So that's something that you can look at. Now, let's move on. So what are we trying to see over here is Spark in a typical data processing scenario, you will have some raw data. Then you will after doing ingestion, you will get your raw data. You will talk about your data quality, get your peer data, do various transformations, and finally you will have the data that you want to do, and you can get the actionable data that you want. So that is what Spark allows us to do. Do a whole series of transformations like the way how you were doing earlier using a Spark SQL. You can do that in Spark core, and that's what we had done, friends. So this is one use case. The sequence diagram for the various data scientists who will use Spark is, when we talk about data scientists, they wouldn't know much about the Spark core way of doing it. They would know primarily SQL way of doing it. So let's see how they go ahead with this. So they type in some code. It could be in Python, Scala, or in R. Load data from a data source. Then it will tell Spark to load that particular data source. And where do they work? They work primarily with something called as notebooks. So you will have the Jupyter or your Zeppelin notebook. So tomorrow we will see how to do the Scala-based notebooks that is called as Zeppelin also. I'll give you an example on that, but that will be tomorrow. So we will get that data, then the data come back, then they say it's okay. Then you would want to further go ahead with the data that comes, apply some transformation or an action, tells Spark to apply that transformation. They will do all of that in the notebook so that you don't have to actually run this. Okay, and then it will come back with the results and say that it returns the data. And if you want to do something further, they will go ahead and continue with it. So this is the way how the complete flow of things happens when we are talking about data science. When we are talking about a data analyst perspective, even that would be a SQL user who wants to analyze the data and then continue on with inference. So that is where SQL becomes the de facto layer of how things would work. And that's what we are going to do in the current example. So let's talk about Spark SQL. So to work with Spark SQL, there are two ways of doing it. We have got something called as a data set, and this is available only in your Scala and in your Java. In your Python and in your R, we don't even have something called as a data set because that's an object. In Python and R, we call it in the form of a data frame. Okay, so the concept of data frame is there in your Spark and in your Scala also, sorry, Java and Scala also, but from version 2 onwards, we have moved away completely from data frame to the data set. So you will not look at anything called as a data frame at all when we are doing Java. We'll always focus on the data sets. So let's look at what this is. So Spark SQL introduced the tabular data abstraction called as data frame way back from version 1.3. It is the data abstraction for working with structured data. So when we talk about Spark SQL, we are all talking about structured data frames. It uses the capabilities of RDDs and applies a structure called schema to the data, allowing Spark to manage the schema and parse the data between the nodes in a much more efficient way than using Java serialization. And it is inline RDD, and the data is organized into columns like a table that you have in your relational database. A dataset is a very strongly typed collection of your domain-specific objects that can be transformed in parallel using functional or relational operators. So each dataset also has got an untyped view called as data frame, which is nothing but a set of rows, what we are talking about. But in Java, we always have everything in the form of a data set. We don't have anything called as a data frame. Okay, but internally, in many cases, the concept that is used is called as data frame, because when we go outside a object-oriented programming kind of a language that is outside my Java or Scala, what is used is the way how I process things in a SQL fashion. So that would be a data frame. The beauty what a dataset gives us is that it gives us two things. It has got a optimizer which optimizes the code. We will see what are the steps in the optimizer very soon. Plus, it has also got something called as a tungsten component that is there. So both these components are listed for you. So just 1 second. I'll show you both these components. I've given the URL so that you can play around with that. So you can see how you can deep dive into the Catalyst optimizer. And this is what the Catalyst optimizer is doing. So I'll come down to this. And then the second thing is what is tungsten. So how you move away from the languages and see how you can go down to the bare metal and start working with it. So these two packages are very, very popular in your data frame way of doing things. So let me go back to the code, what we were doing. So Spark session is an entry point for your Spark SQL. It is the very first object that we create when we develop our SQL-based applications. Then using the Spark session.builder, we can create an instance of the Spark session. If it is already there, you can say create, get or create. That means if it's already there, you will get a handle to it. And of course, we can stop the Spark session by using my spark.stop, the variable .stop. So it is very important that we should know about all the three things. What is an RDD? To some extent, we have got a data frame, and then what is a data set. So let's compare all the three components with respect to 8 different ways of looking at it. So let's start with it. The first way would be when it was released. RDD has been there right from the basic time. So right from 0.4 onwards, I know that RDD is there, although they're saying that it's from version 1 only. But right from the beginning, the whole abstraction is in the form of an RDD. Data frame was introduced in 1.3 because they wanted to show things in a much more SQL way, because a lot of SQL users were using it and they wanted to make Spark as a language where it will be comfortable to them. So that's how data frame came, and dataset was introduced much later in the version 1.6 onwards. Right now we are working with version 2.3 frame. So that is as far as the Spark release is concerned. Talking about the data representation, your RDD is a distributed collection of your data elements across multiple systems. So it is a Java or a Scala object that represents the data. If you talk about RDD, a data frame is again a distributed collection of data organized into columns. Okay, so ideally, data frame will be similar to a table what we have in a relational database. And dataset is just a further extension to the data frame that it provides. So it gives it type safe, it gives you the object-oriented programming interface, and it will give you the benefits of using the Catalyst and the Tungsten optimizer. So all these things bring up together into something called as a dataset. We will always use dataset in our Java-based languages. The third part of it from the data format would be using RDD, you can easily and efficiently process data which is structured as well as unstructured, because in RDD, you don't have to say anything is structured or unstructured, right? But like data frame and data set, RDD does not infer the schema. So the concept of schema was never there in the RDD part of it. Okay, whereas in data frame, it works only with structured data. So a data frame means you cannot work with semi-structured data. So if you want semi-structured, you have to go back to the RDD way of doing things. It organizes the complete data into column-based, that is named column, and Spark data frames allow Spark to manage the schema. Dataset is also the same thing. It represents data in the form of JVM objects of row or collection of row objects. So that is for the data format part of it. Then from the data sources API, RDD has got a way how you can read the data from any data source, okay, and it can easily handle data with no predefined structure because the schema is not there at all. But when we talk about data frame, this is where it becomes very popular, because whether you're talking about a data frame or a data set, it can read it in various formats. CSV was the common. After that, we have got something called as an Avro format. So when we talk about an Avro, Avro would mean that the structure is of the data frame would also be there in the Avro format. So we will talk a lot about this Avro format when we talk about two different objects trying to communicate with each other. Let's say you're an upstream and a downstream. The upstream will give the data to you having about 20 columns. The downstream would just want 5 columns. Maybe it's a combination of some set of columns on the upstream. And that is why when the schema changes, everything will be in the form of an Avro. You can also put something in the form of a JSON. You can also have something in the form of Hive. So this is important because although we are using Spark SQL, okay, you will see that in HDFS, there is nothing called as Spark SQL coming. Everything will be stored in the form of Hive only. Okay. And dataset API will also support data from different sources. Primarily, it will be the same set of sources like what was there for data frame. Then comes the fifth one, the immutability part of it. So RDD contains collection of records which are then partitioned, distributed across the nodes. The basic unit of parallelism is the partition. So each partition is one logical division of data which is immutable, and they are created through some transformations on the existing partitions. So we can move from RDD to data frame using something called as 2DF method, that is 2 data frame method, but you cannot do the reverse fashion. You cannot go from a data frame back to an RDD. That's not possible. When we talk about data frame, after transforming it into a data frame, you cannot regenerate the domain object. You cannot go back to an RDD. But in a data set, that is possible. Okay, it overcomes the limitation of data frame to regenerate the RDD from a data frame. So this was the fifth one. Then talking about compile time safety, that has been provided by all the different objects. Talking about optimization, unfortunately, you cannot do any optimizations in your RDD way, but within your data frame, definitely you can do that. Okay, so data frame uses the catalyst optimizer, where there are 4 phases: analyzing the logical plan, you will do the optimizations of the logical plan, then there will be a physical plan, and then there will be a code generation part of it. So data frame optimization, that what we're talking about, happens in this 4 ways. And data set is nothing but your data frame itself, okay, and you're adding some more capabilities to it. And the second last one, and I think the last one, would be the serialization part of it. So when we talk about serialization, we don't have a very effective way in the RDD to do it, but Spark data frame can serialize it to off-heap memory also in a binary format. And this is where you will have the tungsten engine. Okay, so tungsten optimizer is a tool that we will be using. So this is the way how the tungsten engine will be utilized a lot. When we talk about dataset, when it comes to serializing it, the dataset in Spark has a concept called as an encoder. You will see that, which handles the conversion between the JVM objects to your tabular representation. So what we saw was the differences across 8 separate sections between all these 3 things. So a strong suggestion to all the others would be, please try this 8 things so that will be clear, friend. Also look at this catalyst optimizer and the tungsten. Let's talk about what does a catalyst do. So your data can be there in any format. When we talk about our Spark SQL, it can be done in 2 ways. Spark SQL can be done in 2 ways. Of course, in Java, that would not be possible because we have got a standard way of doing it. But in the other languages, you can write something called as SQL context.sql, and inside that, you can write your SQL query. So when we migrated from an earlier version to the high version of your Hadoop, the first thing that we did was the same code what we had in our normal SQL, we wrote it as SQL context.sql. Okay, so that people don't have a lot of changes or differences. You don't see a lot of differences. The code remains the same. Then they have got also something called as a data frame or a data set API. Okay, using this, you don't have to do everything using SQL. Okay, there is a much more better way of handling things, that is via the dataset API and the data frame API. So this is something that I'll be showing it to you tomorrow. So today we will just talk about the basic SQL query, how we are doing it. But remember, you can do Spark SQL in 2 ways: using data SQL context.sql and using the data frame and the dataset API. Let's go back. So depending upon what kind of query you are having, it could be a Hive query, it could be a SQL query, it could be a data frame. You pass it on to the Catalyst optimizer, where there will be an unresolved logical plan. Then you have a logical plan, and then you will have an optimized logical plan. Okay, so see here, there are 2 rules what we're talking about. One is analysis rule. So the whole thing is what is done by the Catalyst optimizer. So Spark SQL uses the Catalyst rules and the catalog object, that the schema catalog, that tracks the table in all data sources to resolve the unresolved attributes. Then when we talk about optimization, this is applying the standard rule-based optimizations to the logical plan. Then you are getting converted it into a physical plan. That's where it goes to the backend. So you will have multiple physical plans. And we also have got, if you're using your RDBMS, you would also use your cost-based optimization. So any one of you, can you please let me know, are you using any cost-based optimizations right now, friend? Anybody? Please let me know. Because in SQL, you will have this cost-based optimizations, friend. And Sharat, I just saw the hand. Was it for any question that you were asking? Because I didn't see that before. So is it wrongly raised or you had a
Yeah,
question? Over to you.
I had a question that was related to Spark. Internally uses Hive in the background, or how it?
No. It doesn't do that. So see, when they developed Spark, we already had Hive that was there. Hive was the SQL way of doing things in the Hadoop environment. So when they went on to Spark, they took the same concept of Hive that they were doing. Okay, and you can do that in Spark right now. So the query, what we have for the Hive query, you can either use a Hive query, or else you can say SQL context or SQL, or you can use your data frame APIs. All three ways are supported for doing it in Spark, my dear. That's the
Yeah.
answer, dear.
Okay, that was my question. Thank you.
Okay, you're welcome. So just let me know, friend, are you using any cost-based optimizers right now? Because in your normal RDBMS, you do have that capability, friend. Have you done that before, Sharat?
I used Cassandra to load into, so there is no cost base there. So
Okay,
RDBM definitely, yeah, cost base we need to use. Yes.
So
that's
Venkat,
correct.
I have used SQL Developer in the past for query analysis. We used to see the explain plan and the cost analysis, like
Right.
on each table, what it does, what's the cost of the lookup on the table and all.
Exactly, because what it does is you can have multiple separate operations with the latest Oracle, that is Oracle, I think 17 or 19, I don't remember exactly which version. You do have a way how you can optimize your cost, and you'll come to know, okay, if I run this query, this is the way how it will run, friend. So I was coming from that angle, how to use the cost-based optimizations, friend. So if you have done that, well and good, you can do that. See here, after physical plan. Now, you also have got a cost model in your Spark also. Okay, so let me just show that to you. I haven't given that document. Spark cost based optimizer. There we go. And this is what you have to look. So starting from 2.2, they have started with this cost-based optimizer and see how the various things can be done. I'll just copy the link and share that with you so that you can look at that. It came in 2017. Some people are using it, but then if you compare that with the Oracle way of doing it, Oracle is far more advanced because it came in 1970. The Oracle got started in 1970. It's almost 58 years. It's still running. Okay, so they have got a lot of optimizations happening, whereas this is a new beast that has come. So a lot of things needs to be done further on this. Okay, so but then they do have this way how to do your cost-based optimization. So do have a look at this because they've got a lot of fantastic ways how you can improve it, and they're actually competing with Oracle to see how they can do it in a better way than what Oracle does. Okay. So then after that, you will pick up the selected physical plan, and then in spite of the fact that we are talking about using a SQL context, at the heart of it, everything is an RDD. Okay, so in the code generation, what happens is it involves generating the Java bytecode that will be running on every individual machine. So this is what is the complete way of how things will happen. So you have got the Catalyst optimizer, you have got the Tungsten optimizer, and you have also got your cost-based optimizations that is happening in Spark. Okay, so all these three things would be there to help us out. Now, let me go back. So that was the theory part of it. Now, if you look at data frame from a Java perspective, it is nothing but a little bit advanced version of a result set frame. Okay, so some similarities and differences, I've got it over here. If you start looking from the RDBMS perspective, it is nothing but in the set of columns and row. And please remember, the idea of a row is very crucial. It will be a row object that we will create. So now let's pause over here. And if you have set up your Postgre database, well and good, friend. Because otherwise we would need that database when we execute the code. We don't need it in the first code. In the second code, we will be doing it. So let's see what we are trying to do over here. We are trying to load the object and try to use a Spark SQL and see how it would work. So I have got a class called as CSV to data frame app. Then I call my start method. In start, I start with my logger information so that the unnecessary information will not come. I create a Spark session which has got a builder pattern. I give the name of my application, the master. That means if I say local star, it will give me 2 cores. And then I will use my get or create object. So that means it will be created only once. So if you're running it for multiple times in your code, if it is already created, you will get a handle of the same object, or else it will be created for the first time. Then let's look at the file. There's a file called as books.csv, and I think I've already shared that with you. There we go. So this is what is the books.csv file. Okay, and it has got some multiple columns. So you have got the ID, the author ID, the title of the book, the release date, and what is the link that you can look at. So it has got about 5 columns. So let's go back and see what we're doing. So we will say spark.read.format. What is the type of the file? That will be a CSV. And then this is very, very important. If the file itself has got the column headers, what it will do is it'll pick up those column headers and create everything in a tabular view for you. And then I am calling a load. I'm looking, the books.csv would be there in my in folder. And then I call my show method. So what is important here is if I don't say anything in the show method, it will show me 20 rows by default. Okay. Or else you can specify whatever number of rows that you want to see, friend. So this was our first use case of how do we work with a simple data. Okay, and it is in the form of a CSV, and we will see that. In the next example, we will see how to install Postgre. If you have already done that, well and good. So we will see how to install it, and that is through Maven. So all the necessary dependencies are shown, and we will create a database, and you will see that in our Postgre stuff. So just wanted a small check from all the participants. How many of you have already installed Postgre in your systems, friend? For how many of you it's still pending? Good. Mati had raised the hand. That means it's installed, I presume. Igor has installed it.
I have a dialog box that I don't know how to answer, so I'm halfway there.
Okay, sure. So good. So yep, others have done it. So Brandon, I didn't see a hand raised. Ashima, any issues, friend? Did you try that, or that is still pending, dear? Kalyan, what about you? Sharath, you not tried until now? Okay, he said yes, so that's fine. So Sean,
I'm sorry. Are you asking about the data frame example?
No. I'm talking about the Postgre database.
Oh no, sorry, I got lost.
Okay. So that's okay. So no worries. Sean, what about you, friend? Have you installed it? Because I didn't see a hand raised.
I'm halfway there. I'm at a dialogue. I need your answers to your question.
Okay, no worries. So that should be okay. So that's good. So after seeing the first example, just try to ensure that we will finish it off, because that will be required when we actually run the stuff. So let's go ahead and see the example 17. A very simple example. I have got the file, and I will convert that into a data set, and then I will call the show method. So let's execute that and see how it works. Hey, tell me, Vishnu, go ahead. Sorry, you had.
I was just trying to lower my hand.
Okay. I'm sorry, because it came as hand raised, so that's why that was a confusion. No worries. You had a question, Marty? I saw the hand was raised, my dear. That's okay, no worries. Okay, so let me go ahead, because what happens is that I don't look at the detailed output of the individual thing. So when you lower or when you raise your hand, unfortunately, it shows me that the hand is raised. So that's why I get put off sometimes. That's okay.
No, Venkat, it is the previous one which I raised. Sorry,
Okay,
I forgot to do it.
okay, perfect, no worries. So now let's continue with the last example that we just saw. That was example 17. And I've already got that example there, because while testing it, I think I would have wanted to see that the first step, create a example 17. In the src, create a package, create an in folder wherein you will have books.csv, because that's what we are using over here. See here, I will load my books.csv from the in folder. Okay, and then in the package you will have my csv to data frame app.java. As usual, getting our logger instance, creating the Spark session for the first time, and then calling my data set and seeing how it can be loaded, friend. Okay, once everything is ready, you can just go ahead and run it. So just run it. I'll wait for you, friend, don't worry. So since it was ready for me, I'm just running it so that you can see the output, and then I will allow you to do it on your own at your own pace so that it will be clear for you. Come on, it's running. It's taking a little bit of the time. That's okay. There we go. Okay, and you can see how if I say show, it'll show me the 20 records. If I put something into the bracket here, it'll show me that much number of records, friends. So I'll just say 5 and I will run it again. You should see the whole thing coming in a tabular fashion for your friends. Okay, so I will pause over here. I've been talking a lot since lunch, friend. So take up a short 2 to 3 minutes break. In the meantime, you please go ahead and run this and see whether you're getting the proper output like what we are seeing it on the screen. See here? And getting the first 5 rows. I'll just put myself on mute. Please try it out, friends. And then you should have your Postgre database also set up. So please continue with that. If you have any questions, we will have a look at it here. So I'll just mute myself for a couple of minutes. Thank you. You see that in this link, it is giving a dot, dot, dot. There is an option called as truncate is equal to false. That's what I've done it in Scala. Let me see whether that works over here. No, it's once again. No, it's not happening. So I just need to look at the show options. So if you say truncate is equal to false, you will be able to see the whole thing. So look at this. Let me just go back and look at the methods over there. I think I found that. We don't have to say truncate word. Truncate, it will by default take it. I'll just say false. Let's see what the output is. Yeah, there we go. That's what I wanted. See how it will go ahead and give you the full thing. So you can say truncate is equal to false to see the whole output. Take your time. Do this, friends.
Okay.
Hey,
Hello?
tell me.
Yeah, so I need to reset my system to make that SQL available, make posters available. Let me do that quickly.
Yeah, sure, no
I
worries.
installed it, I didn't restart. I forgot to restart. I said afterwards, and I forgot to restart.
Yeah, that's okay. So you can quickly start and you can come back. So I'll just wait till the time others. You finish this current example, dear? Mati, you finished the current example? No, I think she's already restarted. That's okay. So anybody, did you finish with the current example? Any issues in running this, friends?
I'm done. This is Vishnu. The only thing is I removed that restriction of 5. I just gave it as false. It still shows only showing top 20 rows. I'm trying to see how
That's correct. That's correct. So by default, it will show 20 rows. That is the pagination aspect of it. If you want something more than that, you will have to specify the number, my dear. By default, it will always show only 20 rows, friends.
Okay, is there anything like all? If I just want to see everything?
No. There's nothing, friend. So that's something that even I had a pain point when we were running it in other languages. So there's nothing called as all, because typically what they say is that I don't want everything to be shown, right? So 20 was the default figure that they picked it up.
Okay.
Sure. Yeah, tell me, Ashima.
I have to restart my machine too. Sorry. So
No need. Because when she told me that our other colleague that she had to restart, I was a little bit surprised because I was not knowing, because he didn't ask me for a restart when I did my PostgreSQL.
For me, the last step after click finish, it says for the changes to take effect, I have to restart. That's the pop-up.
Okay. Fine. So maybe what you can do is that you can do it in the break, my dear. So we will have a quick break about in the next 15 minutes or so. At that time, we can restart it. We don't really need it right now. So I can give you a break by 3 o'clock once you finish up with this thing, friend. So till that time, we can continue as it is, dear. Sure.
Okay.
Yeah.
We can have a question.
Yeah, please go ahead.
So you said by default it will show only 20 records. Is there a way I can control it? Like if I want to see the next 20 records, how would I look them up?
No. You won't be able to do that. What it does is, because you will have, the reason why they kept the limit as 20 is because you will have a huge set of records what you're having. So in case if you want to show that, there's a show method, like you've got a collect method in your RDD, right? So we have got a show method. You have to pass some number into it if you want to overwrite that 20. The default is 20. You'll have to pass some number to it, and it will show you all those records for you. And then the second parameter is whether I want to truncate it. If it's a very big file, a very big column, you will see as ... coming at the end. If I say false, you'll be able to see that. So that's the way how you control it here.
Okay. All right.
Sure.
Thanks.
Sure. We also have Sean. Were you having a question, Sean?
Yeah, on the post-degree installation,
Right.
I'm in a dialogue that is asking on what drivers and what database server to choose.
Okay, let me do one thing. Let me just say stop, and please start sharing your screen so that we can actually see that. Thank you. I think the default is all okay. Yeah, that's it. Just say next.
No, I picked those.
Oh, Sean, this is the stack builder. I think it pops up when you hit the finish button of the Postgre, right?
Right.
That's
So,
correct.
so if you can just cancel it, I mean, we can use it later too if you want it because it has been already installed. If you check.
Okay.
In fact, even if you go ahead with it, you can just use the default SQL. That's all. Yeah, that's it. Yeah, that's it. So you just download it and install it. You can as well as cancel it. That's also right. But then it will just go ahead with the default steps. That's all. You're almost done. Another 5 minutes, it will be done.
I think wasn't the stack builder is for the additional tools if you want to use for Postgre because Postgre, I think it has been already installed in the system.
That's correct, yeah. Because what it does is that it'll look out for this component. And what I did was I just install the default component so that it doesn't hamper the working of Postgre. That's all. So yes, you're right in saying that I don't need the stack builder, but then just have it as the default, select the default Postgre and continue with it so that we don't run into
So,
issues later on.
so
That's
it
all.
does not prompt for the default one. That's what I think he was mentioning, and I had the same issue too. So I just canceled it because I don't know what is the default. You have to manually pick basically.
Come back
There's
again.
no, so there's no default picked up items in a stack builder for you. We ourselves have to pick them.
True. So in case if you are selecting, you can cancel it. That's one option. Really don't know what the possibilities of that would be. But then even if you're selecting it, select only the default Postgre options and all those things like what Sean did, and then continue on with it. So that's what I had done when I did, because we tried this with MySQL and we tried with Postgre also.
Okay.
So with both of them, it works fine. So that's what I did. But there should not be an issue. We'll just check when we actually run the example to see what is happening. No worries on
Okay.
it.
All right.
Ashwin.
All right. Thanks.
So I think yours is already done, Ashima. So that's good. So Sean is also ready. I hope others have also done this, friend. So let me just click on share. Yeah, there we go. So once that is done, I think we can go ahead with our next one just to see how do we continue with it, or else can others please update me? Have you finished installing or you're still doing it, friends? Anybody still doing it? Okay.
Sorry, how to verify it's installed?
You will see that in the options. So what you can do is you can go down to the PostgreSQL 10 and start with something called as PG admin. So when you click on this, it will open up the default admin in a browser. Will take a little bit of a time for it to open, and it will come up with a window like this. Sean, you had raised your hand. What was that about, Sean?
It's still loading for me. That's all.
Oh, okay, that's great. Thank you. Again, sorry, friend, because I just see the pop-up when even when you unraise your hand, it pops up. Brandon, you
No,
had a question?
I just want to let you. I know that's on purpose. I was just
Oh, that's okay. That's okay. No worries.
No, just answering to your question of the Postgre installation, so I'm done.
Done. That's great, friend. Thank you.
We can have an issue with the PG admin. It's not opening up for me. It just says stopped.
Wow. Just one second. Let me stop sharing. Yeah, can you
Yeah,
just
let me
share your
share.
screen? Sure.
All right. So I went here and then Postgres.
No, that
Oh,
is the default one. No? Not this.
actually, PG admin is the one.
Yeah, that's the one. Yeah.
And then it says like that, it stops working. So do I need to actually create this one to make it work?
Yeah, I think that's the default one it's expecting. Select it.
So this
One
one?
second, hold on. Not that, not that. The second one. Yeah, that's the first. Yeah,
PG.
that one. Yeah, click on it.
Okay.
Yeah.
And then
And the JDBC one, the second one.
okay.
Database servers.
This one, right? That this has been installed.
That's already installed, so no worries on it. I don't need nothing. DB tools, I don't need it. Replication, I don't need it. And I think that's it. You can just say
That's it?
next. Yeah, yeah.
Okay.
No. Oh, sorry, Ashima. Can you go back? I want to see what are the options you have chosen.
Oh, so we chose PG agent, and then we chose PG JDBC driver, and then I installed this one 10.10.2. So
Oh, yeah. It's
so
already
whatever
That's
you
all.
installed, so that's it.
Okay, got it.
And then
Yes.
we're just doing next. Okay.
Yeah. Yes. So it's downloading these things.
All right, I'll stop sharing then.
Yeah,
Thank
yeah,
you.
sure. You're welcome. I just wanted to confirm that with you, Sean. When you go down, let me click on my share. When you go down to the PG admin PostgreSQL, is it opening up a window for you? It might take some time though. Others, if you can click on this PG.
It's installing the Visual C++ redistributable right now.
Oh, wow. Okay. So that's what the challenge would be because multiple things it would expect.
Yeah.
I normally do this with MySQL, but then I was told that try with. Are you using Postgre and the other databases, friend, or what kind of data? Or you're using NoSQL? One of you confirmed that you're using Cassandra. I was told that Mongo is also being used by the team a lot. Is that correct?
Yeah, that's correct.
Okay. So for people, once you have installed it, please go back and start pgadmin. It'll start with a browser-based instance, okay? And it will show something like this. Of course, I've created a database. That's the reason I'm seeing this course data, okay? So once you see this, I think that would be it. So what we can do is, once the installation is complete and we can continue with it. So we can take up a quick break right now, friends. And it's almost 3 o'clock your time. So take a quick break and start by about 3:15 so that we can go ahead and do the, yeah, that's right. 3:15 should be ideal. So that once the database is done, we can go ahead and start with our queries to see how we can insert a record and then try it out. Okay, tell me, Vishwanath, you had a question?
So the PG admin started fine for me on the web browser and also I suppose I don't have to restart.
No, that's what. Even I didn't restart, to be very frank. So no need to restart, friend. So, but some of them got an error saying that they have to restart. So I didn't get an error. That's what I remember, friend. So once you see this, you're all set, Vishwanath. Nothing to be done now.
Okay.
Great. Yep.
VK, I'm going in the loop to install and then the error comes up. So
Hold on. Let me stop sharing. Just show me the screen once again, dear. So at least I'll know what's happening.
yeah. So again, I'm here. So I don't know, make sure the PG admin server is shut down.
Okay, hold on.
How?
It's actually not installed.
I don't know. It says it's, so this has been done already twice, the setup.
Okay, so it's uninstalling. Once again, it's installed. No, it's unpacking. It's actually installing. Let's wait. Let the screen go on a couple of seconds.
Okay.
That's weird. Because it does say it's installing. And you're saying that
Yeah,
this,
yeah, it installs and then again hits the
ah,
same issue when I open the PG admin from a start menu.
okay, okay. So I think then it might require a restart because I don't know why somebody would require a restart, but then it didn't ask for me. That's what I remember. So let's see.
Okay.
Let it finish and let's see that use case coming again.
Sure, sure. I mean, I can update you if you might also want to take break. So I'll update you
Yeah.
once it is done.
Yeah, once it's finished, what you can do is that just restart your system so that things are all proper. And then when you start your PG admin, it should come up with the browser-based view. That's where
Sure.
we should reach, right? Sure, thank
Okay.
you.
Thank you.
Yep, so let me stop sharing. That's perfect. Let me start sharing my screen. There we go. So this is how it should come up in your window, folks. So let's take up a quick break and we will come back again by 3:15 your time frames. Okay. Thank you so
Okay.
much. Just
Thank you.
muting myself. Hey, hello, folks. Saw your message, friend. Hey, that's great. Sean is also saying he's got his PG admin now. And Mati also mentioned that she's got her Postgres working. What about you, our friend Ashima? Any update?
Yeah, it is working now. Are we expecting that to open on browser, right?
That's correct.
Yeah, it
What,
works.
what did you do? You said that it was continuously coming. So what was the solution that you tried?
Just reboot the system. That's the
That's what.
best Windows.
That's what I also thought, to be very frank, but then very surprised you had to do that. So anyway, no worries. So that's all. So Akhil, is it done for you too, Akhil? Just give me an update. Maybe they're not there. Brandon, Igor. Igor said he's already got it up earlier. Kalyan, have you done it? Maybe they're just back. Sharath, what about you?
I got it work.
You got it working. Okay, that's great. Anything different that you have to do it in on a Mac machine, Sharath, other than the steps what we did?
No, it's just a download and
Install. That's all right.
that's it. Yeah.
Okay, okay, great, great, thank you. And even Vishwanath got it, and Venkatanathesan also got it. Okay, so now let's move on and see our first example to see how that would work. That's great. So let me close the things. And I hope that you have remembered what is the password that you have given. I have given the standard password of Hadoop 123. That is the password to my VM images so that I won't forget it ever. So that's good. So please remember, when we are in the project connecting to it, you will have to have a properties file wherein we have to specify the driver. You have to specify the default user, that is Postgres, and the password. We will have to put it over there. Okay, so that is what is necessary in our code. And we will be doing this with a Maven project so that all the dependencies will also get downloaded. So let's go ahead to our example 18 now. So let's mention example 18, wherein we will try creating a simple table and loading records into that. Records into that. So let's go ahead and give it a shot. Let me close some other windows. Okay, so what we're going to do over here is do the standard step of a comma separated value to a relational database app. And as what we did earlier, in the start method, we are having our business logic. So first create our logger object using the Spark session, give it an app name. The master, I've said local, you can say local asterisk also, get or create. Then the data set, I am reading that particular data, formatting it as a CSV, giving the headers to be there, and I have got a file called as authors, what we have. So let's go back and look at the authors example. So let me open that particular file, select this and say edit with Notepad++. So this is having the last name and the first name of 6 of the people. And we have got Mehdi Zaharia over here. So he is the person who has created Apache Spark Friend. Okay, Holden is also there. She is also a very popular user, and the other users I'm not that popular with. I haven't heard about them, to be very frank, but then that's okay. They look to be French gentlemen. So we have got this particular file, and we want to load this particular file in our with our example. Then we will say that with column, that is going to be the name column. We will concatenate our L name, that is our last name. Then we will have our literal in the form of comma and specify our first name. Then we are specifying our connection URL, that is the local host and the name of the database. But please remember, you have to first create the database. Okay, so please go down to your PG admin and start with your SQL, wherein you can, click on your window wherein you will be able to execute your query. You have to create a database. So that's what I had shown earlier. Create database called as course_data. So let's do that. First, we will have to create our database in Postgre. Okay, for that we will say create database, and the name of the database what I want is course_data. Just one second. Let's go back over here, and this one, course_data. Okay, and once you type that particular query, you can select that particular query and click on this button, that is execute, so that it will execute the query. And then you can go down, do a refresh on your PostgreSQL 10, and you will see that this database is there for you. I've already created it, so that's the reason I'm not doing it. You will have to do this. So let's go ahead and create the database, and please confirm to me that the database is created, friend. Let's go ahead and run this and try this out. I'll wait for about 2 minutes. Yeah, tell me, Mati, you had a question?
No. The database is created.
Fantastic. That's good. So that's nice. And even Ashima says it's done. That's good. Yeah. Vishwanath also done. That's great, friends. So I'm sure others will also have that done. So no worries on it. So that's fantastic. And then let's move on with our next part in the code. Let's go back. So the database is created, and this is what is going to be the properties file, what I had shown earlier. So you will have to replace it with whatever password you have given. And then I will go ahead and say df.write. So using our data frame object, we have got a write function wherein I will specify the mode. So I'm going to override the contents what I'm having it. So the save mode dot override, and I will say .jdbc wherein I will give the connection URL. This is what is going to be the table name that I'll be using, and I'll have to pass my properties file. Once you do this, it will just give you a sys out that the process is complete. Okay, so that's what the code is all about. And then we'll have a look at the standard pom.xml. So this is how the default pom.xml will look like. We will create a Maven project. I've shown you how you can start with your PG admin, create database, course_data you'll have to do. And then once the table is created, execute the Java code. You can say select star from project to click on execute, and it should show the answer for you over here. So this is what is the output of the code that we have done. So please go ahead and ensure that the complete thing is done, friend. So I have already done it. So I will directly go back and show this for you over here. So go down to the default database. And in that, you should see in schemas, you should see tables. And I will say that was example number 18. There you see, this is a Maven project. And this was 18, this was 19. Just give me 1 second. The name of our example this was 18. Okay. So if it was 18, yeah, authors.csv, I need that file. I got put off by this. Authors.csv should be there. The pom.xml is there. And let me show that the data is already there. So I will simply say select start from project 1 and I will execute it, and you will see that. Let me just confirm that what we are doing, sorry, project 2, not project 1. So it will show you the files and you will be able to see it. Let me open up my authors. Yep, it should be project 2. So select start from project 2. Let me run this and see here, it should show me all the answers. I'll just wait for a confirmation from the others. For me, it's already done, and that's how you see the data output over here. So go ahead, create a Maven project, and please do it, friends. Yeah, please.
Yeah, so this table should not be available. Our program will be creating this table, right?
That's correct, my dear. So this table will not be there. We are inserting the records and we are creating the table. See here, we are giving the name of the table over here, friend. Right? So the table will be created through the code only, friend.
Okay, thank you.
Yep. And after you do that, this is how it should come up for you. I'll just wait. It will take you about 10 minutes to finish this. So quickly, let's do it, friends. Thank you. Folks, just checking with the other colleagues. Brandon, is the database already done? And have you tried the first example, friend? What about you, Igor?
Not yet for me. I'm working on it.
Okay,
Yes,
okay, that's cool. If you need help, just let me know, please.
Yep, for me it works.
Okay, that's great, Igor. So you can try with the example of from the Java code how we create a table, and we will see that. So the example that we're showing right now, please try that out, Igor.
Yep, I already ran it. Yes, so table was created. Yes.
Hey, fantastic. So now we are inserting our record. So we will be trying our example number 18. So we are executing our example number 18 to see that the records are there. If you see my screen, that for me, it's already executed. So that's the reason how you see it over here. So please do it, mate. Thank you. Kalyan, what about you, friend? So for Brandon, the table was still not done. He's doing it. Any update, Kalyan? What about you, Sean? Both those colleagues are not there. And Vishwanath, I think for you it was done, right? So you're trying with the second example now, Vishwanath?
Yeah, I'm trying to run example 18.
That's great, friend. Thank you so much. And our last colleague, Venkateshan Nathan.
Problems.
Sorry, Sean, go ahead.
So, so I created the POM XML.
Okay.
And I built the project. Now, do
Okay.
I paste this? Do I still have to paste the code into the main?
That's correct. And after that, once you run the project, you will automatically see the table being created. And then you can simply query it and you can see this output. That's what you have to do. You're at the fag end of finishing it, Sean.
Okay.
Great. Please. Thank you. And what about our colleague Venkateshan Nathan? Already done, friend, or having some issues?
No, I'm working on that. Yeah.
Yeah, that's okay, dear. Thank you so much. So, Brandon, you're having some issues. So do you need my help or you're okay with where you are right now, Brandon?
For now, I'm okay. I'll let you know because I'm using Mac, so I'm just using the command line for Postgre. I don't have the PG admin or anything like that. So
okay. That's okay. So just try to fix it up today because tomorrow we would really need that for our other examples also. So try to fix it up by today. Thank you so much.
Will do. Thanks.
Yep, great. So just muting myself, friends. Thank you.
Inket.
Yeah. Tell me,
Yeah.
Mati.
Sorry. Meanwhile, I just want to. I got executed and I created that. It got created my project too in
Fantastic.
Postgres. But I have some questions, right? Like here in the CVS to relational database app.java, we
Okay.
are trying to read it from. Means Spark is trying to read it from the database, and
No,
with
no, no, no,
column.
no, 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 no. Spark is reading from a file and we are inserting it
Sorry.
into a database.
Yes. Sorry, my bad. Like Spark is trying to read it from CVS and then trying to insert into Postgres database.
That's
So
correct.
this can be achieved through a normal Java project itself. What is the significant difference between using Spark and a
Okay, okay.
normal?
No, you're perfectly right in that. What would happen is if your data is there in memory. So take an example, this was a simple flat file and that's why it was hardly about 10 records. What will you do in case if the data is huge enough and you're getting the frequency of the data is very high? So the justification what we have is that one, using Spark, I can do the in-memory processing of stuff. So along with the in-memory processing of stuff, they have also got the SQL wherein you will load the data. So today we will only do the loading of the data. Tomorrow we will start doing some further processing on it, friend. So we will see how
Okay.
what are the other things that we are going to do and all of that. So this was primarily just the loading data right now, friend. Nothing else.
Okay, so if my understanding is right, please correct me if I'm wrong. Like this Spark, while reading it, also does the map reduce, split, and no,
No, no, no,
nothing
no,
like that.
no, nothing like that. See, MapReduce was the old framework. So the same way what we're doing it in Spark, I can do it through MapReduce also. So the reason why we have got Spark is because everything happens in memory. Okay, so Spark is basically a processing engine. The data can be anywhere. I will load it to the Spark, process it, and the data can be stored anywhere. So that is what
Okay.
is Spark. So earlier we had MapReduce almost for 10 years, from 2006 to 2014. MapReduce was the primary way with Hive doing everything. Then in 2009, it got started, it got open source in 2014, where Spark does everything in memory and does it in a very fast way as compared to MapReduce. So that is the benefit of Spark over here, friend.
Okay, so in this case, it is saying Spark.read. So it first reads a CSV and store it in a memory, and then load it
Store it
into
into
the.
the database. That's correct. So see here, I did something called as, after I read it, it was stored into a variable that was called as df, right? We created our data set, it was stored into that. And then I said df.write. That means whatever was there in the memory, what I read from the file, I am going to write it into JDBC in that particular project called as 2, which was created when I ran this code. So that's the whole idea, friend.
So here we are running it locally. If we are having a Spark configured on what's that, daemons and everything right on server, if we are running the same code, so whether this job will be split across all the cores or how it is?
No. See, if it was a distributed environment, what would have happened is the authors.csv, if it was a very big file, it would have been there running parallelly on multiple machines. Okay, so once that is happening, when I do Spark to run this, all that Spark will do is that the data that is there on multiple machines, the object is called as df. It will use this object, and when I do this right, whatever might be the size of data on all the 4 machines, that will get stored into the database. That's what would
Okay,
happen, my dear.
so one file, CVS, right? One file which has 4 records consider. So all 4 cores will be, sorry, all cores, 4 cores will be reading that 4 records and try to insert. And since we say that as overwrite, it will not insert 4 into 4, 16 records. It will insert only 4 records. That's a
That's correct. That is right, but then the override doesn't mean that. What it means is that if the data is not there, I simply want to write the contents once again. So there are various options what we have in the save mode. This will simply tell you what are the various options for writing it. So either you can say append, or you can remove the contents. If I run this again the same number of records will be there. Save mode has an option called as append also. That means if you're running it for the second time, you'll simply append to the data what is already there in the SQL database. So that's what it will be doing, my dear. Make
Oh,
sense?
Yeah, I have one more question. Sorry, I'm little
No,
not
please go
very.
ahead. Please go ahead. Don't hesitate.
Okay, so if the 4 cores are doing the same job, writing 4 records into the database, what is a big advantage? If it is splitting and writing into the database, it would be advantage, right? Like four cores will be doing the same operations.
No, once again, look over here. Let me just go back. The data that we have, let's assume it is going to be 4 records. And since I loaded in Spark and we have used all the cores, so we have got 4 cores. So what will happen is, in my example, it's only 4 records with 4 cores. What would really happen is, what will happen if you have got 20,000 records on every core? So totally 80,000 records is what will happen. In our case, it was a simple small file just to show how things are, because we can't run a very huge file because it will take time and all of those things. That is where Spark really helps in the concept of parallelism and all that. We are working with small data right now, but then the biggest advantage if you try to compare Spark with your existing technologies is that in existing technology, all the 80,000 records would have been there in one place. It is not going to be distributed. Spark ensures that the data is there in 4 separate cores and it is there in the memory, and all the 4 is being written into your database, so that the database will have totally 80,000 records. So the time taken for writing will be 1/4 of the time it takes for a normal relational database, right?
Okay, so the CVS data will be split across all the cores. That's what you're trying to say, right?
Exactly.
Okay.
That's what
But
it is.
as you were explaining earlier, I thought the copy of all the records in CVS will be there in all the cores. No,
No, it won't be there in all the cores. No, it won't be there. When you said 4 records, it will be one record will be there in all the cores.
So those splitting algorithms, like Spark has some strategy to split it, or it's just a split.
No. Last time we saw that yesterday, right? We had 3 records in our data, and we saw that it is getting stored in 2 cores, right?
Yes.
So
Like
by
that.
default, it is a number of records divided by the number of cores. That's all, my dear.
Okay, got it. Okay, thank you.
Perfect. Sure. Sharad, you had a question, dear?
Yeah, with this one, is it possible to put this sequence number to it, added to it? No, right? Only to the
once again, you're saying that you wanted to add a sequence number in that, but then we should have that sequence number in the data file itself, friend. So if you have the sequence number in the data file, that will of course go ahead and it will create it for you.
Okay, so we cannot generate it through.
No, it can't be generated because we're writing the contents of that file, because what is there in the memory of dataset is the contents of that file, right? So, and it is immutable. So I can't change that to add something more in between, like a sequence number and the other thing, or add a column or something. So if I'm doing that, it should return me another RDD, and that RDD is what we can save it. So in case if you want to add some sequence number to it, maybe whatever is the logic, you can do that. But then it will return into another RDD, and that, return another data set, and that data set is what we need to save, Sharan.
Okay, so here another question. So there is no data types defined here. DF dot with column name, concat.
That's correct.
Name,
because if you look at authors.csv, we already had that, right?
No,
because
column
if you look at authors.csv, we already had the first name and the last name. The column name was already there.
Yeah, but the data types we did not mention, right?
Very important. When you are doing with Cassandra, there is no concept of data types, right? So when we talk about HBase and NoSQL and all of those things, the concept of data type goes away completely. Everything is going to be in the form of a byte array. Only in our relational database, we have this data types concept. Okay, but then if you look at the standard ones, especially the NoSQL way, how it is happening, there is no data types at all, my dear friend. And the way how the world is going right now into this NoSQL and other things, the concern of data types is it depends upon the application to take care of it and manage it on its own in the form of a simple byte array, rather than we having to specify something explicitly, Sharat. That's what we're going towards.
But I mean, in Cassandra, we have tables with data types, the columns.
True. In Cassandra, it will be there, but if you look at HBase, you wouldn't have that at all, because everything is in the form of a byte array, my dear.
But in Postgres, we have it, right? So we are not mentioning any data types here.
That's
Is
correct.
it okay?
No, because everything is taken, if I don't say anything, it is taken as a string data type, my dear. Everything is taken as a string.
So if the third column is there with the integer, do we have to mention that?
1 second, let me just come up. Right.
Like, let's say if there is a third column,
Right.
you have an integer, age or something, right? Age.
That will be a number then. It'll automatically pick up and convert that as a number.
Oh, it does convert automatically. Okay.
That's right. That's right, friend. Sure. Always. We have one more colleague. Yeah, Vishwanath, you had a question?
This query editor is not loading for me. The program ran fine. I can see the table and all, the schema. Can I share my screen?
Yeah, sure. Let me stop sharing. Yeah, stop sharing a screen, friend. Thank you. Okay. Yeah, the post data is there. The tables are, okay, do one thing. Go down to SQL on the right hand side. On the right hand side, top dashboard SQL. Yeah. That's funny. Because show you a window. Let me go down to my screen.
Yeah, see, one thing I figured out, if I click here, there's an option for query tool.
Okay.
But the moment I do that, this spinner, it goes on forever. It's never loading that editor window that I can run my queries and all.
Okay. Vishwanath, I think it is a question with the restart, my dear. I'm really surprised as why it is forcing. Now I'm having a doubt whether I started my system myself when I did that. It's a question with the restart, Vishwanath. Because remember you said that you haven't done it, and for the others, they are not having this issue at all, dear. They've actually loaded everything.
Okay.
That would be the issue. So just try it once, huh?
Okay, yeah, I'll restart. But for today's session, do you think that will be required? If not, probably at the end of the session, I can restart.
No, only do it at the end of the session. You don't require it right now because you know that the record has gone and you can actually see the columns over there. So that is perfect. You just have got one more example to run right now. So that is perfect. You don't have to do it right now, Vishwanath. That's perfectly okay.
Cool.
Sure. Okay, maybe not there. So that's fine. So
I had that problem with the JDK again. I'm trying to fix. Almost there.
Okay, sure. So no worries. So that was the example to show how we can insert some values into it. So just as a quick rerun to understand how the actual thing is done, we will go down to the last example for today to see how that is done, friend. So let's go ahead. The standard form.xml, all those things are done. And the database is created. You can see all this. Now, we are just seeing one more example to reinforce whatever we have learned, friend. So we are again doing a read dot format, and the contents of this thing is from name underscore comments dot text. So see over here, this is what is the data file that we have to load right now. Okay, so see over here, we have got our last name, our first name, and our comment. So this is what is the data that we are going to load in our last example. The thing that we're going to do here is we are trying to do a transformation. I am trying to do a concatenation of two things. So the last name and the first name, I'm concatenating it. I'm trying to do some further operations. So I'm going to put it into a column called as full name. which is a combination of the last name and the first name. Of course, we are doing a filtering on it also, and then we are ordering it in a descending fashion. Okay, so that's what we are doing it over here. And then please note our data sets are immutable, and after doing all these transformations, we are putting it into a variable called as data frame. So I'm doing a show so that at least you can see the answer on your screen, as well as we are going to put it into our database also, into a new table called as project one. So this is the last example that we will have to try for right now. Tell me, Mati, you had a question?
Yeah, so as of now, we are writing from a flat file or from CSV to database. So
Right.
in DS, we can do a reverse as well, like reading from the database into a flat file as well.
Possible. So what you can do is that, like the way how we are doing a writing, you can definitely read from a database, put it into a file. So that is definitely possible also. So that means if I have got some contents already there in my database, I can read from that and I can do that. In a real world, if you are trying to do this, you'll actually use a component called as scoop for this. There is a component called as Apache Scoop, which is for reading and writing from a data store. That is the Hadoop way of doing it. If you are doing something on the Spark, you will have to do it with the data frame only. So that's
Data
option
frame
you will
or
have to
data
try.
set?
Sorry, data set. Apologies.
Oh, no
It will be a data set, because pardon me when I say data frame, because we are traditionally used to the data frame way when we talk about Python, right? Python doesn't even have a data set, so that's why the term is not that frequently I use that frame. So that's the reason. So for us in Java, everything is a data set, and we'll be using this object only.
And there is no Java object called data frame as well. Only data set is available.
Yes, we don't even have a data frame. So in Java, when we look at data set, internally that is actually a data frame. Okay. Plus, it has added some additional capabilities, because if you want to do the object-oriented way of doing things, then it has to be a data set, and that's what both Scala and Java does it. For Python and R, we have got something called as a data frame, which is
So
again.
already, okay. Okay, sorry. Yeah, go ahead, please. I
No,
will
that's
ask.
right. So in the other languages, you have got something called as a data frame, and using that, we can do it in two ways. One, I'm showing it to you in this particular way. Other way, you can actually write a SQL query also. So you can say SQL context.sql and put it into double quotes and then write it.
So
So let
database
me.
to database is also possible. One database to another database is also
One
possible.
second. Why do I need Spark for doing that? Database to
Okay.
database, right? So I can actually do it using any other tool. But in case if you want, it is possible. I can read from one database. I can do some transformation of my data in my Spark, and then the transformed data, I can push it into a database. That is definitely possible.
Okay, so those are the additional features for this part. But what are the specialized tools for doing it, like Scoop? Scoop, you
No,
said.
that is in HDFS. So that is in Hadoop, not HDFS. That is in Hadoop. So if you look at
Okay.
Hadoop, Hadoop has got some components called as Apache Scoop, which is import export of data. It has also got a component called as Hive, wherein you will write the SQL queries. Okay. But since we're using Java, that's the reason why we are going ahead with this Spark.read, and we are not writing a SQL query. Over tomorrow, I'll be just showing you how to write a SQL query also. We'll put everything into double quotes, and we can simply say select star from table name and call show, and you'll be able to see the complete result also. But that is also definitely possible here.
So you said like for database to database, Spark is not a recommended.
Ideally, that is not the right tool, because you will have an import export in the database already, right? So you can import and then export it as a CSV file, and then you can easily move across. Whenever you want to do
No,
some
directly from one database to no, sorry. This might be the relate just to try to understand what are the use cases can be used to using Spark. So I am very new, so I'm just trying to understand.
No, that's perfectly right here, because if you're talking about a database, you need an intermediate file, right? You can import it from a database, and you can, export it from database into a CSV file, and that CSV file you can ingest into another database. I really don't need Spark by default over there. Spark
Okay,
is
got it.
really used when the data is huge that it really becomes, and there are multiple sources. You're getting the data from a flat file, you're getting the data from a database, you want to transform that data. That is what is the beauty of Spark, my dear.
Okay, got it. Got it. Thank you.
Yeah, sure. You're welcome. Sharat, you had a question?
Yeah, the going back to the same question. Let's say I have a table in Postgres
Right.
SQL. It has got last name, first name, and age. Age is double variable, and then the flat file that I'm going to load has 3 columns. Same thing: first name, last name, and the age is in string quotes or something.
Okay.
So you want to, I mean, so that age needs to become double, right? So we have to do all that thing in a
Spark.
split, all that
That's
thing.
correct. Yeah, so what you'll do is you'll read the data in the form of double from there, and because you have kept it in the form of a string, okay, you will have to convert it to a string, and then you can go ahead and do it. But please note, when we are moving data via Spark into a file, okay, it by default it will not be a string at all. It will be by default taken as a double only. But I'm understanding your example and saying that, yes, what would happen if that was a string? Then you have to do some transformation in your Spark for converting it from one type to another type here. Make sense?
Okay. All right. Yeah.
Yeah. Perfect. Okay, so let's run this last example also. So I think I've already done that. Let me just go back to my Eclipse. But this was your example number 19. Let me just go back. I'd already tested it before, but then the 19th example is not there. So let me create it for all of us right now. So I will just create a Java project, and let's call it as example 19. I'll just say finish, and let me create a package. We'll call this as com.blanket. Let me, the name of the file is going to be application. Control C, go back to Eclipse, right click, new class, application. I just say finish. Then I will have to load all the default variables. So I'm having all the variables over here. That's it. Control C. I will paste it. That's perfect. And then I would need the public static void main. We can select the complete code. I'm writing it. That's it. Control C. Let me go back over here and paste it. That's good. Save the file. Let me add the Spark jars. So I will say add external jars. I just apply and okay. Just once again, need to have a little bit of a water. Just once again. Hit back again. So yeah, the code got compiled. That's perfect. And let me see what is the save mode. Overwrite. So that's okay. So whatever is the contents, that should be fine. In case if I want to create a new database, let's say I want a database called as 3, and the the database is course data. The table is called as 3. That's perfect. Let me save this and let me run this way. Oops, I didn't write that code, so that's why I'm seeing all this info. That's okay. I forgot to write my line. That was, in fact, I missed it over here also. So I'll take it from the earlier one. I wanted to show only the default logger. I missed it. So Control C. I'll put it in the file so that next time it will be easy for me. Control V. And I will put it in the code also, just to be very clear. There we go. Control V. Okay, I need to add the jar files. So log4j is already added. Let me add my level also. There we go. And I will close that. That is perfect. Now over here, okay, it was giving me an error. It says path. Okay, okay. So I forgot to create the in folder. Let me do that first. A folder called as in. And if I look over here, this is where my code failed, my dear. I'll just show that to you. See, in name underscore comments. So let me copy my name underscore comments. And I can simply drag and drop this in my in. So the file is there. That's perfect. And let me run this now. Go back and run this code. Let's wait. See what is happening. It should load all the values and then we should be done. Just 1 second. And for the others, I presume it would be done. So, no, yeah.
EF2 is commented out. Oh,
Come back
this one you should be in a POM project, right?
Okay. I missed that.
You
Yeah,
can copy the
otherwise I
POM.
won't get the jars. That's correct, because I won't get the jars. That's the reason. So, okay. Sharat and Sean. Sharat first. What was the doubt, Sharat? You raised your hand. That's okay. Sean, what was it?
I'm still on trying to create the database.
Okay. So what you'll have to do is go back to PG admin, and once you click on this, it'll open up a query editor. Sorry, this one. You have opened the query tool, Sean?
Yeah, I'm saying, what I'm trying to say is I'm getting an error, unable to connect to database.
Hey, that's a Java project. That should have been, that's what she just helped me right now, because Mati had mentioned I should have created a Scala, Maven project, because in Maven we have got all the dependencies, right? So you have got it as a Java project. So
You
create
can
one more.
convert this to Maven project by right-clicking configure Maven project and add that pom.xml. That would be better.
Hey, can you just show that to me? I'm sorry, I'm totally new in that. So what should we do? Where should we right click? Where should we click to convert?
Okay, so this is a project. Which project? Artifact 1 is a project name? No.
That's correct. That's a project name.
Okay, got it. You can save this file and right click on already it's a Maven project. Artifact 1.
I started off as Artifact 1 is Maven. Yeah, it's a Maven project.
You created it as Maven project already.
But I
you added the pom.xml, and pom.xml has everything in it.
Can you just show me the pom.xml? Why is it saying connection attempt failed? Okay. No, you have got everything over here. That's okay. I'll go back to a CSV to relational database app. That's okay.
Try adding the port number.
Okay. He's mentioning about the port number. So just 1 second.
What would the port number be? Let's see.
The database name is correct?
5, 4.
The database name?
Source underscore data.
Try that. Yeah.
Yeah, I think that's correct. Yeah. Just run this now.
Sean, I think that's the client port number? How did you get connected to the client?
We didn't have to specify the port number. It picked up automatically, friend.
No, if he's running on defaults, right? Some drivers don't do that.
Okay, okay. No, okay, so I think the course underscore data is not there. Can you go back to your browser to open up the tool? Yeah. So you have to create, just say create database course underscore data.
That's right. If I say databases, that's right there.
Oh, you already have that. Okay. That's correct. That's correct. So you already created the database. Let's go back and again run this and let me see what the error is. Go to Eclipse once. You've done everything correct. You don't have to do anything extra. Let's see what's happening. The password is correct, right?
Yep.
Okay. Let's have a look at the error once again. I'm trying to see what's wrong. Just scroll up. It's giving an error in line number 44 something. It says it does not exist. Course underscore data. Can you just go back?
What does this line do?
This is the table. This will create the table in the database. The database is on the top in DB connection URL, right? So that's the database name, course underscore data. You got it correct. So can we just go back to the browser of Postgre to see whether it, yeah, that's also correct. Yeah. Database is correct, course underscore data. Let's go back. Let's see one last time. Go back to Eclipse. Let me see if there is a spelling.
Sean, did you import all those jar files which were necessary?
I'm not seeing in folder.
Yeah, there's no reference.
The authors.csv, you don't have it. That's what she's saying.
Yeah.
Yeah, I do.
Yeah.
Okay.
Yeah.
Can you just clean and install it again? Probably it got changed something. Or maybe update the project. Or just clean and install, yeah.
Because it's giving a specific database error that course underscore data does not exist. So yeah, clean should be one.
Install. Just go to the project and do it. Don't do the POM. Go to the project, click on the artifact one and then do it.
Run as Maven install. Yeah.
Clean again?
No need, no need. Install
No
should be
need
okay.
to, yeah, just install it.
Yeah, the jar file should already be there because yesterday you have done it.
So it failed somewhere.
Yeah, that's fine. It's simply copying. It's not downloading.
Okay.
It's already downloaded, so just copying it. So it should be all set.
Okay, now just go to your main and then run as, main file and then run as.
This file, right click, run as.
Oh, like, sorry, on the left navigation. So yeah, over here. Just right click. Oops.
Go to the package explorer, close the type hierarchy. That's it.
Yeah, just click on here. Yeah. Run as a
Java application.
Java app.
It's a Java app?
Yes.
Okay, at the bottom it's showing that it is launching that. Okay. Not giving any error, so it looks to be good as of now. Let's see. No, wow. Just scroll up in the error, the same thing. It says database course underscore data does not exist. It's weird.
Error here. Can you check the host actually? Can you run this query?
Which query, Sharad?
I'm pasting it in.
It says error on the driver, connection error. Can you make sure your password is correct as well?
I have put in the page the chart. You can run that thing in Postgres and check the host name. If the host name is like localhost or something else.
Yeah, just select that. He's already put it in the chat window. Yeah, you'll paste it here. That's perfect. Yeah, click on the connection on the right hand.
Oh, so you
Just paste it, and on the top it is run. Just paste it. I don't know what happened.
I don't know what happened.
Yeah.
so
on
so
the
not
right,
from here, on the right, yeah.
on the right hand side there is an OK. The diamond kind of a icon. Scroll up, scroll up.
That's a Spark.
Yeah. That's what.
The Spark one.
Click on this. If you click it on the left hand side, it will open up a new window for you. It is localhost.
It is localhost. Okay. This one it is.
Wow. And this database name is okay. The simple thing is create a new database and give that and see. Over here only, create a new database. Create database. Let's say test. We can remove this.
I wonder if this is course data slash Postgres at local 10.
Yeah, that's correct. Why would this come? I have absolutely no clue. So this once again, let me just copy this. Hold on, friend. So just to be clear on that, paste. Right click, copy, paste. Okay. That's done. Move back to the screen. Can you just remove this contents from here?
I'm trying to.
Okay. That's okay. Click on SQL again. Oh, sorry, on the left hand side, that diamond arrow. So it will open up that for you. We want to create a new database, not this. On your left hand side, the same icon is there on the left also. Besides dashboard, after two icons. Oh, okay, you got it. So create database, temp. Yeah, let's run this. Yeah, perfect. And we'll change that to temp data, and then we'll come to know what the real reason is. Almost there. Okay, just go to on the left hand side databases, right click and say refresh. Yep, three is created. Yep, that's right. So now let's go back and change that to temp data and see in Eclipse, so that we know the error is at that or something else. I think the error is because of the connection error, because it's giving a driver error.
How
Let's
does it
see.
determine? Maybe, it could
Let's
be,
run this and see, so that we know that if it's a driver error, the error will still persist. Run this. You should really look out for a bigger machine, Sean.
you're telling me.
Wow. And Maki, I just need your help in letting me know how to convert our project into.
Okay, yeah, sure. So you had to just
One second, dear. 1 second, dear. I'll just share my. I'll just let him finish this.
What is
No,
this?
no, just say cancel. Select that CSV to relational and then do a right click and CSV to relational database.java. Right click and right click and then say run as Java application. Yeah. Yeah, it started. Let's see what's happening. If it still gives an error, I think you will have to change, look at the pom.xml to see that, or maybe your property is wrong.
Yes.
The
Is there a
password
way
is
to
wrong.
test the JDBC connection?
Was that Sean?
Is there a way to test the JDBC connection outside of Eclipse?
Outside of Eclipse, just frankly speaking, Java is a new beast. Almost 4 years I've not touched it, so frankly I don't remember, guys. Any way to test the JDBC connection outside of Eclipse, my dear?
No, this is the way we will connect with connect to Java with any other database. So this is a basic.
The good thing is not giving any error until now, but I don't know what it will do after some time.
You can go ahead and check the Postgres database, right? Like in the browser, what happened? Is there any data creator or something?
No, it should show process complete, right? Because he's got a sys out in line number 46. So it should at least show me that the process is complete. No, that's what I thought. It's giving an error in line number 44. That means, yeah, something is wrong. I think the this thing is wrong. Your connection error is there. But then, if you scroll down, see, that's weird. Why should it say the database is not existing?
Maybe because of port number. Should we give the port number here?
No need. It will pick up the default port number, right? So none of us
Yeah, but
gave. So
his port number is different from the default one. The port number of us is mine is different from his.
So that's surprising. So did you give a port number? Because I never gave a port number. It was not needed actually. By the way, what's the port number? Let him try with that once. So folks, what is the default port number for Postgre? Let me Google it out.
5432.
5432.
This one says 5433.
Okay, use that. opened it at the end of localhost.
Yeah.
No, it is
Oh.
5432, my dear. I don't know from where you got 32.
Yeah, see, I got, in my installation, I got 2 servers installed by mistake.
Okay.
I deleted one of them. Probably the one that was on 5432. So let's try this.
Okay, let's try this now.
Is this the way we give the port number there? It's not localhost port number, right? Okay. Okay.
No, after Postgre, I think the port number should come, and then ::/ localhost. This would take it as the port number of the system. Maybe. Just check once again. Yeah,
No,
he's
he has it
right.
right.
He's right.
Got
It
it.
should be localhost after that.
So while Sean does that, I have a question.
Yeah, please.
Well, everybody's silent anyway. How have you come across in your past experiences of somebody who's doing something that's processed in Spark but uploaded into Postgres or any other databases in a real world scenario?
No. Can you just repeat that, because I missed the part of it? Just repeat it here.
So the exercise that we are doing right now, which is basically take a file, process it, and then upload it into Postgres, right? Have you come
In the
across?
real world production, this will not happen at all, because we will upload it from Postgre into HDFS or put it into memory so that I can do the transformation on the data, and put it back into a database so that you can work on it. So the benefit of doing it like that would be that instead of working on Postgre for doing some transformations, people are seeing that with the volume being very high, it's better to do the joining of 2 columns, the others, and all those things can be done in Spark, which will be faster. That's what we have seen.
I was coming up from a really enterprise use case, right? Where, let's say, you have some database A, right?
Okay.
Which has a lot of data from different, let's say about 3-4 different databases. We use Spark to somehow make sense of that data, but then we have to export this data into something, a bigger database like Teradata, right? Would you recommend something like that on Spark?
See,
basically, mainly from a data warehouse perspective, I do understand the process of doing data warehouses on more Hadoop infrastructure and all that good stuff, but let's face the fact that not everybody is ready, and we probably will need some transition phase where the enterprise data warehouse team continues to do their job using their traditional RDBMS, right? At the same time, we don't want to be too slow too. Have you come across such use cases before?
Frankly speaking, no. In the banks, primarily what we have is, in some of the cases, what we did is they were using, which is the database that SAP has. They haven't changed it to the last 5 years. And shucks, I forgot the name of the, it's a pure relational database. And the last 6 years they haven't done it. So Citibank is doing that. So what they did is instead of doing the huge amount of transformations, etc., in my database, they moved that data from the database into Hadoop and into Spark. They did all the transformations what they have over there, and then they push the data back into that using Scoop, and so that the downstream people can go ahead and do that. So we don't use primarily the database for the transformation. So that's one use case what I have actually seen what's happening in the real world, Kalyan, but
So
not in the example what you said.
right. So what you just said, which is using Scoop, which is again a data extractor, right?
Right.
That's again a connector for you to pull data from the database.
That's correct.
Right? I'm not talking about that. Let's say you do use Scoop from 4 different databases.
Okay.
You have your transformations on Spark, and you have your actions on Spark. The actions will actually give you a value on that transformations, yes. And then I want to take that actions or the values from that actions and put it back in the database. But this at an enterprise level, is anybody doing it? Or have you come across something? Or would you recommend it in the first place?
First of all, I would recommend it, because now tell me, where is the source of the data coming from? You're saying that I will use Spark for the transformations and actions.
No. So I'm talking about, let's say team 4. There are 4 teams which have a totally different databases. And then there is a team 5 which has its aggregated database of all 1, 2, 3, 4, 5, or 1, 2, 3, 4. And then in between team 1 to 4 and 5, there is a Spark team, which is, I'll call it Spark team. And then that team transforms all the data, and put the job of that team, Spark team, is to put the data back into the database. And in that case, have you seen what are the performance impacts? What are the chances of Spark getting, or because Spark is extremely fast from what I've seen till now, will that crash the database? Because how often, what should be the optimization parameters, and how should we be going about it? Do you have any insights into those?
First of all, we use Spark. So primarily, let's look at one aspect. What is the purpose of Spark? Yes, I can connect to a database, I can load into it, but then the purpose of Spark is for the transformations. Whatever you're doing it at the SQL layer or do it at the RDD layer, do the transformations, turn the data into a different particular format, and then load it back into a database. So if that is done, Spark has done its work. So like what you mentioned, there are 4 databases that is there. I will take
so
the
in your use case, what you just said, right? In that aspect, right? In that aspect, were there any performance benchmarks on what should be the ideal way of doing things per se? Like,
okay, when you start out with this, when you're doing some new transformations, we really cannot have a performance benchmark, because that is something that we didn't have it done earlier. But then performance comes in the fact that it is not about how much time it takes or how you do it. It's about whether it crashes. Initially, when you start out with it, you feel that, okay, it is going on fine. We kept a initial benchmark, whatever time it took for the first time. That was the first details of the records that we had. When we started running it multiple times, then we saw how much time it took, if it crashes for some reason. So those are the performance benchmarks that JP typically uses to keep a stack of what we are doing and then continue with it. So people have been doing this kind of things wherein I was talking about Sybase. Okay, so I was giving an example, right? So even Citibank is completely moving out of Sybase because you don't have that used at all. So Sybase was a database where instead of doing it in Sybase, people felt it's better to take the data out of Sybase, using Spark, do the processing, do the transformations, what we're doing, and load the data back into Sybase. That will be faster than Sybase themselves doing the data. So that was the earlier question to which I was giving the answer. To your question, friend,
your
if you're
example
doing
actually
it,
fits my question.
Come back again.
Your example of Sybase out and Sybase backend fits my example. So my question was, what was the performance impacts on Sybase at that time?
No, there was not much of a performance impact because Sybase couldn't do that transformation at all. It was taking a really long time, and if you want the benchmark, I still remember it. It was taking about 3 hours for it to do that kind of transformations within Sybase itself. Of course, they were working on Sybase IQ.
I think we should move on. Looks like we'll chat later.
Okay, cool, no worries. So yeah, I'm there on my screen. So I just need your help on just one second. Let's see two questions. Yeah. So let's take your help. Let's see how to move this. This is a pure Java example. How do I convert this?
Right click on it.
Yep.
And go to configure.
Yep.
And then convert to Maven project.
Great, fantastic. Okay. I will just say finish. Okay.
And then you can copy example 18 pom.xml to the pom.xml here.
That's it. That's fantastic. This solves my thing.
But you have to copy the pom.xml from 18.
Yeah, I'll do that. What was this? There should be some.
This is the pom.xml generates, right?
Okay. So
it has the basic information, but you need to copy pom.xml from 18 to 19.
That's correct.
No. You should not delete, right?
No, I don't delete. No issues on that. Because there wouldn't be any dependency as well. Of course, you're right. The projects and all those things I have to be careful. But then if I simply take it up in this way and then put it over here, that should be all okay, friend.
Yeah.
Let's go back. So this is 18 is done. I've got my data, everything. Let's close this. And now you're saying that I can do a...
This is building, so you have to wait a little bit.
That's correct. Yeah. So this thing is happening. Let it continue. I think it's finished. So right click, Maven, update my project. Okay. It's updating the Maven project. It's giving me some error here. That's it. The error went away. Yeah, that's fine. Now I will do right click, run as Maven clean. That's also done. Yeah, and now I will do run as Maven install. Because I've already done it earlier, so it should not be a challenge. Same thing that was happening on Sean's machine.
You can remove the reference libraries if it is giving you trouble, like you have loaded it. So if you really want to remove it, you can do
No, this will happen fast because it is picking up from the repository itself. It's not downloading this actually. So you can see that it's actually doing it. It's not downloading it. It's just picking up from the repository. So just maybe another 30 seconds. This should be done. And then let me run this. And I have created a new folder called, a new project name called as project 3. That's where this should happen. Let's go back to this. So this was nice. This was interesting. Right click, configure, and then convert it into that project. Okay, that was nice. Okay, so once this is done, I should see that. So others, all of you would have seen that coming for you in the PG admin, right? The table that we created. So I should see project 3 coming in right now. Let's go back. Sorry. Once again, you're saying that I can remove some dependency libraries. What was that, friend?
No, that is reference libraries. You already loaded it, so you can in your build path, from your build path, you can take it off. But if it gives something issue on for you, if you face some issues, because after JP, you are seeing the reference libraries, right? If you click on it, you whatever you have added in the build path, it will be there in the reference. No,
reference libraries. Okay.
Yeah, you can right click and remove it from the build path.
All the contents.
Yeah,
that's right. Yeah, got it, got it. So
Not
it was
even
no need for it. Right click, toolbar. Yeah.
no, you can from
Okay.
here itself you can right click on reference libraries and remove. That's okay.
This one, right? This is what you're
Yes.
saying, right? Okay.
Yes.
So there we go. I'll say remove.
Yeah. Okay.
I'll say okay. Setting
Oh.
the toolbar.
Together everything will build. We'll wait for it.
Yeah. So once you run this, this is what you should see, friend. So the focus of the context for what we were doing is to see how does it create the database and then make it work. So if you just want to summarize what we have done till now, so that we can see what we did today, and so that we know what are the things that we learned. So today we started off with our first one, that was our accumulators. We did 2 examples of the accumulators. Then we did our broadcast variables. Then we did our third one, that was cache and persist, caching and persisting the data. So this was the 3 advanced Spark SQL that we saw today. Then we did the examples of joins. And after that, we went ahead with the theory part of RDD versus data frame versus data set. So you really would need to look at what are the differences, etc. And then saw 3 examples of creating tables in PostgreDB. So that's what we will be seeing today. For tomorrow, we will go ahead, and the focus for tomorrow would be on the Postgre database, try to see the various, the way how the various SQL options will work. And we also would look at the way how the data frame or the data set, we are talking about the data set right now because we are in Java. So let me remove the data frame word, how the data set operations would work, And I have to just see if I can directly pass my, I can set my data set dot, I can try with SQL context.sql and then run the SQL query over here. The way how we go ahead with the SQL query and then run with this. So these are the various options that we will be seeing tomorrow. Everything about the SQL part of it should be done. And towards the end of the day, we will start with Spark streaming. Okay, how do we go ahead with Spark streaming? So ideally what we do is we do it in our Python and Scala to say how does that work. But then since we're going to go ahead with Java, we will be talking about, there's no interactive mode at all. So we will be talking about this, and either tomorrow or day after tomorrow, we will talk about Zeppelin. So Zeppelin is the default data store for Spark SQL. So we will talk about what is Zeppelin and how does this work. Unfortunately, till Java 8, we don't have any of the notebooks that is there for Java. And on the last day, we will focus on what is the ML part of it, what are the various machine learning libraries, what you'll be having, and then seeing an example of our graphics, the way how graphics-based computing would happen. And then one of our colleagues had mentioned that he wanted to know about the best practices for setting up an environment, So that is what we will be talking. And then what I was told is that to give a project, a complete end-to-end project, so that whatever you have learned, you'll be able to work with those things so that you'll be able to apply these rules on some end-to-end project. So this is what I was told, friend. So these are the things that we will be seeing to see how things would happen, friend. So now to just check if everything is done at my end. Very good. 30 MB, everything is done. Now I can go down over here and I can say run as, hold on. Let me select my, where is my file? This. I should say, okay,
Oh,
it's
it's
the
not built.
the
No, it's
application.
not built. No, it won't run, right? This won't run. Oh God.
That's weird because I thought that you're saying that the complete folder did not get created. Is that what you're saying?
Yeah. The folder structure is not good.
Yeah,
Try
that's right,
running
because
that.
it should come like this.
That's okay. You can just try running it.
Just try it.
Let me just go back and see if there was right click, run as Java application. That's
Yeah.
weird. That's okay. So I'll just try to create this. Just give me another 2 minutes.
If you just remove the package, that should probably work.
Okay. But then I thought it should
No.
keep it like
Create
this,
a
right?
pack. Yeah, that's true. That's because when you built it as a Maven project, if you go to your com.xml, maybe the source is cut.
Make it a source folder. Actually, right click.
Right click on what, Sharat?
On
The
example,
project itself, yeah.
Okay.
example 9.
What do you
Example.
want me to do once I right click?
The project, example 9 project. Can you right click on that one? Example 9, 19.
Okay.
Right click.
Okay.
Right click.
Properties.
Properties, yeah.
Sources. Source. On the right, the first tab. On the right, the first tab.
Yeah, add folder. SRC.
Say okay.
Yeah.
Okay.
That should do it.
Apply. Yeah. Okay. Yeah. Apply.
Okay.
Now you should see.
That's okay. Let me try running this.
Sir.
Run as Java application. Yeah, this should be running. That's good.
Did not change the existing POM, just to have copied the other one, maybe that might work. Yeah, you copied
Yeah, that's
the
it. Yeah, he just created that, and that's okay. So once this is finished, I can go back over here and I should see a new project coming in. So let me just refresh this. Right click. Maybe it will take some time, but yeah, it's already done. See, project 3 is created. So let me say select start from project 3 and let me run this. Yeah, there we go. You saw how the answer came in, friend. So that's perfect. So this is what was the objective of what we were doing. In fact, this is terminated. That's correct. But I thought that I put some sysout at the end, right? No, I didn't do that. Okay. So that's what this actually got terminated. So that means the project is done. So for all the others, this is what needs to be done. I think only for you, Brandon, we will have to set up the component to see where we are and how to set it up, guys. So for the others, this is done. So tomorrow we'll be working on these things a little bit more. And just one thing I remembered right now, they also wanted me to show you an example of connectivity with Mongo. So
Actually, sorry to. So this is Brandon. You're referring to the setup of my Postgre. Everything is okay for me. I finished all the up to that last exercise.
okay, that's great. So then that's also you're done. So almost all of you have done that. So that's perfect, friend. So they wanted to show the connectivity to Mongo and how to insert some values. So when I asked them for the version of Mongo that they're using, so they were not able to answer that. So I think you are using it, Sharat. So which version of Mongo are you using right now?
I'm not using Mongo. I'm using Cassandra.
Oh, sorry, using Cassandra.
Akil is using Mongo.
Akil must be using.
Brandon might be. I don't know.
So guys, anybody using MongoDB? If you can tell me which version of MongoDB you're using.
Venkat is using. Venkat.
Yeah, yes, Sarat.
What version of Mongo you guys are using?
So we are using the Cosmos MongoDB, right? It's not a direct one. We just use that.
Yeah, it's a
Also,
Microsoft service.
yeah.
But does it have any version number? The back.
I think it's a 3.4 something. Yeah.
Okay, 3.4.
Okay. So you're using Cosmos Mongo. I think it is a part of the Microsoft way of doing things, right? One of you said that right now.
Yeah, it's actually the Cosmos has drivers. I mean, the front end Cosmos manages MongoDB. So
okay.
But again, that Cosmos implementation of Mongo, it's not exact Mongo. So it's really port which Microsoft did. So we already learned what there is no like direct mapping between all features of Mongo to particular Cosmos Mongo. So it's very specific to Microsoft implementation.
Okay.
Wow. So what I'll do is I'll just show how the default connectivity from Spark would be there, like the way how we created it on Postgre. I'll just show that how we can set up our Mongo if it is already there, and then how to go ahead, because I don't know why if not everybody is using it. What I was told was that that is going to be one of the implementations that will come up. So they wanted to cover up this particular aspect. And then, of course, in the Kafka, they wanted to see how the different utilities are running. So just wanted to check with you, Sharat, is Kafka also being used, or you're planning to use Kafka?
Yeah, we are using Kafka. And all the other teams also started using Kafka, actually. So yeah, it is there. I have a question after you finish everything.
Okay. So no, I think that would be the question what I wanted. So this covers up the things that we will be doing. So tomorrow would be primarily focusing on Postgre. Looks like everybody has done that. So I think that will be it for today, friends. So I'll show you another example for tomorrow.
The question I wanted to ask was like, are you going to show us MLib machine learning exercises also, right?
Yes, we will be having an exercise on ML also. So I'll be just showing you how to do the basic way of inserting your data into that. So they said that give about 1 or 2 examples in ML and 2 small examples in graphics also, because the focus was primarily on understanding what is the Spark core. So that's why we took about 2 days in trying to cover that. Spark SQL, that's what we just started with it today, and then tomorrow. And then streaming, they wanted to cover the way how Java connects to the different sources, and then small examples on the ML and the graphics also. So we will be doing that, Sharat, for the ML and the graphics also.
Okay, thank you.
Good.
Also, Kafka, right? You will be giving us some introduction, or something you will be talking about Kafka as well.
Yeah, the Kafka is going to be a 3-day session that they have discussed. So that will be done on 28, 29, and 30. So in that, what? Yeah.
No, in this session also, I saw somewhere like Costco. Sorry, what is it? Kafka. Okay, let me check.
No, that's what one of them had said, that there will be something of Kafka, but then from my perspective, there was no Kafka involved in this at all. Kafka is a completely separate course for 3 days. So I don't know whether it is you folks or some other folks.
You talked about Kafka in the streaming topic, right? In the introduction, you mentioned that streaming near lifetime.
Yeah, that's it. See here. So tomorrow we'll be starting with Spark streaming.
Okay, good.
Yeah, so that will be there. The Kafka would not be a part of it. So let me just tell the team also to see, some people have got that Kafka would also be covered, but Kafka is actually going to be a 3-day thing that they are going to talk about. So not sure, would anybody be a part of that Kafka training also, or would it be a completely new team who will be coming in, friends?
Mostly.
Mostly new people, but I think there must be 1 or 2 going to Kafka also from this one, I think.
Okay. So that's fine, because again, getting the information from your side, from the team, was a little bit of a challenge for me, because I wanted to know who all would be there, what should be done. So nothing was told to me other than on the first day when I came, and when I discussed with the people, then I came to know who the participants are, because that information was also not shared. What is the level of the participants? What are they expecting? Nothing was shared with us, So there was a big gap in that. We asked 3 or 4 times, and then it was complete stop still. So at least for day after tomorrow, if you come to know what is the skill set of the audience, that will help us a little bit in seeing what they want and try to customize it also.
Yeah, really, Venkat, I do see the who participants from us for Kafka. Most of them are our tech leads, so it would be pretty, and some of them really using Kafka already. So I know what Suzanne, for example, who will participate, will use Kafka already for our product catalog choice. So she's pretty experienced here.
Okay. Now, when you say Kafka, how are you going to go ahead with it? Are you working with a Confluent Kafka right now, or you're looking at the vanilla Kafka? Which version of Kafka are you using right now?
Confluent Kafka.
Yeah.
No, see, there's an open source version of Kafka, and then there is a Confluent Kafka also.
Yeah, Confluent Kafka.
Yeah, we are using Confluent one.
Okay, okay. So that's again something that we will have to just look up and see how things would be, because they wanted to work with it. So there is they wanted to work with the vanilla version and then also talk about Confluent to see how the schema registry would be there. So good. So I'll just check it up with them to find out how the things would be happening. So let me go back and check with them. Sean, you had a question, dear? You raised your hand.
Was it supposed to create a table called Project 1?
Right.
Okay, because your screen said Project 3, and I'm like, I don't have a Project 3.
No. I had already had Project 1 and 2.
Yeah,
That's the reason I created Project 3.
I know.
Here. See here.
I'm just catching
Okay.
up. So I think I got.
It's working for you now?
Yeah, it's just weird that my console is all red, but everything seems to work.
Okay. So we have to just check what is wrong and why would that happen. So just check that out. But otherwise, if it's good, that's fine. But are you able to see this like this? When you go down to PG admin and do a select star, are you able to see the outputs?
Yes.
Yeah, that's fantastic. Because last time we were not able to see that at your side also. So that's good. So that is running, because we'll be using this extensively tomorrow, because to see the SQL way how that would work. So that's what we will be seeing tomorrow. Yeah, so just to continue with the discussion with who was it? The Igor. So what was told to me is that you'll be, they want to see how to work with the vanilla Kafka, and Confluent, they want to do the Avro schema, the way how the schema changes would happen. And that is what they wanted to see that. And they wanted to do that using Scala as a language. So just let me know, the tech leads, are they working, which language are they working on? Are they working on Java or are they working on Scala?
Mostly Java.
Mostly Java. Yep.
Okay. But then I've got no clue why they said that they wanted the Avro version to be shown on Scala also. So that's something that I was preparing. So because if I know what the requirements are, it will help me a lot to see how things would be. But let me just try once again to talk to them and see what can happen, friend. Okay, so I think that will be it for today, friends. So we saw the different examples in the use cases. So we will stop it over here. And tomorrow we will continue on with our Postgre and the SQL part of it. And towards the end of the day, move on to your Spark streaming and try to cover up Zeppelin also. So that on the last day, we can focus on the ML part, the graphics part, of course, the best practices, and then trying to connect to the basic Mongo. Because if Cosmos is a specific implementation, I wouldn't know about that. So we typically work with Edgebase. So in the projects with both the banks, with the Citibank and with Deutsche Bank, they work with Edgebase as a tool, which is a NoSQL product. They really don't work with the other tools like Mongo or Cassandra. They work with Edgebase only. So this is a little bit new for me, but still I have got a way how you can connect to it. So that's something that I'll show it to you, friends. So thanks for your time, guys. So let's close it out over here and see you tomorrow in the morning with a new set of stuff. All the examples, what we have done today, I will be just zipping it up and sharing that with you, friends. So thank you. God bless and take care.
Thank you.
Thank you.
You're welcome. Bye-bye.
Thank you. Bye.
Yeah, sure. Sharat, you had a question, or that was the old hand that was raised, Sharat?
Yeah, that was the old one.
That's okay. Yeah.
And
So
if possible, Venkat, is it possible to get that cache code that you were talking about? Um, I mean, even in Scala, it's fine. I just wanted to see that code part. Uh,
this is the code, my dear. Just once again, Sharat. So let me just scroll up. No, it was in my document. Okay, so what happens over here is that in the Scala code, once we call it as a cache and then use some other variables to use this, and they will be able to work with it directly. So what confused me was that when you said that we are having in Java, when we are having separate implementations at the JRE level, you said that you'll be using it. So not very sure whether it will be the same JRE or it will be a different instance that will be there. But in Scala, once we do it something like this, I can use this small rdd.cache everywhere in the code. So I will create that example for you. In fact, I'll just look at my repository to see what we have done for the project. And tomorrow I should be able to show that to you, Sarah. So that at least the way how we have used it, I can show it to you, friend.
what I was saying was, here you're doing like val small rdd equal to sc dot parallelize all these things, right? So are you going to do the same thing in the other file also, another job? Are we going to do the same parallelize list, all that thing, or just use small rdd dot cache?
No, I'll directly use the small rdd.cache.
Then it's not going to compile, right? How do we declare? You have to declare, right? Val or var, something like that.
See, what would happen is that once you're caching it, if it is there in a particular scope, okay, it is going to be, when I cache it, it is going to be there on the system. Like how did we do our broadcast variables, right? So something was put into a cache, right? So I might close my current Spark session, but then it is already cached. And once it is cached, I can assign it from the small rdd.cache. I can assign it to something else. So I can do it like this: ABC is equal to so and so, and then I will continue with the code. That's what I was saying, Sharad.
No, actually, you still didn't get what I am saying. Actually, I think two programs we are talking about.
Yes,
right?
yes.
Two separate programs. How do we, compile without declaring a variable called small rdd in another program? It's totally entirely different program, which is another job. And rdd, you are caching it here. I want to use that cache in the other program. So it's totally different independent jobs. So how do I refer that small rdd in the another program, another job?
Got your point, because you're thinking from in two separate. Let me put it in the Java perspective.
We need to generate jars, right? Two jars, right? Two jars. So how do we generate the second jar without declaring a variable called small rdd? Are we going to get from some context or something? I was talking about that. See, when you say small dot cache, small rdd dot cache, you have a variable already declared over here. In the other program, how do we declare that?
See, friend, the same name I have kept it for it, right? See here, there is RDD name, right?
Yeah. Can you show like two programs instead, writing one program I saw. Can you write another program using the same small RDD, so that I'll understand instead of explaining?
Definitely, that's what I will be doing it, Sharat. So I'll just write a small program to show it in this particular way, a completely different program. But then I am thinking, how do I show this without creating a separate cluster? Okay, because you wanted a separate program to be there. So what would happen is, since this is there in the REPL mode, what we are doing, if I close my REPL mode, this particular window will go away, right? That means the 4040 will be stopped, right?
What I was trying to say. Only when there is in one session only you can do all that thing, because you are sharing the session. See, in different programs, when you non-REPL mode, I don't know how I'm going to access that cache. That's what I'm trying to say.
Got your point, Sharat, but then you can do it, my dear. So that's what I'm going to try to see how I can show that example. It is, see, friend.
If you have the code, right, for the second one, I would understand. I can understand easily actually. If you have,
Let me try getting that. So all that I was saying, Sharat, is we are having your Spark running in a cluster mode. That means there will be multiple jobs that will be running over there, right? So that doesn't mean that once a cache RDD, it can be used only in that job. The other job should also be
yeah,
able to get that RDD,
I
right?
agree. I agreed actually. I agreed that fact. But how I write it, I'm not understanding how I write the another program.
Okay, okay.
How I
So,
can,
so give me time till tomorrow, my dear. I
yeah,
just need to look at
yes.
my other
I agree with
repository.
you. I agree the concept. It is being shared and everything. I totally agree with that.
Right,
There is
right,
no doubt about it. I
right,
already said so many times. But the only thing I could not understand is how I can access that cache that I have already prepared in another job. How I
right.
can access in another job. Is there? I mean, there must be some programming construct that
Exactly. So
allows us to get the cache.
that's correct.
That is what I'm trying to ask actually.
That's correct. So I think I will have to just look at that. We will not say the same RDD. So I have to just look at this because frankly speaking, I don't recollect also how I had used it. But then using your Spark context and getting that object, you'll be getting the handle of that. It need not be this name, but then whatever name it is, then
Yes,
you'll be getting a handle of it and you'll be using it. So
exactly.
if you can,
When you're doing set name there, right? When
right?
you're doing dot set name, probably
Mhm.
that is the name under which it is putting that cache actually.
That's
So
correct.
probably
Because see here,
in
that is the
context,
name how it is used.
yeah, in Spark context, somehow I think you are getting that cache using that name. I wanted to know only that statement. I have been asking only for that statement how you get it back. I understood what you were saying. I totally understand. It will be there, available for all the jobs. No worries, and we don't create any session. We just get the session that is existing. I totally
Right.
understand the whole thing. Only that programming construct that in the second program, how I can access that. That's what I.
Got it, friend. So just give me time till tomorrow, friend. So tomorrow definitely I'll see if I can get hold of the list and see how they are actually doing it, friend.
No,
I'll
no,
definitely do it for you tomorrow because I have done it. That's the reason I'm so dead sure that it is possible. So I have to just look at the way they have done it. And what you're saying is also I got because these are two separate entities. So how do you get it? Like what we saw in our sequel, right? Get or create, right? So I think they have kept it into an object and you have to just see the syntax for doing it. So just wait till tomorrow, friend, and I'll show that to you, friend.
sure.
That's my word with you.
No worries, no worries.
Yeah,
Thanks.
yeah. It is actually done. It's only that we have to just see how that is done and show that to you. So I'll just go through the repository and see how that is actually done, friend. We have actually done it because take this concept, friend. If you're putting it in an enterprise mode, you will have multiple applications running, right, Sharat?
That's true.
So it is not within one mode. Here we are running it as a standalone. So I fully agree with the question what you are saying, but when you are having it as a clustered environment, when you are having it as 25 node cluster, that means even though one job got finished, the Spark context will not get killed, right? It'll still be available. So using that object, you'll be still be able to get hold of that particular RDD.
Yeah,
So let me come back to you with the exact syntax so that should solve that out, friend.
sure, Venkat. Another thing, Venkat,
Mhm.
I'm really interested in that MLib, examples actually,
Right,
Spark, machine learning.
right.
So if you can get different kinds of examples, that would be really great actually. So I just wanted to mention that.
Yeah, yeah, sure. So I have got some of the examples, and what I can do is that the other examples will be in the form of a RAR file. I'll share the source code for that, and whatever examples is possible that we have, they're showing in the class, we will see all of that. The other examples, I'll give you the source code file. You can actually go ahead and compile it, and you can run it. Should not be a challenge. I can definitely do that for you, dear. No worries.
Like a classification, regression, and clustering and all that
Yes. So,
okay.
so based on whether it is, there are 3 separate sections of libraries what we will have, reinforcement learning. So we'll be talking about each one of those things. So I have got a complete list of the different examples that what is given in that. So I will share the complete list with you. You can have a look at it. You can try that example. But in the session, I think we'll be covering about 3, 2 is what they said minimum. I'll try to cover up 3 examples so that you'll understand how that would work. So I'll share the
Okay.
whole thing with you. No worries on it, friend.
Awesome. Thank you so much. Thank you.
You're welcome, friend. So that's it. I think it's only 3 of us over here. So that's okay. Hey, even Vishwanath is there. So all good till now, Vishwanath? Or maybe you stepped out? I think he stepped out. So no worries, Sharad. So see you tomorrow and I'll share that example with you, dear. Okay?
All right. Yeah.
Sure.
Bye-bye.
Thank you.